Welcome back. Before we take things to the absolute next level today, I need to stop and say a massive heartfelt thank you to all of you. Our SnowPro Core COFC03 tutorial did not just become YouTube's first ever complete 7-hour course, it also became a launchpad. To every single one of you who dropped a comment, shared the video, and most importantly, to everyone who commented, I passed after watching it, huge congratulations. You did that. Your support is the reason I do this. But you did not stop there. You asked for next steps, and for the last 3+ months, I have poured my absolute heart and soul into building what comes next. No shortcuts, no fluffs. Welcome to the ultimate comprehensive tutorial for the ARA-C01 SnowPro Advanced Architect Certification. The Advanced Architect exam is not about memorizing definitions, it's about designing elite scalable data architecture. This is the syllabus provided by Snowflake for Advanced Architect exam. Here, the official blueprint breaks down into 4 massive pillars that we are going to master together in this guide. They had divided the architect subject area into 4 domains: accounts and security, Snowflake architecture, data engineering, and performance optimization. And they had also mentioned the weightage on exam domain by domain. We will be covering each and every topic. As you can see, I had literally covered each and every topic. So I had highlighted the topics which I had covered one by one. So as I was hitting the videos step by step, I was literally highlighting all the concepts as early as I was creating the video. So it should not be like that I am missing the topic. That's why you can see everything in yellow, and I had literally covered all the domains and all the chapters inside that. I had highlighted my domains lesson into 2 colors. First is yellow color and second is green color. Green color indicates that these concepts are already covered in somewhere above, so that's why it is green, and yellow means that these concepts are covered in the current domain only. If you are ready to transition from a Snowflake user to a certified Snowflake architect, grab your coffee, open up your console, and let's turn this data into dollars. Let's get started. Let's begin with lesson 1.1, design a Snowflake account and database strategy based on business requirements. The first topic we will be covering is that how we can create and configure Snowflake parameters based on central account and any additional accounts. And we will be covering all the 3 kind of parameters, and we will also be looking in depth on the parameter hierarchy and the relationships between the parameter types. Let's dive in and let's understand parameters in Snowflake. Very simple words. In Snowflake, parameters allow you to control everything from session timeouts to how data is formatted. Snowflake provides you certain set of parameters to let you control the behavior of Snowflake account, individual sessions or objects. These parameters are always set up with standard default value while you code new account provisioned, but you can always change them as per your business needs. In Snowflake, we have 3 different type of parameters that are account parameters, session parameters, and object parameters. So now we know that we have 3 kind of parameters: account parameters, session parameters, and object parameters. Let's deep dive and understand each of them one by one. And let's start with account parameters. These define the global behavior of your Snowflake instance. Example, time zone sets the default time for the account, or data retention time in days that sets the default time travel period. Account level parameter is the highest level of parameter in the hierarchy and affects all the Snowflake accounts. These parameters are set at account level. If you are using a role that have been granted the privilege to set the parameter, to set an account parameter, you can run alter account command. Next up is session parameters. These control how the current user interaction behaves. Most account parameters can also be set at session level. Example, the query tag that adds a string to metadata to track post or date input formats. Session level parameters generally set by user and pertain to their user session only. These parameters can be set at account level but can be overridden at user session level for that user. Same parameter can be differently set per user for the same account, like date format can be differently set for each geographical aligned users. Session parameters can be modified by both account admin or sysadmin role for a user. If nothing is set at a session or a user level, it inherits the value from what is set at account level. Most parameters are session level parameters. Very important to note, guys. Third one is object parameters. These are specific to the heavy lifters of Snowflake. These consist of warehouse parameters or database, schema or table parameters. So warehouse parameters are something which is helpful for control, scaling and suspension. Example, auto suspend or max concurrency level. And the database, schema and table parameters usually related to data retention and protection. Example, data retention time in days or max data retention time in days. Object type parameters can be set at account or object level. These parameters are applicable to Snowflake objects like warehouses and databases. Warehouses don't follow any hierarchy, so warehouse specific parameters can be set at account level and then modified for individual warehouses. Unlike warehouse, database do have hierarchy, like database is the highest in the hierarchy, then schemas, then objects. Database parameter can be set at account level and then can be modified at a database level or schema level or at object level. Value set at the lowest level is honored if it's set at all the levels. Now, as we know all the three type of parameters in Snowflake, let's outline the Snowflake parameter hierarchy and the relationships between the parameter types. Snowflake parameters are organized in a top-down structure. If a parameter is set at a multiple levels, the lowest level in the hierarchy, which is closest to the specific session or object, takes the precedence. Parameter hierarchy consists of 4 levels: account level, user level, session level, and object level. If we talk about account level, this is the highest level. Settings here apply to the entire Snowflake account and all its users and objects by default. User level parameters are applied to the specific user. These override account level settings wherever that specific user is logged in. Object level parameters consist of warehouse, databases, or users. You can set specific parameters for individual warehouses or databases or users. For example, a marketing warehouse might have a shorter auto suspend time than a data science warehouse. Further, database have a hierarchy like databases, schemas, and objects. Database parameter can be set at account level and then can be modified at database level or schema level or object level. Value set at the lowest level is honored if it's set at all level. The major conclusion, if I have to say, for parameter hierarchy is whatever is set at the very lowest level always gets the highest priority, and that will only be something which Snowflake considers as the value. We have values at account level by default, but if I am having a value at session level, Snowflake will override my account level value with my session level value. Let's come up to the session level. This is the lowest and most specific level. Any parameter set during an active SQL session using alter session overrides everything else for the duration of that connection. This is the complete parameter hierarchy of Snowflake, guys. Okay, let's now go to Snowflake and understand how we can see parameters. I am on my Snowflake now. The first command I am going to show you is show parameters. Okay, and if I run this command, you will see there are 153 parameters returned by this query. Correct? By default, show parameters displays only session parameters. Okay, but now if you want to see object parameters, okay, to display the object parameters for a specific object, just include the in clause with the object type and name. Okay, let me show you. For example, you can say show parameters and then include the in clause and whatever the object type or name you want to see. Let's say I want to see for database, I will say database, and I will mention the database name, let's say Snowflake sample data, and now I will hit run, and I am able to see the object parameters related to my database. There are 34 object parameters as you can see. Similarly, we can see the parameters for warehouse as well. I will just copy paste this command, and I will just say instead of database, I will say warehouse, and I will mention my warehouse name, which is compute warehouse. And I will hit run, and this is how I can see the object level parameters associated with the warehouse. Make sense? Okay, now if you want to display all the parameters, including your account or object parameters, then just include the in command, and after that just mention the account. In this way, you can see all the parameters which I am having inside my Snowflake account. You can even specify the like clause to limit the list of parameters by name. For example, you are just looking for those parameters which have a word called time. So you can say show parameters, and then you can say like, and then maybe you can just use this wildcard as time, and you can run this. And see guys, this is how you can even filter based on the specific parameter names. Okay, that's how we can see parameters in Snowflake. Cool. Sir, there are a lot of parameters I had seen in account level. If you just rerun my account parameter query, I am able to see 267 parameters. I can't remember them all. There is no way that I can remember them all for this Snowflake Advanced Architect. Okay, guys, I know you can't remember this. Even I don't remember everything. But the good news is we really don't need to remember all of these parameters. There are 14 widely used parameters which you should know. Okay, I will show you, but you should know these 14 parameters at least for sure. Okay, and that's it, guys. There is nothing more than that. I am back on my PPT. Now I will show you those 14 important parameters which you should definitely remember. And these 14 parameters are very, very handy. Either you are an admin person or you are someone who is having a higher role and you want to see some more detailed view. These 14 parameters are really, really non-negotiable, guys. The first parameter is abort detached query. Okay, this parameter is session level parameter but can be set for account or user. By setting this parameter true or false, you can tell Snowflake to whether to abort the in-progress queries if the connection is lost due to abrupt terminal of a session in case of true value set for parameter, and vice versa. Okay, this is very important to note. By default, false value is set for this parameter, which means the query will continue to run even if the client connection is dropped. Now, where this parameter can be useful is the case where you have human errors, which might keep running long queries and then close the connection. If this parameter is set to false, then that long running query might charge you handsome amount of credits. So you can set this parameter for your human error. And it is highly recommended to set this parameter, because if your colleague just ran a query and he just closed the window and the query is a long running query and it just keep on running in background, it will eventually cost you a lot of credits, which you obviously don't want. Okay, so you should set this parameter as true. Default is false, but you can set this as true. Okay, the same can be left false for your service account or application connectivity, which run heavy processes on backgrounds and needs the query to be run. Make sense? Okay, the script for this is alter session set abort detached query equal to true. I had mentioned the curly braces, so this indicates the dynamic passing of this one. So in the real query, you, instead of curly braces, you need to mention abort detached query, and you can run this query in your Snowflake and it will be implemented right away. Next one is allow client MFA caching and allow token ID. These two are very, very handy, and these specifies whether an MFA token can be saved in the client side operating system key store to promote continuous secure connectivity without users needing to respond to an MFA prompt to to start of the each connection attempt to Snowflake. If it is set to true, it stores an MFA token in the client-side operating system key store to enable the client application to use the MFA token whenever a new connection is established. While true, users are not prompted to respond to additional MFA prompts. Okay, but the default is false. So false do not store an MFA token. Users must respond to an MFA prompt whenever the client application establish a new connection with the Snowflake. Okay, and default is false. This is something which is important to know. And the script to set this parameter is very similar to abort detached query, which is alter session set allow client MFA cache or allow ID token is equal to true. Okay, next up is binary input format and binary output format. The binary input format is the format of varchar values passed as input to varchar to binary conversion functions. Okay, and the binary output format is the reverse of this, which is returned as output by binary to varchar conversion functions. Okay, default is hex. Okay, and if you want to set this parameter, you can set that on either account level or user level or session level. The alter script for this is alter account or user or Snowflake set this parameter is equal to whatever you want, hex or UTF-8. The fourth one is data retention time in days. The very important one. Okay, this is one of the most important parameters in Snowflake, which derives the time travel. Okay, this parameter tells Snowflake how long should it keep historical data available so users can go back to a specific point in time in their data. You should take a note of this, guys. This is non-negotiable one again. This parameter can be set at account level, in which case it will be applied to all the underlying hierarchy via database or schema or tables. This parameter can also be set at object level, in which case it will be applied to the respective objects, either database or schema or tables. And for standard addition, this value can be set to 0 or 1, and for enterprise addition or above additions like business critical or VPS, this can be set to 0 to 90. The default value for this parameter is set to 1, which can be increased or decreased based on addition you are. Setting the value to 0 means you want to disable the time travel for your account or object. The alter script for this will be alter table my table set data retention time in days is equal to the number of days you want to retain your data. The similar parameter and his brother is max data extension time in days. This parameter is for object level. Okay, but it can be set at a count level as well. Okay, this parameter tells Snowflake how long Snowflake can extend the data retention period for a table to prevent the stream on the table from becoming stale. This is the main difference, guys. Data retention time in days is a parameter which derives the time travel, but maximum data retention time in days is useful to prevent the streams on the table from becoming stale. Okay, wherever I have very important thing to say, I had marked that as yellow and you should know that. Cool. By default, the value of this parameter can be set at 14 days, which means even if your data retention time in days parameter for a table is set for less than 14 days, and if the stream is not consumed, Snowflake will temporarily extend this period to the stream's offset up to a maximum of 14 days, regardless of the Snowflake addition for your account. This parameter again can be set at account level, in which case it will be applied to all the underlying hierarchy via database or schema or tables. And again, this parameter we can also set on object level, in which case it will be applied to the respective objects, either databases or schemas or tables. Okay, the alter script for this is alter table my table name set max data extension time in days is equal to whatever day you want to specify up to 14 days. It's up to your business requirements. The sixth one is auto commit. It is very optional one. Okay, and it depends from systems to systems. Okay, but you should know this, so I will explain you. This parameter is a session level parameter but can be set at account or user level as well. The default value for this parameter is true, which means auto commit is already enabled. That's why I said it's optional for you to remember, but you should know that there is an auto commit parameter. If you want to disable it, what you will do, right? You should know this, right? So the default value of this parameter is true. And for Snowflake, okay, this is very important to note. Okay, every database has their own behavior. If you had worked on Oracle, then you would have seen that we have to write commit after any DML statement, which shows that auto commit is disabled by default in Oracle. But in Snowflake, it is enabled by default. You can disable it, but it is not recommended. But you should know this. To be frank, it is a matter of choice how you prefer your application should behave. Okay, this parameter gives you opportunity if you want to change the default behavior. If you want, this is more relevant when you are migrating from on-premise databases like Oracle and your code is designed with explicit commit and you don't need auto commit enable, else it may break your application behaviors. Okay, the alter script for this will be alter session or user set auto commit is equal to false, and that's it. Next up is date output format. This parameter is session level parameter, but you can again set this for user or account level. This parameter is used to decide what will be the date format. By default, Snowflake use YYYYMMDD date format. Suppose you have a report which need date format as per reporting country for any business reason. Okay, this parameter can be useful by having date output format set for that session to that country specific and generate the report. Okay, the alter script for this is alter session set date output format is equal to any relevant format required for your business use cases. Eighth one is query tag. This is very important, guys. If you are working as an admin or if you are working as a senior DBA person in your team, this again is non-negotiable. This parameter is a session level parameter, but again can be set at user or account level. Had you noticed one thing, guys? Whatever parameters we are understanding, most of the parameters are session level parameters, right? But we can obviously override and set them for account or user level, and this is again one of them. Query tag. Okay, this is optional query tag, but yet very powerful tool when it comes to trace back any support activity. It is a very useful tool for production support or DBA kind of people where they work on several request incidents or changes per day, and it is difficult to track back what they had done for which request. Query tag can be really useful to tag a session with a particular request or change or incident number before starting any scripting, and unset the query tag once you are done. All the things that you had tagged against that string which you set for the session level query tag parameter, and later you can easily query those using query history view under the account usage schema. The alter script for this is again alter session set query tag is equal to the tag name. Ninth one is default DDL collision. Setting this parameter forces all the subsequently created columns in the affected objects, table, schema, database or accounts to have the specific collision as default unless the collision for the column is explicitly defined in the DDLs. Default is empty. Okay, next up is event table. This specifies the name of the event table for logging messages from store procedures and UDFs contained by the object with which the event is associated. Associating an event with the database is available in Enterprise Edition or higher. Default one is none, but obviously again you can set the event table if you have an event table. And next one is max concurrency level. This is again a very important and non-negotiable parameter if you are an admin or DBA. It specifies the concurrency level for SQL statements, that is queries and DMLs executed by a warehouse. When the level is reached, the operation performed depends on whether the warehouse is a single cluster or multi-cluster warehouse. In single cluster or multi-cluster in maximized mode, statements are queued until already allocated allocated resources are freed or additional resources are provisioned, which can be accomplished by increasing the size of the warehouse. In multi-cluster, additional clusters are started. The default max concurrency level is 8, but again you can change based on your needs. We had reached 12th, guys. 3 more to go. Okay. 12th is periodic data rekeying. This is the account level parameter. Definitely this is my account level parameter, and this parameter only applies to enterprise edition or higher editions. It enables or disables the re-encryption of table data with the new keys on a yearly basis to provide the additional level of data protections. You can enable and disable the rekeying at any point of time. Enabling or disabling rekeying does not result in gaps in your encrypted data. If a rekeying is enabled for a period of time and then disabled, no problem. All data already tagged for the rekeying is rekeyed, but no further data is rekeyed until you re-enable it again. If the rekeying is re-enabled, okay, Snowflake automatically rekeys all the data that has keys which meet the criteria, that is keys that are older than 1 year. Okay, and default value for this is false, and you can obviously change based on your compliance and all these policies which your organization follows. 13th one, again very important one, statement timed out in seconds. And I had seen this personally in the Snowflake Advanced Architect exam. This parameter is very, very handy, guys, because it tracks the amount of time in seconds after which a running SQL query is cancelled by the system. Okay, the parameter can be set at different levels in the session hierarchy on the account or user or session. If the parameter is set at more than one level, the rules described in the session parameters determine which value should be used. The parameter can also be set for an individual warehouse to control the runtime for all the SQL statements processed by the warehouse. Default timeout is 2 days, that is 1,72,800 seconds. Last one is used cache result. Used cache result again is the very important property, but you should know that default is already true and Snowflake automatically catches the result for you, but you can disable that if your business needs are demanding that. It can be set for account or user or session level. It specifies whether to reuse the persisted query history if available when a matching query is submitted. The values here are true and false. True is when a query is submitted, Snowflake checks for the matching query results for previously executed queries, and if the matching result exists, it uses the result instead of executing the query again. This can help reduce query time because Snowflake retrieves the result directly from the cache. This is the default behavior as well, guys. And second one obviously is false. Snowflake executes each query when submitted regardless of whether a matching query result exists or not. Okay, the default behavior we had discussed is false. And with that said, we had covered everything on parameters. We had covered all the 3 parameters like account parameters, session parameters, and object parameters. We had covered the parameter hierarchy, account level, user level, session level, object level. You know how the precedence works. You know the highest precedence is for account level and the lowest precedence is for session level. And session level, if I had set something on session level, it will override all the higher level parameters, and we had understood all the 14 important parameters required for Snowflake Advanced Architect exam. Guys, that's it for the parameter hierarchy and parameters in Snowflake. There is nothing more than that. By the way, there are more than 200 plus parameters. If you really want to learn, you can obviously go to documentation. I will provide you the link in the description box. Happy learning, guys. See you in the next one. Let's discuss about the benefits and limitations of one Snowflake account compared to multiple Snowflake accounts. We will also discuss on the key considerations and constraints when defining an account strategy, and we will also cover the features and capabilities that can be leveraged across accounts, and we will also be looking on the use cases that are appropriate for the account strategies. And let's begin with isolate or segment accounts. One Snowflake account versus multiple accounts. In the early stages of your Snowflake Snowflake journey, you might have to decide from DevOps perspective whether you are going to deploy on a single Snowflake account versus multiple Snowflake accounts as separate environments such as dev, test, or production. Technically, as a SaaS provider in terms of security, operations, deployment, multiple accounts are multiple tenants being part of the same deployment. So having multiple accounts is not the same as having multiple VPCs in AWS or Azure. Let's discuss about single account strategy. In this model, all the business units, environments, either dev, test, and production, and the data resides within one Snowflake URL. If we talk about the benefits includes simplicity because it's a centralized management of resources. RBAC and the security integrations are very simple to implement. And the second is resource efficiency. You really no need to move data. Users can simply access different databases or schema within the single account setup. Third is centralized billing. Obviously, one contract, one usage, one billing. If I talk about the limitations, the biggest limitation is blast radius. A single misconfigurations at the account level could lock out the entire organization, right? The other limitation is object limitations, which is rare, but hitting limits on the number of shares or specific metadata objects is possible in massive scales. Third is strict isolation. It is harder to achieve absolute air-gapped isolation between highly sensitive data and journal analytics. When we talk about single account strategy, these are simple and efficient, but obviously you are having everything at a single place, which might leads to limitations like blast radius and strict isolations. So obviously guys, there are pros and cons for a single or multiple accounts. We will discuss the use case as well, but this is pretty much about the single account strategy, which you should know what are the benefits and what are the limitations for these kind of strategies. Next up is multi-account strategy. Organizations often spin up separate accounts for different regions, departments, or life cycle stages. If we talk about benefits, the first benefit is perfect isolation because it's having zero resource contention at the metadata level and complete separation of administrative privileges. Next benefit is compliance. It meets data residency requirements by placing accounts in specific cloud regions, example US East 1 or Azure West Europe. Third is billing granularity. It simplifies the chargeback models by having separate invoices for different business accounts. But again, here we also have few limitations like operational overhead. You must manage security, users, and networking for each account separately. And second is data silos. Moving or viewing data across accounts requires Snowflake data sharing or replication, which obviously adds more complexity. That's pretty much about multi-account strategy, where we have the perfect isolation, compliance, and granularity, but we are obviously increasing the operational overhead and we are promoting the data silos. Next up is key considerations and constraints when defining an account strategy. When defining your strategy, evaluate these four constraints. The first one is security and compliance. Do you have hard tenancy requirements? Some regulated industries require production data to be physically and logically separated from deployment environment. Second is geographic footprint. Snowflake accounts are region specific. If your users are globally distributed, multiple accounts in different regions minimize the latency and satisfy local data loss. Third is governance maturity. A single account requires a very mature RBAC model to prevent admin overreach. If different teams need account admin privileges, they should likely have their own accounts. And fourth one is cost management. While resource monitor works very well in single account, separate accounts provide the cleanest break for financial auditing. Let's discuss about feature capabilities that can leverage across accounts. If you choose a multi-account strategy, Snowflake provides features to make them behave like a unified ecosystem, like Snowflake organizations, a management layer that allows an org admin to create accounts, view usage across the entire company, and manage billing centrally. Next up is data replication and failover. You can sync databases between accounts, even across different clouds like Azure to AWS for disaster recovery. Third is secure data sharing. You can share data between accounts without physically moving it. This is the primary way to break down silos in the multi-account setup. Fourth one is replication of security integration. Using account replication, you can now sync users, roles, and even network policies across accounts to maintain consistency. And the last topic is identify the use cases that are appropriate for account strategies. I had divided them into three parts: use case, recommended strategy, and what is the reasoning behind it. Okay, the first use case is early stage startup. If your company is kind of a startup or you are just new to the IT with a very small team, the recommended strategy is to have a single account setup. And the reasoning behind is that you will be having low overhead and it will be very easy to manage with simple RBAC. The next use case is global enterprise. If your company is a multinational company or it's a product based company which have a very vast data to store and a lot of clients to serve, the recommended strategy is multi-account, and the reasoning behind is it is essential for data residency following all the GDPR and CCPA policies and the regional performances. Third one is SaaS provider. Definitely guys, if the use case is SaaS provider, the recommended strategy should be multi-account. And the reasoning behind is that often use readers account or separate accounts per gold customer to ensure data privacy. Fourth one is strict dev and production separation. And obviously we are talking about separation. Recommended strategy should be multi-account. And the reasoning is very straightforward, that it prevents accidental account admin mistakes in production while testing in the dev environments. The last one is centralized data hub. As the name suggests, you want the solution which is very centralized. So the recommended strategy should be single account. And the reasoning behind is it is best for internal teams that shares the same core data sets, example marketing and finance teams. This is pretty much about the use cases for appropriate account strategies which you should follow whenever you are setting up the new Snowflake account within your organization. Based on the requirements and the recommended strategy, you can decide which is the best fit for your organization. To be very honest, the exam often tests your ability to balance operational simplicity versus regulatory compliance. If the question emphasizes ease of management, lean towards a single account. And if it is emphasizes data residency or let's say absolute administrative isolation, multiple accounts are the answer. Cool. With that said, we had also covered the strategies and the use cases and the considerations and constraints and features and capabilities. Thank you so much for watching. See you in the next one. Let's now begin with lesson 1.2, that is design architecture that meets data security, privacy, compliance, governance and requirement. In this first topic we will be covering is configure RBAC hierarchy, where we'll be discussing about what is RBAC and how the RBAC hierarchy works. Then we will be understanding the secondary roles, system roles, functional roles, database role, and the privilege inheritance. And then we'll also discuss about the differences between the access roles and functional roles and what are the best practices for the system roles. So let's get started. Let's deep dive and start with the system defined roles. Snowflake provides several system defined roles with predefined privileges to manage accounts and its objects. These roles cannot be dropped and their default privileges can never be revoked. Additional privileges can be granted on them. Okay, these are totally default roles. We don't have any kind of control on them to manage privileges for them. This is something which is created by Snowflake for us. And the primary system defined roles in Snowflake account are account admin. This is the most top level role with control over all the aspects of the accounts. It inherits privileges from security admin and system admin roles, and it's intended for account level tasks. It is not meant to be used for your regular day-to-day object creations. Second is security admin. This is the role that manages any object grants, any user's roles. It inherits all the privileges of user admin role. Okay, so this is majorly to manage grants and create users and roles. Third is system admin. So the system admin role comes with privileges to create and manage warehouses, databases, and all the databases objects. It is best practice to have custom roles roll up on system admin role in the role hierarchy. Next one is user admin role. This is the role which is a dedicated role for user and the role management. So it can create further users and roles and manage those its own without the ability to manage the grants for them. Next one is organization admin role. So this role is to manage the operational things of all the organization level, and this is not actually part of the standard account admin hierarchy. If you see the hierarchy, first is account admin. This is the top level role, followed by the security admin role, which is we can only required to use when we have to manage grants or create users and roles. Similar way, system admin is the best suitable to create, manage warehouses and databases and schemas. Then we have the user admin role. This is the dedicated role which is used to create users and manage tasks on its own. And organization role, if you see, this is not in the hierarchy as it is just for the operation purposes. And the last one is public role. This is the default role which is automatically granted to each and every user, either custom users, whichever you create. The question is, whenever you are granting any other stuff which you had created using public, ensure that you are granting the privileges based on the sensitivity. So this is pretty much about the system defined roles. Let me show you that in Snowsite. Here, if you see, these are all the roles which we had just discussed, and these are known as system defined roles: system admin, account admin, organization admin. Next topic is secureable object hierarchy. Secureable objects are organized in a strictly logical hierarchy. To access a specific object, the user must have necessary privileges on the object itself as well as the usage privileges on all its parent container objects. Hierarchy of the Snowflake objects is like that account and warehouse. Okay, these are the top level container for all the Snowflake objects within an organization. Then we have a database. So database, it's a container for schemas, and to access objects within database, the usage privilege must be granted on the database. Next one is schema. It's a container for specific database objects like tables, views, stages, stored procedures, functions, and obviously the usage privilege is required to access its objects. Similar way, we have objects. That's the lowest level in the hierarchy, and these are where the actual resources sit. This is where your data is stored and the operations are performed. Next topic is access control framework. So Snowflake approach to access control combines aspects from the following models. First is discretionary access control. So each object has an owner who can in turn grant access to that object. Okay, so this is discretionary access control. A object is a owner, and owner can in turn grant access to that object to anyone. This is discretionary access control. It's a object based, and role based access control. It's the access privilege, okay, are assigned to role, which in turn are assigned to users. So discretionary access control is a object based. Role based access control is assigning the privilege to roles which we can assign to users as well. This is the definition in the easy way, that RBAC is the administrative skeleton of Snowflake. Access is granted to roles and then roles are assigned to the users. So the logic is, if you are in a marketing team, you will get the marketing role, and so on. If you are in another team, you will get the another role. So it is centralized and it is managed typically by a security admin or user admin. It uses a hierarchy, and if the analyst role is granted to the manager role, the manager will automatically get every permission which analysts have. Similar way, DAC is the centered around ownership. Every object in Snowflake has a owner. The logic here is, if I created this table, I decide who else can see it. And it is decentralized. The owner of the object can grant any privilege to any other role, okay, at its own discretion. Control here is, if you create a table using the dev role, that role owns the table and can discretionally share it with QA role as well. This is really important for SnowPro exam as well. Let's see this in action. I am on my Snowflake now. So let me show you my current user and current account. For that, there is a command called select current user, current account, and also let's see current role as well. So this is the current user. This is my name as a user, and current role I am using is system admin. So if I change the role to account admin, now my role is account admin role. Let's now create roles and users and provide access to understand more about the users and roles. Okay. Firstly, I will select the sysadmin role. Why? Because sysad role is used to create database objects and tables. I will use this role either by selecting here as I just did, or either I can type here sysadmin. See, so it executed successfully. Now let me change the role and let me try to rerun this sysadmin. See, there is a change, right? So this is how we can use the role. This role is important when we are trying to create the database tables and objects. Let's create the database, create database. Okay, project DB. Okay, and then we'll write the script of create schema. I am going to create a use case where there is a project manager who is taking care of the Snowflake account, and there is a dev team who will be developing the engineering task, and there will be a QA team who will be doing all the testing, and there is a BA team. So I need to create a framework where the project manager is having all the accesses, including the ownership access, and dev team can select, update, delete, create the tables, and testing team should have the required privileges like selecting the table and seeing the data. Similarly, BA team should also be having the select privileges. So this is a scenario which I'm going to create. For that, I am creating a database and I'm going to create schema. So I will create 3 schema. First is dev staging, second is dev QA, and third is dev analytics. So I will say dev staging, QA testing, and then analytics. So I need to hit run for all, and it ran successfully. Now I had created the schema, I had created the database, I had used the sysadmin role. Now I am going to create the warehouse. As I am having a 3 teams, dev, QA, and BA team, I am going to separate them because it is recommended by Snowflake to have a separate warehouse for a separate teams. So I'm going to create 3 warehouses. Create warehouse. If not exist, I will name it as a, let's say, dev warehouse. And I will mention warehouse underscore size is equal to, let's say, small, and then auto suspend is equal to 60, and auto resume is equal to true. This is one. Similar way, I will create the QA and analytics one. Cool. So I had created the 3 warehouses. So I'm going to run all 3. Perfect. So I had created the 3 warehouses: analyst warehouse, dev warehouse, QA warehouse. So now I have 3 additional one, and all are in started state. Now I am going to create the roles and hierarchy which differentiate for that. So obviously, whenever we are going to create roles and hierarchy, it is recommended to use security admin role. I'm going to select security admin role, or even user admin role can work here. Okay, so you can select anyone, but advisable is security admin. So let's select security admin here. Here I will write the script to create the roles. First I need to create the roles, then I need to create the users. Similar way, UA and analytics. I had defined all the 4 roles. Now let me trigger all these 4. Perfect. So 4 roles are created. Now I will grant the roles. This allows the project manager to inherit all the permissions from the team roles like QA role, dev role, BA role. And it is very important that for the visibility of project manager, dev role to role PM role. Similar way QA and BA. Okay. Now I will run this, and it had successfully built the hierarchy for me. Now I will connect the PM role to sysadmin role so that it can have all the ownership privileges. For that, I will say grant role PM role to role sysadmin, and I will trigger this. Cool, that's done. Now my PM role is having all the privileges required. This was a typical RBAC. This was RBAC, role-based access control. Let's have a DACs. For DACs, I will be granting usage access and select access and all the required access databases to the required roles. So I will write grant usage on database, and database name I have project DB to role dev role. I want dev role to have the usage access. Similar way, UA BA role. I had written grant commands to grant access to the respective roles. I'm going to hit them, and cool. It had created a DAC discretionary access control for me. Similar way, I'm going to grant full control to dev team on dev schema, as they have to create the tables, delete the tables, update some tables, right? So they should be having the full control on at least the dev schema. And the whenever you are granting the privileges, we need to ensure that we have to grant the least required privileges to each and every role. Cool. Now I will write those commands. So I need to give full access. So what's the command for that is grant all privileges. Grant all privileges on schema project db dot dev underscore staging to role dev role. Now I will hit run. Oh, perfect. Now dev role is having full control on dev staging schema. Further, I will also give him the warehouse, right? He also need warehouse to run something. So I will write that command as well, warehouse to role dev role. I will hit run. Perfect. So now dev role is ready. Think about QA team now. QA team needs read privilege, right? And full control on QA schema. So let's do that. Grant usage on schema. Running this command will ensure that QA role is only having the usage privilege and not all the privileges as the dev role is having. Now QA should be able to at least do select on this dev staging schema, but obviously they also need full privilege on their schema. Cool. So now they have all the privileges on the QA testing schema. Now, obviously, as the dev team required warehouse, same way QA team also require the warehouse. I will just copy paste this command and just tweak here dev to QA, and here also QA, and run it. Cool, cool. QA team is ready now. QA team is done. Now I need to focus on BA team. What BA team needs? BA team needs only read-only access. They don't require any further access. They just need select access Okay, and we are going to grant him the select access and the usage access on their schema. So I will write grant. First, I will give usage on schema. Okay, this is done. They also need select access on all tables in schema project DB. Cool. Now I had given all the accesses required for dev team, QA team, BA team, and project manager is having the ownership access for all the objects. So a typical hierarchy is established. Now I need to take care about the future grants as well, right? So there is future tables which dev team will be creating and they will be requiring access. Other teams will also be requiring. So I will give that access as well. Grant select on future tables in schema. I will give them the access. Perfect, perfect. So now I have everything in place. Okay, now I will go and create the users. I had done everything with the roles and I had done everything with warehouses, granting accesses. We had seen RBACs, DSE in picture. Let's create the final step to put real people into these roles. Okay, so for that, I will going to use the use role, user admin. Okay, so now it changed to user admin. And here I'm going to create the users. Create users if not exist. First, I will create dev user. I will mention password. Then default role they should be having is dev role. This is why we had created the dev role. Now they have default role as well, password as well. There's a property called must change password. Okay, very, very important to remember. Whenever you are creating a user, always set this property as true so that they change the password when they first time trying to log in. And this is very, very helpful. I will mention as of now it's as a false. So I will similarly create two more. One is for QA and second one is for BA. One more I will create for PM. Perfect. So now I am going to trigger them. First I will trigger this dev one. Okay, dev user is created. Same way I will trigger these three altogether. Now all the users are created. I will log in to Snowflake and see this in action. For that, first I will open the incognito window and I will again type Snowflake trial and go for a sign in. I will mention my account identifier here and then I will go for sign in. And once I click on sign in, it will ask me for the username and password. This time I am going to pass this username and password this password. So I am passing this username dev user and password temp password and I'm going to hit enter. So see guys, it had created the username and I am able to log in to a new Snowflake instance and see here this is again the quick start guide and I'm going to skip it now and if you see here this is showing the dev user. In the similar way, you will be able to log in into QA, PA, and PM user. This is pretty much about the hands-on on how you can create roles and users and how you can grant them the privileges. As now we had seen RBAC hierarchy and system roles, let's understand privilege inheritance. In Snowflake, privilege inheritance is primarily managed through RBAC model. Unlike some traditional databases where privileges might be tied directly to a user, Snowflake grants privileges to roles and then roles grant to users or other roles. Let's try to understand this with the below image. The core of privilege inheritance is the role hierarchy. You can grant a lower level role to a higher level role. When this happens, the higher level role inherits all the privileges held by a lower level role. Privileges flow upwards. If the role B is granted to a role A, then role A has all its own privileges plus everything granted to role B. At the top of every Snowflake hierarchy, we have system defined roles like, as you can see, account admin, security admin, and sysadmin. There is a subset which is known as structural inheritance or database objects. Snowflake also utilizes a container based inheritance models for objects. This is often referred to as namespace inheritance. Privileges can be granted at different level here, like account level, database level, schema level, and object level. To access a low level object like a table, a role must have a usage privilege on every container above it. If you have select on a table but lack usage on the parent schema or database, you cannot access the data. Let's now talk about database rules. Snowflake has introduced database rule concept facilitating the assignment of grants on database objects to other database roles or Snowflake roles. This simplifies the process of redistributing database roles to multiple roles without any kind of ambiguity. Database roles in Snowflake are entities designed to manage access to secureable objects within a specific database. Unlike standard account level roles, database roles are contained within a database and cannot be granted directly to users. Instead, they must be granted to the account role, which are then assigned to the users. If we talk about the key characteristics and scope, database rules are limited to the database where they are created. They can only hold privileges for objects like tables, views, schemas within that same database. If we talk about hierarchies, you can create a role hierarchy by granting database rules to other database roles within the same database or to the account roles. Next up is activation. Users cannot activate a database role directly using use role. They must use an account role that has been granted the database role. And fourth is creation. It is managed using the create database role command by a role with ownership on the database. The common use cases involve data sharing. Providers use database roles to segment access to shared objects. Instead of sharing an entire database, they can grant specific database roles to a share, allowing consumers to access only a subset of data. Next up is reduced role sprawl. They allow database owners to manage fine-grained internal access independently without creating numerous global account roles. As we can see in this diagram, database role cities DB reader is contained within a database and is granted to the account role cities reader, which is then assigned to the user cities analyst. Let's create the database role in Snowflake and see this in action. I am into my Snowflake, and first thing I will create a new SQL file. I will name this as database roles.sql, and in this I will be showing you the complete hands-on on the database role. First thing first, I will create a database. I will say create or replace database, and I will name this as, let's say, db_cities. Okay, and then I will create a schema. I will say create schema cities, and let's create a table as well. Create table db_cities dot cities dot, let's say, cities list, and I will just have a column called cities_name as varchar. Perfect. And now I will insert two entries, and I will skip this part. I had written my insert scripts as well. Let's create a database role as well. I will say create or replace database role. Let's name it cities_db_reader. And then I will grant usage on schema. DB underscore cities, got my table name cities to database role, my database role cities underscore DB underscore reader. And I had granted the usage on the schema, and I will also grant select on the table. Grant select on all tables in database DB underscore cities to database role, and my database role is cities DB reader. Let's run these scripts as of now. I will hit run. And perfect, guys. All these scripts has ran. It's the very time that I should see the grants. So I will say show grants to database role and my database role. And I will hit enter to see the grants. So I can see that I am having usage grant on database and schema and select grants on all the tables. As of now, it is only having a single table. So it is giving a select for single table. Makes sense. Now it's the very time to create another user. I will create one more user. I will say create or replace user, and I will name this as cities underscore analyst. I will mention the password, let's say 123. Then there is another property which is very important to mention. Okay, must change password. As of now I am keeping it false, but usually it is the best practice that whenever you are creating a new user with the default password, initially you should have a must change password as true, so that user can change the password on his end as well. So also I will create one role, create role, let's say cities reader. I will grant my database role to this new role. I will say grant database role cities DB reader to role, this role. Now I will run these three scripts. Now I need to grant this role to warehouse as well, right? So I will say grant modify monitor operate and usage on my warehouse, and my warehouse is compute warehouse. To which role? To my cities readers role. The last thing I will do is I will grant the role cities reader to cities analyst user. I will say grant role cities reader to user cities analyst. I will run these two scripts as well. And perfect. I had ran all the scripts. Now, after using this series of scripts, database role will be granted to the Snowflake role. That is further granted to the user as well, as you had just seen. Now, we will be logging to the Snowflake account with the credentials of cities analyst. Okay, the user is cities analyst and my password is 123. I will log into this account now. First thing first, I will go to my account and I will sign out from my current account. And then here, I will mention the username as cities analyst and my password as well. And then I will go and sign into this account. I am into my newly created Snowflake account and I will go to workspace. I will click on new file and I will create a SQL file. Here you can see my cities reader role as well, right? And I should be able to see my compute warehouse as well. Perfect. And if I go to my databases, I should be able to see my cities DB, and inside my cities DB, I should be able to see my cities table, which I am able to see. Now I will just run the select star on this table. And perfect, guys. I am able to see my data using my database role, which is cities reader. This is how database roles work. Database role cities DB reader was contained within the database and then was granted to the account role cities reader, which is then assigned to the cities analyst. And we can see the tables results. This is pretty much about database roles. Now let's discuss about the functional roles compared to the access roles. Functional roles are designed to match users' responsibilities within an organization. They do not directly hold privileges. Instead, they act as a container inheriting privileges from one or more access roles. This ensures that when a user's job changes, only their functional role assignment needs to be updated. While the access roles are designed to manage access to specific objects like tables, schema, or warehouses, they are functional agnostic, focusing entirely on the security part. If we go with the definition, Snowflake functional roles represent job functions, example data analyst, assigned to users, while access roles hold specific privileges on objects, example table read. Best practice dictate a hierarchical approach. Access roles are granted to functional roles and the functional roles are granted to users, separating responsibilities from permissions. If we talk about the key differences at a glance, I had divided them into features between the functional roles and access role. The first feature is purpose, and then assignments, then permissions, then examples, and then lifecycle. If we talk about the purpose of functional roles is it defines who is doing the work, and the purpose of access roles is it defines what they can access. If we talk about assignments, functional roles are granted to the users and access roles are granted to functional roles. Okay, if we talk about permissions, it inherits permission from the access roles, while access roles contain the privileges, okay, like select or usage. If we talk about examples can be data engineer role or finance manager role. And access role example obviously is table read, DB read, schema usage. If we talk about life cycle of functional roles changes when employee role changes, but the access role life cycle remains stable and it rarely changes. Let's talk about secondary roles. In Snowflake, secondary roles allow a user to perform SQL actions using the aggregate privileges of multiple roles simultaneously within a single session. The syntax for using secondary roles is use secondary roles, either all or none. In case of all, Snowflake grants all the roles the user in addition to the current active primary role, and in case of none, it disables the secondary roles. The authorization of all the SQL actions is provided only via the primary role. Let's see the secondary roles in action and we'll do some hands-on on that. I will go to my Snowflake, and now first thing first, I will create few roles, I will create few users, and then I will provide some grants on them. Okay, so for that I will use my account admin role. I will say use role account admin, and then I am going to create roles. First role I will create, let's say, analyst role. Next role I will create, let's say, tester role. And the third role I will create is, let's say, developer role. Now I will create a user. I will say create or replace user. This time I will name this as admin user, and I will mention my password as, let's say, 123. And then the default role, I will mention analyst role. Then I will grant this analyst role to my admin user. Okay, I will say grant role, analyst role to user, admin user. And similarly, I will grant the tester and developer role as well. I had granted them. It's a time to grant privileges as well. Like first thing, I will grant the warehouse usage to all these three roles. So I will say grant usage on warehouse, compute warehouse to my analyst role. And similarly, I will grant this to my tester and developer role. I will just copy paste and I will just change it to tester role. And again, I will just copy paste and change it to my developer role. Okay. Now we had created the roles, we had created the user, we had granted the role to my admin user, and then also we had granted the usage on the warehouse. Let's create a database as well. create or replace database, and I will name this as secondary underscore demo. And let's also create a schema. Say create or replace schema secondary demo dot. I will create two schemas. First is for analyst and second is for tester. I will say, let's say tester SGS, and then I will grant the ownership to the respective roles. Okay. And I will say grant ownership on schema secondary demo dot analyst SCH to my role, which is analyst role, and I will revoke my current grants. This is just a extra cautious step. Okay. I usually use ensures that specific role is having the least privileges every time. So same thing I will do with my tester role. I will just copy paste this and I will just change the analyst SCH to tester SCH, and from analyst role to, let's say, tester role. Okay. And I will also grant the usage on database to both the roles, else it will throw error, right? So I will say grant usage on database secondary demo to my role, which is my analyst role. And I will also grant usage on database secondary demo to my tester role. Perfect. That's pretty much, guys. Okay. I will run all these scripts now. I will say control enter and it will start executing all of my 19 scripts one by one. And perfect. It has executed all of my scripts. It's the very time that I log out from my root account and I should go to my admin user account. Okay, so I will just say sign out and I will go to my admin user account and I will just click on my account identifier again. And in the username, I will mention admin underscore user, and in password, I will mention my password 123. And I am back to my newly created user account, and my role is reflecting here as analyst role because I had mentioned there as default role. So first thing first, I will go to project workspaces and I will create a SQL file, and inside this SQL file I will create two tables, first using analyst role and second I will use tester role to create two tables. Okay, I will say use role, analyst role. Obviously, you can select from there only, but it's a good practice to have that in a single place so that in future you can just copy paste your things to make it quick. Secondary underscore demo dot analyst dot sch dot, let's say, table A as select, let's say, analyst data. I will just populate with some dummy data. Similarly, I will copy paste this one and I will just change analyst role to tester role. So I will say tester role, and instead of analyst SCH, I will use my tester SCH, and my table name, let's say I name it underscore T, and I will say it's my tester data. Perfect, guys. It's the time that I run these two. Perfect, guys. All the scripts had ran. Now I will switch back to my analyst role. As of now, you can see it's my tester role. So I will switch back and then I will also say use warehouse by compute warehouse. I know it's already selected, but as I told you, it's a good practice. So the next thing is I will mention use secondary role as none. Why I am mentioning this is that it's critical to disable any secondary roles left over from your previous sessions. Snowflake sessions are very sticky because I had tested multiple times this secondary roles all in my previous turns. Worksheet will still be using the same setting. By adding the use secondary roles as none, you force Snowflake to look only at your primary role, which is my analyst role, which correctly blocks the earlier secondary role options. So now I will just hit run and perfect. It's the very time that I will do select star. I will say select star from my analyst table. And if I hit run, I should be able to see the data. And perfect, I am able to see the data. But if I change this to my tester table, I should be getting error. Okay, so let's see if I am even getting the error or not. And perfect, guys. See, guys, I am getting the error that the tester SCS schema does not exist or not authorized using my analyst role. But if I change the role, I will go to my tester role and I will run this. I should be able to see the results, and perfect, I am able to see. But now, as we are already understanding the secondary role main intention is that only that with my primary role, I should be able to see other objects, right? So what I will do is I will just copy paste this one, and instead of none, I will say all. So by running this command, I am turning the union back on for all my rules. So I will run this one. Perfect. Once I had ran this, it's the time to retest this. And as you can see, this is my tester schema. The role is analyst role. Earlier it was throwing error, but if I now run this, I will be able to see the results with my analyst role as well. This is how secondary roles works, guys. It allows a user to perform SQL actions using the aggregate privileges of all my multiple roles simultaneously within a single session. Cool? That's it, guys. That's it. Hope you had really enjoyed the video. Thank you so much for watching. Do consider liking the video. Have a nice day. Let's now discuss about another important topic of lecture 1.2, that is data access. And inside the data access, we will be deep diving into storage integrations. A storage integration is a Snowflake object that stores a generated identity and access management entity for your external cloud storage, along with an optional set of allowed or blocked storage locations for S3, GCP, or Azure. Cloud provider administrators in your organization grant permission on the storage locations to the generated entity. This option allows users to avoid supplying credentials when creating stages or when loading or unloading the data. Please note that if your cloud storage is located on a different cloud platform from your Snowflake account, the storage location must be in the public cloud and not in any kind of virtual private environments. This is the syntax of creating the storage integration. We start with create or replace storage integration with a storage integration name. Then we will mention the type, either external stage or Postgres external storage. We will cover that in the parameters required section of the storage integration once we had done the hands-on. But as of now, please remember the types are of two, either external or Postgres external stage. Okay, then we have cloud parameters like enabled is equal to true or false, default is true, and similarly storage allowed location. Storage block location is something which is optional parameter. It is not required. If you want, you can obviously mention something here, but if you don't want, that's completely fine. Similarly, comment is also something which is very optional, but it is highly encouraged to mention comment inside your storage integration, which is very relevant. What is the purpose of this storage integration? Let's see storage integration in action. For that, I will first go to my S3. I need to create a S3 bucket. If I am not having, I'm already having the S3 bucket, so I'm not creating it. Cool. And the second step is you need to create the IAM policy. That also I had already created. I will just show you that this is the IAM policy I had created, Snowflake S3 Access. And the third step is you need to create the IAM role as well. Okay, this role will be going to responsible to have the relationships between S3 and your Snowflake accounts. I had already created my roles. Okay, the fourth step is we will go to Snowflake now and we will build the handshake between S3 and Snowflake. For that, I just discussed with you that we need to have a storage integration. So we will create a storage integration, create storage integration. If not exist with the, let's say, S3 integration, Jaswinder, and the type of storage integration here is external stage. These are all the properties which are mandatory required to create the storage integration. Okay, and then it asks for storage provider name. So in my case, it's S3, and then it will ask for enabled. I will say it is enabled. Enabled is equal to true. And then I need to mention my storage AWS role ARN. This is the point which will ensure the connection is made. Okay, and I will pass my ARN number here. Then it asks for one more, which is storage allowed location, and I will mention my S3 path here. Cool. This is pretty much required to create the storage integration. I will just hit enter and run. Okay, I had ran. Now I am going to create the handshake. For that, I need to say describe integration and my integration name. What I need from this is I need two properties. First one is this one, storage AWS IAM user ARN, and second one is this one, storage AWS external ID. So these two are required to me, and I will copy paste these values and I will go to my role. Let me show you. I will go to my role and I will go to trust relationships, and here I will add my ARN which I had copied from this one, IAM user ARN, and I will similar way I will copy my external ID, this one GQ15001, and I will copy paste that here and I will update my trust script. In this way the handshake is completed, okay, which I had already done. And now once we had updated the trust relationships in AWS role, now we will create a stage. Okay, in order to create a stage, we need to say create or replace stage followed by my stage name. Let's say my S3 stage, Jaswinder, and then I will mention my storage integration. Storage integration is equal to, I will copy paste this, S3 integration Jaswinder, and then I will mention URL on which I am having my files which I need to stage here. I had pasted my URL as well. Okay, now I'm going to run this query. Cool, I had ran the stage. Now let's list the data inside this stage which we just had created. Perfect. So we are able to see the files which we had placed in our S3 bucket. I had placed this Titanic file, if you see here, and now I am able to see that file inside my Snowflake as well. Cool. Let's now discuss about storage integration required parameters. The first parameter is name. It is the string that specifies the identifier for the integration. It must be unique throughout your account. Second one is type. Type is either of external stage or Postgres external stage. External stage creates an interface between the Snowflake and the external cloud storage location like GCP, S3 or Azure. And the Postgres external storage is something which creates the storage integration for the use of Snowflake Postgres only. Okay, only one storage location is allowed for this kind of integration. This is very important to note. Third is enabled is equal to true. It specifies whether this storage integration is available for uses in the stages or not. By default, it is true. True allows users to create new stages that reference their integration, and existing stages that reference this integration functions work very normally. If I mention false, it prevents users from creating new stages that reference this integration, and the existing stages that reference this integration cannot access any kind of storage integration in the storage definitions. Next up is storage allowed location. This explicitly limits external stages that use the integration to reference one or more storage locations, either from S3 or GCS or Azure. So it supports a comma separated list of URLs for existing buckets and optionally path used to store data files for loading or unloading. Alternatively, it supports the wildcard, meaning you can allow all the buckets or all the parts if that is your requirement. First one is Amazon S3. If we have to mention Amazon S3 as a storage allowed location, this is the syntax of doing that. we first have to mention the protocol, and protocol will be any one of the following. First is the most widely used protocol, that is S3. Second one is the S3 China, and third one is the S3 GOV, that is only for the government regions. Similarly, for GCS, we have the storage load location URL starting from GCS. Then we have bucket and path, and we can mention multiple paths as we had already discussed. Third one is Azure. For Azure, the URL starts with the Azure. Then we need to mention the account. Account is the name of the Azure storage account. Use the blob core windows.net endpoint for all the supported types of Azure blob storage, including the data lake storage gen 2. Then we mention the container. Container is the name of the Azure blob storage container that stores your data files actually. Okay. And then obviously, as usual, we have path. And similarly, we can mention multiple paths inside our storage allowed locations. That's pretty much about storage integration. This is very important when you are doing loading and unloading. So please practice this out on your Snowflake trial version. Today, we will be covering the another important aspect of lesson 1.2, that is data security. And inside the data security, we will be covering secure views, data governance, which includes column level security, external tokenization, dynamic data masking, row level security, aggregate policies, projections, data lineage, object tagging, compliance, and features of PCI and PIS, and which are the minimum standard editions where these things are supported. This fledged data security video will be very helpful for data architect advanced point of view. Please consider liking the video and sharing this with your friends. The first topic is secure views. Secure views in Snowflake are specialized database objects designed to enhance data privacy and protect sensitive information by restricting access to both the data definition and the underlying table structure. If we talk about the key features, the first key feature is defining masking. Unlike our standard views, the SQL of a secure view is hidden from unauthorized user. Only those roles that owns the view can see its SQL logic using either getDDL or showViews command. Second up is optimization bypass. Snowflake's optimizer skips certain internal optimization for secure views in order to prevent the data exposure via interface attacks or user-defined functions. Third one is mandatory for data sharing. Secure views are very mandatory for data sharing. These are often required when sharing data with external accounts to ensure providers do not expose known shared object or internal metadata with third party. Fourth one is granular control. This includes implementing the row level security or column level security, which we will be covering in few more minutes, using functions like current role or current user to dynamically filter data and maintain the PI of the data. Let's see the secure views in action. I will go to my Snowflake account, and first thing first, I will create a table. I will say create or replace table, and I will name this tables as, let's say, employees. And I will mention 3 columns, let's say employee ID, and this should be my primary key. And then I will mention employee name and varchar. And the third thing which I will mention is role. Okay. Now I will run this one. Perfect. It ran. Second thing, I will do some inserts into this employee table. For that, I will skip this video. So now I have few insert scripts. I will just run all of these insert scripts one by one. And once these insert scripts run successfully, I will create a secure view on top of this. I will say create or replace secure view, and I will name this as view underscore emp. And I will say select star from employees. And I want to mention here where my role should be equal to current role. Only display data if the current role is equal to my role inside my employees table. And I will run this one. Perfect. I had created a secure view. It's the very time that I will say select star on this view. And see guys, this secure view only returned me 2 records while I am having 6 records inside my employee table, because inside my secure view definition, I had added a filter of role is equal to current role, and my current role is account admin, and that's why it had shown me the account admin respective data. If I change this role to, let's say, sysadmin, I should be able to see the data which is relevant to sysadmin. See guys. Similarly, if I change this to user admin, I should be able to see the user admin relevant data. And if I select something else, let's say I select DA analyst, and if I try to run this one, I will be able to see nothing because there is no record mapping to this role. Correct? And if I try to get the DDL of that, I will say get DDL for my view, and I will mention my view name here. I should get the error. And see guys, I am getting the error as view does not exist or not authorized because I am using DE analyst role, and that is not the role by which I had created my view. I have created my view on my admin role. If I click on my account admin role and try to rerun this script, I should be able to see my DDL. But if I am trying to rerun this with any other role, I am getting the error that you are not authorized to view the DDL for this view. Cool. That's pretty much about views, guys. Let's deep dive and start with data masking. Data masking is very simple. Just think of Snowflake's data masking like a digital spy filter for your database. Instead of actually changing the data in your storage, Snowflake hides the data behind a mask in real time, and this is known as data masking. That's it. Cool. Hiding the data behind the mask in real time. For example, if you are a CEO or account admin, you might require full table access, so you will be seeing all the data. But if the role is support agent or lower, account admin or senior management wants to ensure that they are only having at least required access to the data. In that case, you gonna apply masking policy to hide the sensitive data, as you can see. Similarly, for data analyst as well, you will be requiring to provide the least required access for the data. Snowflake primarily uses dynamic data masking for protecting sensitive data. This feature obscure data in real time based on user's role and access permissions without altering the underlying data in storage. Now let's discuss about row level security. Snowflake implements row level security primarily through role access policies, which are schema level objects that dynamically determine which rows a user can view in the table or view at query runtime. Okay, this ensures users only can see the data relevant to their roles and permissions and don't see the other data which they don't are intending to see. And if I run this query in my Snowflake, normally I will be seeing all the data. In this case, if you see, I'm able to see HR department data, tech data, marketing data, and employee ID, salary, manager ID, everything I'm able to see. But if you had applied the row level security and you are from HR team, you will only be seeing the HR team data. If you run this query, you will only be seeing HR team data. You won't be able to see marketing team data or tech team data. This is known as row level security, hiding the data which is not required for another team and only ensuring that they have access to the relevant data only. Cool. Similar way, if I am from a tech team, I will be only seeing the tech team data, and similarly for marketing team as well. How this works is, on top of Snowflake tables, we create a secure view, and based on the secure view, we write the filter conditions that if role is HR role, then show HR respective data. If the role is technical, then show that relevant data. Similarly, for marketing, show the marketing relevant data. So this is the syntax for creating the secure view. Create or replace secure view name and select star from company dot employee table where a department is equal to current role. Okay, so if my role is HR, I will be only seeing HR entries. So this ensures this thing. Cool. If you see in Snowflake, if my role is marketing role and I am running this query, I am only seeing two records because other records are not from marketing. So this is pretty much about row level security. Now let's discuss about column level security. Column level security restrict user access to specific columns within the database table, providing granular data protection for sensitive PI data, financial data, or health data. It ensures only authorized user can view or modify particular field. Row level security is ensuring that a subset of relevant data will only visible to the relevant team, and column level security is assuring that the PI data fields are masked and normal users are not authorized to see the actual values for those fields. Okay, this is the difference between row level security and column level security. Column level security in Snowflake allows the application of masking policy to a column within a table. Cool. Currently, column level security includes two features, that is dynamic data masking and second is external tokenization. Dynamic data masking is a column level security feature that uses masking policies to selectively mask plain data in the table. Very, very important to note. And views columns at the query time. Okay, external tokenization enables to tokenize data before loading into Snowflake and detokenize the data at query runtime. So tokenization is a process of removing sensitive data by replacing it with undecipherable tokens. If I show you the example, this is my actual table where I am able to see email and salary for the employee. But if I apply column level security, it will look something like this. It will having email, let's say abstract, if I use abstract to define that, and salary will be empty if I use single quotes for that. This is the syntax for creating the masking policy. And once you create the masking policy, you need to apply the masking policy on the table. Let's quickly go to Snowsite and create masking policies there. In order to create masking policies, I had written the scripts to create database. I am going to insert few scripts and then I am going to check whether the data is there in the table. So let's me quickly run all these. Cool. I had ran all the scripts and now I am able to see the data populated in the employees table. Now let me create the masking policy. In order to create the masking policy, the syntax is create or replace masking policy, and then the policy name, let me give me the policy name as, let's say, customer account balance. I want to return my value as varchar data type. It's important to return the data type, and then you need to apply this, and then you need to write case when my current role in account admin or sysadmin, I want to see the data for these two roles. But if my role is other than this, then I want to, let's say, see this, then I will trigger this. Perfect. I had created the masking policy. Now, as I had created the masking policy, I will apply the masking policy. So I will apply masking policy for sensitive data, and sensitive data here I am seeing is salary. So let's apply masking policy to salary. Alter table, the table name, and modify column salary and set masking policy and my masking policy name. Cool. I had created the masking policy. I had set the masking policy. Now let me query the table. I had queried the table, but I'm not able to see here hashtags. Why? Because I had mentioned that when the current role is account admin or sysadmin, then I need the actual value. So this is why I am seeing the actual value. Now let me change the role from account admin to, let's say, BA role. Okay, and now if I run this select query, I will be seeing the hash values. Okay, I had masked my data. This is known as data masking. Okay, now if I change to sysadmin, I will again able to see the data because it's written here that if the current role is account admin and sysadmin, then show me the value. All the other roles will be showing me hashtags. Like let's say I will use one more role as username, user admin, and see guys, this is known as column level security and dynamic data masking. Next up is aggregation policies. Aggregation policies are schema level governance objects that restrict how users query sensitive data by requiring all results to be aggregated. These policies ensure that the individual records cannot be identified, only group level insights can be provided. An aggregation policy is a schema level object which controls what type of query can access data from a view or table. When this policy is applied to a table or view, queries against that table or view aggregates data into group of mentioned minimum size to return results, hence preventing a query from returning information based on individual record. A table or view with an aggregation policy assigned to it is said to be aggregation constraint. Aggregation policies can be used with or without a key called entity key. When aggregation policies are used without any kind of entity key, they protect the privacy of individual rows in the data set, that is on row level privacy. With an entity key, it protects the privacy of an entity even if information about that entity appears in multiple rows, that is entity level privacy. The syntax of the aggregation policy is create aggregation policy, the aggregation policy name, and then we return the aggregation constraint with the body, and the comment is obviously recommended but optional. If we talk about aggregation policies parameters, there are two parameters. First is name and body. Name is the identifier for aggregation policy. It must be unique for your schema. And the body is the SQL expression that determines the restriction of an aggregation policy. To determine the constraints of an aggregation policy, use the SQL expression to call one or more of the following functions. First is no aggregation constraint. Second is aggregation constraint. No aggregation constraints means literally no aggregation constraints will be applied and the results will be shown as usual. If the parameter I am applying is aggregation constraint, I need to mention another parameter which is min group size, and min group size will take the decision that at least how many records as a group it needs to fetch, and it specifies how many rows or entities must be included in the groups returned by a query against the aggregation constraint tables or views. Cool. Let's see this in action. I will go to my Snowflake, and first thing first, I will say use the role as account admin. And then I will create one another role. I'll say create or replace role. I will name this role as aggregation admin. And then I will grant this role to myself. Aggregation. Perfect. And I will run these three queries. And cool guys, now I will create a database, a schema, and I will also grant the usage on both database and schema. So let's create that as well. I will say create or replace database, and the database name, let's say privacy lab. Okay, and I will also create a schema, and let's say privacy lab dot policies. Cool. And obviously I need to grant usage on both of them. I will say grant usage on database, privacy lab, to role, my newly created role, aggregation admin. And I will also grant usage on schema to the same role. I'll just copy paste, and instead of database, I will say schema. And instead of privacy lab, I will say privacy lab dot policies. Cool. And now I will run these four scripts as well. Perfect, perfect, perfect. It's the very time that I also grant create privilege to my aggregation admin role. So I will say grant create aggregation policy on my schema, which is my this schema to role this role. I will copy paste here and I will run this one as well. Perfect, perfect. So now my aggregation admin user will be having the permissions to create the aggregation policy, but it should also be having the access to apply the policy. Don't you think? Right. So I will say grant apply aggregation policy on account to my role, which is aggregation admin role. And this will ensure that I am not only having the create privilege, I am also having the apply privilege, and I can apply this policy to any table I want, which is obviously having the privileges of aggregation admins as well. Okay. It's the very time that I should switch back to my this new role of aggregation admin. I will say use this role, and then I will say use my schema privacy lab dot policies. Cool. And then I will run these two as well. Perfect. So now I am using my aggregation admin role with database and schema as privacy lab and policies. It's the very time to actually create the aggregation policy. I will say create or replace aggregation policy, and then my policy name, let's say p underscore min group, let's say 5. Okay. And then I will mention as this is the syntax, right, guys? This is the syntax. You can obviously go to Snowflake documentation and, copy paste from there. You don't need to remember this. If you are able to remember this, that's very good. If that sounds challenging to remember, no problem. You can quickly go to Snowflake documentation and copy paste that syntax, and then you can just tweak it as per your requirements. Anyway, I am coming back to my discussion that I had mentioned the aggregation constraint. As we had discussed, there are two parameters here. First is no aggregation constraint, and second is aggregation constraint. So I will show you both of them. Okay. So inside my aggregation constraint, I am writing a case statement saying that if my current role is account admin role, then please don't apply any aggregation. I will say no aggregation constraint. Okay. But if it is not true, this means I am having other role. I will apply the aggregation constraint. I will say aggregation constraint, and I will mention the min group size as we had discussed. Min group size should be greater than equal to, let's say, 5. Okay, and I will end this one. Cool. It's the time that I should run this as well. I will just hit run. And I had created my aggregation policy as p min group 5. Now I will switch back to my account admin role. Why I am doing this is because I am going to create a dummy temporary table on top of PPCHSF1 schema, which is Snowflake sample data schema. That's the only reason I had changed it to account admin. Else I am pretty good with my aggregation admin. Okay. If you already have table inside your database, I am okay if you skip this part. Okay. But I am not having because my Snowflake is trial version and I had recently created my Snowflake account. So I need to do something for my data. So I will do this. So I will say public. Then let's say I name this as sensitive orders. Okay. And I will just pull the data from TPCH from my orders table. I will say select star from Snowflake sample data dot tpch underscore sf1 dot orders. Cool. And let's say I will limit the data because data is very huge. Okay. And then I will run this one. Perfect, guys. So I had created my thing. Now, as I just told you, these are something which you can ignore if you already have table. I was not having, that's why I used it. So I had commented them out. And by the way, I am creating all the SQL files and I will put these SQL files in my Git repo so that you can go and check these scripts on your own. Okay. It's the very time that I move back where I was earlier to my aggregation admin role, and I should start assigning the rule. I will say alter table privacy lab dot public dot sensitive orders, and I will say set aggregation policy to my policy name, which is privacy lab dot policies dot my policy name, which was p underscore min underscore group underscore 5, right? I will hit run. Perfect, guys. So my policy is now set on my sensitive orders table. It's the very time that I move to some other role and start exploring this. So I will say, let's use other role to test if the aggregation policy is working as expected or not. I will move to my DA analyst role and then I will just do select star. I will say select star from privacy. I will copy paste from here. And guys, I will stop here. I won't run this script first. I want to talk with you. Okay. Aggregation policy requires the results to be aggregated, right? We had discussed this part. But in this select query, am I doing any kind of aggregations? Had I mentioned any kind of group by or so something like that? No, right? So ideally, what should be the result of this select query? It should fail, guys. It should fail, right? So I am going to run this query. And see, guys, the result which I am getting is compilation error saying aggregation policy violation. Aggregation is a must required. Why this is happening? Why this happened is, let me show you with an Excel example. Now I am on my Excel. So if you assume this is my initial table and I had set the aggregation constraint with the min group size as 3, then I am only having a single department which is having 3 employees. So the output for this should be a single record HR with my sum of all these 3 salaries. Correct? Similarly, if my min group size is 2, I am having 2 departments. First is HR, which is having 3 entries, and second is sales, which is having 2 entries. So I had got my output as HR and sales. But what if my aggregation constraint min group size is equal to 1? It will actually break the principle of aggregation policies because operations is only having a single record. If someone got this access, he will immediately be knowing the Vivek's salary. But in this case, in HR department, we are having 3 people. So it is actually combining the results of 3 salaries. The audience is not able to judge that which salary is Sachin's salary, which is Ayush, and which is Avantika's salary. But if my min group size is equal to 1, I am actually violating the aggregation policy principle, because other person will be judging, or they might predict that who is the person who is having this 25,000 salary. Actually, this is the whole intention to create aggregation policy, and it is recommended to at least have a minimum group size of 2 guys. Okay, this is very important to note, because if you are not doing this thing, the actual aggregation policy, whatever you are working, is not even a valid. Okay, it only gets valid when you mention some min group size, so that the output of the result is not a predictable. Okay, let's go back to my Snowflake. And as you had seen that this has thrown error because it is expecting a minimum group size of 5 or greater than 5, and I am not mentioning any kind of group by here. So that's the reason it had failed with the error of aggregation policy violation. Now let me do group by. What I will say is select, I will pull some columns O underscore cust key, and then I will say count of star. Then I will also do sum. I will say sum of O underscore total price from my privacy lab sensitive orders table. Copy paste. And then I will group by. I will say group by 1. And if I run this now, I should be able to see my output. See guys, I am able to see the output. Now I had written the another select statement. Okay, so if I run this one, I should be able to see the results. See guys, I am able to see the results. Why? Because I had added the aggregation group by, and I am not able to predict that order status O, this count holds for all the O's, and I cannot judge that for a specific person or for a specific entity what is the actual count, right? It is respecting my aggregation policies, right? Similarly, if I run one more script and I will say, hey, aggregation policy, I want the result where my count star is less than 3, I will be getting no output. Why? Because I had mentioned the minimum of aggregation policy as 5. So I am now doing 3. So it is violating the principle. That's why it's saying query produce no results. Okay. This is all about aggregation policy. Now the next question is, if you want to see how many aggregation policies you have and what kind of policies you had applied, you can obviously go to information schema. You can say select star from table, and I will say information underscore schema dot, I will say policy reference, and then I will mention my policy name, and my policy name is this one. Copy paste here and put it in quotes. If I run this one, I should be able to see my aggregation policy inside my information scheme. Okay, similarly, I can see my aggregation policy inside my account usage, that if the aggregation policy is active or not. See, there is a column called policy status, which is saying active. And if I want to see that in account usage, I will just say, as of now, I will just say select star from Snowflake dot account usage dot aggregation policies. And I will say where delete is null. This will show me all the policies which are now in active state. And see guys, it had produced no results. As you already know that information schema is real time and account usage schema takes some time to reflect the things in the table. So that's the reason it is not displaying. If you check after 3-4 hours, you will be able to see this aggregation policy here as well. Okay, that's pretty much about aggregation policies. Next up is projection policies. While aggregation policies control how you see data, which requires the grouping of the data, projection policies control what specific columns you are allowed to see in the result set. Projection policies allows you to define rules and helps in determining whether a column can be included or excluded in the output of a query. This enables you to prevent accidental exposure by avoiding unintended disclosure of any kind of sensitive data by restricting certain columns from being displayed in the output. Comply with regulations. It implements data minimization principles and shows only necessary columns as required. And third is customize data access. It tailors with what data users can actually see based on their roles and responsibilities. This is the syntax for projection policies. Here also we will say create projection policy, then name, then we return the projection constraint, and then comment is also, as we had discussed, is the important one to have, but it's again optional. Then the parameters which are required for projection policy, first one is obviously name. It is the identifier of the projection policy and it must be unique for your schema. Second is body, SQL expression that determines whether to project a column. The expression can contain case and other logic statements, but must be the projection constraint function. That is, projection constraint allow either true or false. And second is enforcement. Okay, if we talk about projection constraint, allow true allows the column to be projected and false prevents the column from being projected. Enforcement comes with two supported values. First is fail. The query will fail if a projected column is included in the outermost query. And second is nullify. All the rows in the projected column returns the value null. Let's see that in action as well. I will go to my Snowflake and first thing first, as I always do, I will say use role account admin. And then I will grant my create policy to, let's say, the already existing aggregate admin. Okay, so I will say grant. Previously, we had granted the create to the same aggregation admin role for my aggregation policy. Now I am going to grant projected policy to the same role. So I will say grant create projection policy on schema, and my schema name was privacy underscore lab dot policies to my role, which is my aggregate admin role. And then I will also grant apply privilege, apply projection policy on account to role aggregate admin. Cool. And now I will run these three scripts. Perfect. Perfect. Next up is I will again move to the role, use role aggregation admin, and we will stick to this role now. And then I will again say use my schema, which is my privacy labs dot policy one. I will just copy paste from here. Perfect. And now I am going to create my projection policy as well. Create or replace projection policy. I will name this as, let's say, p hide columns. I will say as returns projection constraint. The constraint should be case when my current role is account admin. Then I want projection policy. Then I want projection constraint as allow is equal to true. Else I want my projection constraint as allow is equal to false. Cool. And I will end this one. And now I will run these three scripts. Perfect. Perfect. Again, I am going to use account admin role to create a table, and this is also something which is optional. If you already have table, I am really not having table. That's why I am using this create or replace table privacy lab dot public dot protected customers, and I will just say select star from my Snowflake sample data tpch.sf1.customers, and I will, let's say, limit this one as 1000, and I will run this one, and I will run both of them. Perfect. And now I will again switch back to my role, and I will assign my projection policy. I will say alter table, this table, copy paste here, and then modify, because projection policy is applied on columns. So I need to apply this on column, modify column. There is a column called C underscore phone, and I will set my projection policy, and my projection policy name is this one. I will copy paste. And similarly, I will assign this policy to one more column. I will just copy paste this one only, and instead of C phone, I will change this to C for C underscore account balance. Okay, these two are very crucial columns, phone and account balance. So that's why I chose these two columns to apply this projection policy, and both the scripts had ran successfully. It's the very time that I use other role to test whether the things are working or not. First thing, obviously, I will do select star from my table. What do you think, guys? Will this script run now or not? Let's think. Earlier, we had seen that in aggregation policy, this script failed because it was missing the aggregation. But now we had implemented the projection policy. If I run this script, do you think we will get data? No, right? We won't getting any data. We will still getting the error as SQL compilation error, because there are two columns on which we had applied projection policy, and we cannot have those columns as part of our select query. And I am doing select star. So when I am doing select star, I am actually including these two columns as well, which violates my projection policy. So if I run this one, I will get error as the following columns are restricted by projection policy. Please remove them from the list of projection policy. Make sense? Perfect. So now what I will do is I will skip the part and create two more select statements. So I had written two more select statements. This time, instead of star, I am mentioning the other columns which are not C phone or C account balance. So this time, do you think this query will run? Definitely yes. This query will run and it will give me the results as expected. Okay. I had written one more query where I am mentioning a filter based on this projected column. Do you think this will run? Definitely, guys, this will also run. That's the main intention of showing you this projection policy. You cannot query it, but you can obviously filter the results based on the projection policy column. Okay, so if I run this, I will still be able to see the data, but I am not able to see the account balance for a specific column. I can just filter the column. I cannot include the column inside my select query. Okay, again, for viewing the projection policy from information schema, you can write something like this and you can run this one, and you will be able to see the projection policy which we had applied on two columns, and you can see both the columns here, account balance and phone, and you can see the policy status is active, right? That's pretty much about projection policies, guys. Now let's discuss about data lineage and dependency. Data lineage is helpful in tracking the flow of data journey from its source to its destination, detailing transformation, dependencies, and usage. It helps with debugging data issues, example, identifying missing or incorrect records. It helps in understanding dependencies between tables, views, or queries, and it also helps in auditing and compliance tracking. Let's discuss about importance of lineage in Snowflake. First is data governance. It ensures that data is quite accurate, being consistent and following compliant with regulations. Second is impact analysis. It helps in understanding how changes in any single part of data pipeline affecting all the downstream processes and reportings. Third is debugging and troubleshooting. It supports quickly identifying the source of data issues anytime by tracing back through the lineage. And fourth is documentation. It provides a clear, comprehensive view of data flows for businesses, stakeholders, and auditors. The get lineage function enables user to retrieve data lineage information for specific tables and columns. The basic syntax for get lineage function is snowflake.core.getLineage. Then we mention the object name, object domain, direction. Then we have two optional parameters that are distance and object versions. If we discuss more about the arguments, the required arguments are object name. Object name is the name of the object for which data lineage information is retrieved. Second is object domain. This is the domain of the object, and the supported domains are column, table, which includes all the table-like objects, including views and dynamic tables. Then it also includes semantic views for semantic viewing and stages. And for ML lineage, we can use tables for feature views, which are dynamic tables and views internally. Then also we can use data sets or modules for models. Third one, required parameter is direction. The direction for which the lineage should be retained. Supported directions are either upstream or downstream. And then we have two optional parameters which are distance, the number of levels of lineage to retrieve. The maximum is 5, which is also the default distance. And then we have object version for versioned objects such as datasets and models. The version of the object for which lineage is retrieved. If not specified, the default version is used. Let's now discuss about object dependencies. Snowflake tracks how database objects are interrelated to each other using object dependency view in the Snowflake.account uses schema. This is essential for impact analysis, compliance, and maintaining data integrity. And object dependency exists when one object relies on the another object to function correctly. For example, a view created on top of table depends on the table's metadata. If we talk about dependency type, the first one is by name. You can refer any object using the name, like select star from table. Next up is by ID. The dependency is stored using an internal object ID. For example, creating a stage using storage integration. And next up is by name and ID. It is used in objects like materialized views that reference by both name as well as ID. If we talk about use cases, it is very useful in trace downstream objects before altering or dropping any kind of base objects, and it identifies the sensitive data lineage for GDPR or HIPAA compliance to ensure sensitive data is properly managed across its life cycle. It also understands the dependencies across consumers and the provider's account, but on a very limited visibility. It also automatically apply object tags from the referenced object to the referencing objects like views. If we talk about limitations, it does not track any session variable based logic. And second is it omits some function based calls. And third is there is no tracking for any kind of external or replicated dependencies. Let's see this in action. I will go to my Snowflake. First thing, we will create a database and schema. Then we will use the database and schema. And then I had created a sales table. And on top of sales table, I had created a sales view as well. Okay. This is my level 1 dependency. Okay. Then using the same view, I had created a second sales view. Okay. This is my level 2 dependency. Okay. And then also I had created a materialized view on top of my this sales view. This is again my level 1 dependency. So if I comment it down here, this is my level 1 dependency. This is my level 2 dependency. And this is my level 1 dependency again. Okay. Once I run these all, I will use the snowflakes.core.getLineage function, and I will pass my table name and the upstream or downstream dependency. Before running this query, let's run all the above queries. I will select all of them and I will click on Control plus Enter. and it started executing all my 8 scripts. And perfect. Now I will run this get lineage function, and I can see there are 3 records in the output. First is view and the other 2 are tables. And if you see here, it is even displaying my distance. So for my sales view and materialized view, which is sales summary, the distance should be 1. Okay, so if we just verify here, you can see sales view and sales summary, which is my view and materialized view, their distance is 1. But I had created a second sales view on top of sales view. That's why its distance is showing 2. Okay. This is how we get the lineage from the Snowflake. Next is object dependency. In order to get the object dependency, we have a table inside our account uses schema, and we can mention the referenced object name. And if we run this one, we should also be able to see the object dependencies. And see guys, I am able to see the object dependencies with my referenced object ID and the table on which it is dependent, and referencing object names and what is the dependency type, by name, by ID, or by name or ID. So in this case, dependency type is by name. That's how we can see the object dependencies and lineage dependencies. This is pretty much about object dependencies and lineage dependency, guys. Let's now discuss about object tagging. Snowflake object tagging is a data governance feature that allows you to categorize and track database objects such as tables, views, and columns, as well as account level objects like warehouses and users. Object tagging is a process for a database object to define a tag and can be used to identify the object and to implement the data protection and data classification, usage, and compliance. What's the tag? A tag is a schema level object that can define and assign to single or multiple different types of objects like tables, columns, views, etc. The maximum number of tags in an account can be 10,000. You can even assign multiple tags to any object. Please do remember the minimum addition required for tags is enterprise edition. In case of single object, you can set a maximum of 50 tags including the tables and views. And you can see the tags associated with the objects using account usage.tag reference and information schema.tag reference. Let's see that in action. I will go back to my Snowflake. First, I will say use role account admin. Okay, and then I will create a new database. I will say create or replace a database, and I will name this as, let's say, governance. And then I will create a new schema as well. We'll say create or replace schema, and I will name this as governance dot tags. Cool. And then I will grant the usage. I will say grant usage on my database, which is governance. And then I also need to grant usage on database governance to role, let's say DA analyst role. And then I will again do the same thing for schema. I will say grant usage on schema, and I will mention my schema name as governance dot tags. And now I will run these scripts. Perfect. I had ran all the 5 scripts. It's the very time to create a tag. I will say create or replace tag, and I will put the tags inside my newly created schema. I will say I will copy paste, and then I will say, let's say PI data as the table name, and then I will say allowed values. Okay, whenever you create tags, we need to mention the allowed values. Let's say I mention high, then medium, then low. Okay, and I will also mention a comment. This is my tag. Okay, and perfect. I will run this one. And perfect. I had created my tag now. It's the very time to alter my table and set this tag. I will alter table from my analyst DB. And I had already created one table earlier, which was employees table. So I will mention this tag there. I will say set the tag and I will copy paste my tag name, governance to, let's say, hi. Okay. And I will run this one. I had added a tag. I will add one more tag. This tag I had applied on the table level. Now I will apply one more tag to the column level. Okay. So I will again copy paste this one and I will say modify column, and I want to apply this tag on my employee name column, and I will set this as, let's say, medium. Okay. And I will run this query. Perfect. I had added both the tags. It's the very time that I should go to my information schema.tag.references table to see these tags. So I had written the script which is select star from table information schema.tag references, and I had mentioned my table name and it is table, so I had mentioned table. So if I run this select query, I should be able to see the tags. So see guys here. So I am able to see the tag schema, the tag value, and the table on which I had applied the tags, and applying method is manual. This is pretty much about tags, guys. Next topic is compliance and features of different Snowflake editions. Preparing for Snowflake Advanced Architect exam requires a deep dive into how Snowflake handles data sovereignty, security standards, and auditing. Unlike the core exam, the Advanced Architect exam focuses on designing solutions that meet specific regulatory requirements like GDPR, HIPAA, or SOC2. I had divided the compliance and features into compliance and the minimum addition required for each kind of compliance. The first one is SOC 1 and 2 or ISO 27001. SOC 1 and 2, which is also known as System and Organization Controls, and ISO 27001 are frameworks that verify an organization's ability to protect data and manage risk. SOC 1 focuses on internal controls over financial reportings, while SO 2 access operational controls for data security, availability, and privacy. And SOC2 is also called Trust Service Criteria. ISO 27001 is an international certification for maintaining an information security management system. Okay, the minimum edition required to have this certificate inside your Snowflake edition is standard edition. Next one is HIPAA support, a very popular one. HIPAA support refers to the tools, services, and processes implemented by healthcare organizations and their vendors to protect sensitive patient information and comply with the HIPAA security and privacy rules. It covers technical safeguards, administrative procedures, and physical security measures ensuring confidentiality, integrity, and availability of data. The minimum Snowflake edition required is business critical, and it also requires the business associate agreement to be signed with Snowflake. Third is PCI DSS. PCI DSS stands for Payment Card Industry Data Security Standard. It is a set of mandatory security requirements designed to ensure all companies that store, process, and transmit credit card information maintain a secure environment. The minimum addition required again is business critical. Next one is FedRAMP Moderate. FedRAMP is a federal risk and authorization management program. It is a US government-wide program that provides a standardized approach to security assessment, authorization, and continuous monitoring for cloud products and services. So the minimum addition required is business critical, and it is for the specific government regions. For FedRAMP, high minimum addition requires is VPS. Next up is CSA Star Level 1. This is a self-assessment. It is a free entry-level volunteer program for cloud service providers to document their security posture based on Cloud Security Alliance and the Census Assessments Initiative questionnaires. Okay, the minimum addition requires is obviously standard. The next one is HITRUST CSF. It's a common security framework which is a comprehensive risk-based security and privacy framework designed to help organizations manage data protection and regulatory compliance, particularly with sensitive data like protected health informations. And the minimum addition required is business critical. And the last one is personal identifiable information or personal health information. Snowflake provides a robust security framework for managing personally identifiable information and personal health information to meet compliance requirements such as GDPR, CCPA, and HIPAA. It handles sensitive data through a defense in-depth approach, combining automated data classification, encryption, dynamic data masking, and role-based access control. The minimum addition required is business critical for this as well. That's it, guys. That's pretty much about compliance and features of different Snowflake additions. Thank you so much for watching. Have a nice day. Let's cover lesson 1.3 that outlines the Snowflake security principles and identify use cases where they should be applied. And we will be covering everything about network security, encryption, users, roles, and grants. And we will also touch base on authentication parts. First up is network rule. In Snowflake, network policies and network rules work together to create a multi-layered security parameter. While they sound similar, but they serve different functions. Rules define the what and where, while policies define the allow or block. A network rule is a schema level object that identifies a set of network identifiers in Snowflake. It does not actually block or allow anything at all on its own. It simply creates a reusable list or definition that other security features can refer and use. If we talk about network rules parameters, the first is mode. Mode indicates whether the traffic is coming in or going out of the Snowflake environment. There are two modes supported by network rules. Those are ingress. It is for the traffic to come into the Snowflake. Second is egress. It is for the traffic leaving the Snowflake. Next parameter is type. Type identifies the specific IP ranges or domain names or IDs in case of private connections. And third one is value list. It is nothing, just your IPs or CIDR ranges stored inside the networking rules. This is the syntax to create a network rule. We will say create or replace network rule with the name. Then we mention the mode, either ingress or egress. Then we mention the type, and then we also mention the value list, which is nothing, just the IPs. Next up is network policies. Network policies provide a critical layer of security by controlling inbound access to the Snowflake service based on the origin of the request. Network policies provide a critical layer of security by controlling inbound access to Snowflake services based on the origin of the request. This is the syntax of network policy. We will say create or replace network policy, then the name. Then we have a parameter as a load network rule list and block network rule list. If we talk about parameters, the first parameter, as you had already seen in syntax, is name. Name is the identifier for the network policy. It must be unique for your account. And next up is allowed network rule list. It specifies a list of network rules that contain the network identifiers that are allowed access to Snowflake. There is no limit on the number of network rules in the list. And third is block network rule list. It specifies a list of network rules that contain the network identifiers that are denied access to Snowflake. There is no limit on the number of network rules in the block list as well. As we had seen network rules and network policies, let's do hands-on, and I will go back to my Snowflake. First thing first, I will just check my current IP. I will say select my current IP address, and this IP address I am going to use for this tutorial. I will hit run and I am able to see my IP address. I will just copy paste this here. Now I am going to create a network rule. Once we create the network rule, we assign the network rule to the network policy. So I will say create or replace network rule, and I will name this as, let's say, my IP rule. Okay. And first thing I need to mention is type. So the type of this is IPv4, and then I need to mention the mode. Okay, and I will mention the mode as ingress, and then I will add some comment, which is a best practice to do. I had successfully created my network and I will run this network rule. Perfect, guys. I had successfully created my first network rule. It's the very time that I also create a user, And I guess you already know how to create a user. For that, I will say create or replace user, and let's say demo test user. And then I will say my password. Let's say 1234. And then I will mention the default role as public. Cool. And I will run this user as well. Perfect. It's the time that I set the network policy and assign that policy to this user. For that, first I need to create the network policy. So I will say create or replace network policy name, let's say demo network policy. And then I will say allowed network rule list. Okay. And I will mention my network rule. I will just copy paste here. And inside my single quotes, I will mention my network rule. And then I will add a comment saying that this is my network policy. Cool. And I will run this one as well. Perfect. Now my network rule is there, my user is there, my network policy is there. It's the very time that I should set the network policy for this user. So for that, I will say alter user, my demo test user, that network policy is equal to my network policy name, which is demo network policy, and I will hit run. As you can see, there is an error on your screen. This error came because while I had created my network rule, I forget to mention the value list. Value list is nothing. Basically, it's your IP. So I need to mention that as well. So I will say value list is equal to my this one, and all I will do is I will just rerun these all scripts. And perfect, guys, I had ran all the required scripts. It's the very time that I should log into this demo user with my password. I will sign out from my existing account and change my username to demo test user, and I will mention my password 1234, and I will do sign in. Once I do this sign in, I will go to my workspace. So as you can see that I am able to log into my demo test user. Reason because it's having the same connection. But if I change my connection from my current connection to anything else, I will be getting blocked by my network policy because it is not allowing anything additional than my current IP address. As of now, I am only having a single network connection, so that's the reason I cannot show you. But if you try to change your network connection and try to log in, you will be blocked by your network policy. That's pretty much about network policies and rules. If I conclude, network rules define network identifiers and are schema level objects, while network policies enforces the allow or block logic and are account level object. Snowflake manages data encryption keys to protect customer data, and this management can occur automatically without any need for customer intervention. And customers can use the key management service in either the cloud platform to manage their encryption, or they can use Snowflake managed keys as well. When enabled, the combination of Snowflake maintained key and a customer managed key creates a composite master key. This is very, very important to protect customer data in Snowflake. This is only known as Tri-Secret Secure. All Snowflake customer data is encrypted by default, and Snowflake uses strong AES encryption, with a hierarchical key model. A hierarchical key model, it's a framework for Snowflake encryption key management. It is composed of 4 layers of keys in which each higher layer of keys encrypt the layer below. This is hierarchical key model and rooted in the cloud provider hosted hardware security module. Okay, always remember Snowflake uses AES encryption with the hierarchical key model to protect your hardware security module. This is the four levels of keys in which each higher level of key, we can say parent key, encrypts the lower below. So we have 4 level of keys: root key, account master keys, table master keys, and file keys. Okay. Now, if I talk about encryption key rotation, keys in Snowflake managed key hierarchy are automatically rotated by Snowflake when they are more than 30 days old. Okay, very important to note. Second, active keys are retired and new keys are created. Okay, when Snowflake determines the retired key is no longer needed, the key is automatically destroyed. Cool. This is pretty much about encryption. Next up is external network access. External network access allows UDFs and store procedures to securely connect to network locations which are outside of the Snowflake environment. This feature is commonly used for data enrichment for any third-party APIs triggering external workflows or managing your ML models. This is the syntax of creating an external access integration where we mention the name, allowed network rules, allowed authentication secrets, and enabled. Unfortunately, external access is not supported for trial versions, but I will still take you to my SQL file and I will explain you how we can create it. I am into my Snowflake now, and I had earlier tried creating the external access, and as you can see, I got the error as external access is not supported for trial version, which we just had covered in our PPT. But I will walk you through the steps which we need to follow when you are actually creating the external access for your projects. First thing is we create a security integration, and for that definitely you need an account admin role. Here what I am doing, I am using this Google Translate authentication. So the whole purpose of these scripts are that at last, if I am passing my sentence and I am passing the language, I am getting the output in the same language. So it is converting my English text to that specific language. First thing, we create our security integration, and for that we need the parameters like type, authentication type, auth client ID, port, token, authorization, and all these scopes. Once you create the security integration, now I had recreated this for you guys. We create a secret by referencing this security integration, and then we will create a role, obviously, because we need to assign this secret to the role, right? So let me create that as well. Perfect. So now I will use my security admin role to assign this secret to my developer role. Cool. Now it's the time to create the network rule, and obviously this parameter is very important for my access integration. So I will create my network rule using the account admin role, and once it is created, the next step is that we should create the external access integration. Inside that we will mention this network rule, and then we will mention the secret name, which is auth token. We will mention that here, and then enabled is equal to true. But if I try to run this query, I will be getting the error that, hey, external access is not supported for trial accounts. But if you are doing the same in enterprise accounts, you should be able to run this based on your parameters. Once I run this, let's assume that this ran successfully. Once I run this, I will grant the usage on this integration to my developer role, as we had already seen multiple times. And after I had grant the usage, I will shift back to my developer role, and I will create a UDF which will take a sentence and a language and give me the output as a translation from that language. Okay, so this is a pretty much UDF which I had written. All the code and everything will be there in the GitHub, so you can obviously go and understand what this code is doing, but in high level it is translating my sentence to any specific other language. Okay, so once you create a function, you need to grant the usage of that function to your role. And once that is also done, you need to test the function. When you test the select query, you will be able to see the output something like this. That's pretty much about external network access. It's the very time that we discuss about access control privileges. Access control privileges are permissions that are granted to users, roles, or applications, defining what actions such as select, insert, or delete can be performed on specific database objects like tables, views, warehouses, etc. They ensure only authorized individual access sensitive resources, frequently managed by RBAC, to enforce the Snowflake principle of least privilege. Studying for Snowflake Advanced Architect exam requires a shift from knowing what privileges exist to knowing how they interact within secure architecture. You don't need to memorize the entire list. You need to understand the core functional groups in the access control privilege, right? There is a vast list of access control privilege, so it's tough as a human to memorize all of these things. So I had categorized the most important privileges into 5 parts specifically curated for the architect exam. The first one is the global privileges. These are account level privileges typically controlled or held by account admin or delegated to the specialized security roles. The first is manage grant. This is very crucial one as it allows a user to grant or revoke the privileges on any object they really don't own. It's essential for centralizing security management without using account admin profile. Next is create object. Please understand that create database or create warehouse and create user are the global and must be granted to the account admin. Third one is monitor usage. It's critical for cost optimization questions and allows non-admins to see credit usage and billing history. Fourth is apply policy. Architects must know that the role creating a policy is often different from the role applying to it table. Next up is warehouse privileges. Snowflake always separates the ability to use any warehouse from the ability to manage its cost. The first warehouse privilege is usage. It's required to run any kind of query. Without this, you cannot even turn on your compute at all. Second is operate. It's the ability to manually suspend or resume or abort your queries. Third is modify. It's the ability to resize, either scale up or scale down or change the auto suspension settings. Fourth is monitor. It is the ability to see the query history and load the charts for that specific warehouse. Third one is DB, schema, or table level privileges. For architect exam, we must remember that Snowflake uses a container model. To access a table, you need a chain of usage privileges. Database should be having usage privilege, schema should be having usage privilege, and table should be having select privilege. Then only you can see the table data. If a user has a select on a table but lacks the usage on the parent schema or database, they cannot even see the data at all. Fourth one is storage and integration privileges, and inside that first we have usage on integration. It is required to use a storage integration or API integration. This is the bridge between the Snowflake and your cloud provider. Next up is usage on stage. It is required for copy into or get or put files if you are working with internal stages. Third is read and write on the stage. It is specific to the internal stage for all kind of file managements. Fifth is advanced security privileges. These are ownership privilege. This is the most powerful privilege. It allows you to drop the object and grant privileges to any other object. Next is imported privilege. It is specific to Snowflake sharing. It allows a consumer to access data shared by a provider. Third is references. It is required if you are building foreign key constraint between the tables. How the tables will communicate with each other is known as references. It is rarely used for performance, but it is very common in DDLs. If there are some referential integrity, we mention this referential integrity inside the DDLs. The last one is the future grants. I had put that as 5.1 because this is the select privilege which we grant on all the future tables which we create in the respective schema, and these schemas are only those schema on which we already have the usage privilege. Next is private connectivity. Snowflake provides private connectivity to ensure data traffic between our cloud environment and the Snowflake service remains intact on the cloud provider's network's backbone, bypassing the public internet. Important to note that is this feature requires business critical edition for Snowflake account. Unfortunately, I have a Snowflake trial account on top of enterprise edition. When I was trying to run this private connectivity, I was getting this error of business critical edition. I will show you the error, but let's first talk about private connectivity options by cloud provider. Each cloud provider uses its native private networking service to connect to Snowflake. For example, for AWS private link, we need to connect with our Amazon VPC to Snowflake VPC using interface VPC endpoints. Second is Azure private link. It is required to connect Azure virtual network to Snowflake virtual network via private endpoints. And third is Google private service connect. It provides the private connectivity between your Google VPC to Snowflake VPC by making the Snowflake appear as a resource with a private IP address in your network. If we talk about key benefits, the first benefit of having a private connectivity is enhanced security. It eliminates the exposure to any kind of public internet and reduces the attack surface by directly using the private IP addresses. Next up is improved performance. It offers more reliable connectivity and lower latency through a direct connection on the provider's backbone. And third is simplified compliance. It helps meet strict regulatory requirements for data privacy in sectors like finance and healthcare, where data is very sensitive and we should be having a private connectivity between the provider and the Snowflake to ensure that it is a very secure environment and it is on the private IPs. Make sense? Let's see this in action. I will go to my Snowflake and this is my AWS private link file which I had created for you. You can find it on my GitHub. Okay. The first thing we need to key my current region, because on top of the region only you can create your private link. So as of now, my region is US West. So once you know your region, you need to go to your AWS account. You need to click on this CLI. I will do reconnect. And once you have the connection established, as of now it is taking time, I will go back to my Snowflake and I will run this script in my CLI. This script will give me my account identity. Okay, so I will come here, I will paste my script here and I will hit run. And once I run this, I will get my account ID. And once I got my account ID, I need to get the federated token, which is nothing, just the JSON file, which is required for my next parameter. So I will go here and I will copy paste this script. And once I run this script, I should be able to see a JSON file, which is required for my next parameter. Okay. The next is the Snowflake defined parameter, which is authorized private link, and it requires two parameters. First is my ID and second is federated token, which we had just generated here as JSON. So once you mention your ID and your JSON, you need to run this one. Okay. And when you try to run this one, you will get an error stating that business critical or higher edition is required for this operation. Please upgrade to the valid edition and then retry. So in this case, if you had already created the trial version on top of enterprise edition, unfortunately you need to create another Snowflake account on top of business critical edition, and then you should be able to run this script. Okay, as of now I'm just skipping it. Once you create this private link, you need to get the private configurations. Okay, the output of this will be the list of URLs and it will be having a private link VPC ID associated with it, and it will look something like this. Okay, and then at step 4 you will create the AWS gateway. In order to create the AWS gateway, you need to go to your AWS account. Okay, and you need to first, I will close this one, and you need to search here VPC. Okay, and it will take you to this VPC service. And here you need to create an endpoint. And in order to create the endpoint, you need to go to private links and you need to click on endpoints. And then here I will mention create my endpoint, and I will create a endpoint, let's say Snowflake private link. And then I will scroll down and I will come to my services, and in services, I need to select the respective services which are required. As of now, I am clicking on this one, and then I need to create a VPC. I have already created a VPC, so I will assign the VPC to this one. And then I need to mention my subnets. Okay, so I need to create few subnets. I have one subnet, so I am assigning this one and I will assign this here. And once you assign the subnets, you will be able to see the security groups which you have. I had already configured my security groups. If you don't have, you can create new security groups. And once you do that, you can obviously mention some custom policy or full access policy based on your requirement. As of now, I'm going with full access. And then you should just click on this create endpoint, and it had successfully created the private link for you guys. Okay, so obviously you need to configure this based on your requirements. Okay, as of now I just configured it based on demo purposes. It is starting, so that's why it is saying status is pending for this one. This is how we create the AWS gateways. Okay, once I had created my AWS gateway, I need to run this command, and here I need to mention my own VPC. And if this returns a private IP, like something like 172.31 or something very relevant to IP, this means the bridge is built between the Snowflake and your private link. This is how we work with any kind of private link. I had shown you demo with AWS. Similar we will follow in Azure and GCP. That's pretty much about private links. Let's now understand about user role and grants provisioning. Snowflake users and role provisioning uses RBAC to manage access to objects. Users are created with the default role. Roles are assigned to the users to bestow privileges like select, usage, and roles can be nested for hierarchical management. If we talk about users, these are the unique identities created via create user command, and we also mention the password. And the roles are the entities used to manage the privileges, and the grants are the privileges assigned to the roles. So you understanding the things, right? User is the unique identity, role is the privilege, and grant is the privilege assigned to the role, which is then obviously assigned to the user. This complete structure is known as hierarchy, where roles can be granted to other roles, allowing for privilege inheritance. And we will obviously see this in action in next 1 or 2 minutes. If we talk about best practices, always create a robust hierarchy, like read only should be granted to data engineer and data engineer role should be granted to sysadmin role. Next is SCIM provisioning. For enterprise environments, automate user and role provisioning using SCIM with identity providers like Microsoft Entra ID. And we should not be using account admin role for our routine task. We should assign the custom roles with the limited privileges only to do the regular work. And we should use show grants to user to audit permissions. Let's go to Snowflake and see these in action. First thing first, I will say use role security admin. And then I will create a rule. I will say create role if not exists. And then I will mention my name, let's say data analyst FR. Let's say this is my functional role, and that's why I had suffixed that with FR. Next thing, I will create two more roles. Those roles I will be using to build a hierarchy. Okay, so let me add comments as well. Okay, so first thing, this is my functional role. Okay, and now I will create two access roles. So I will say create access roles, and I will say create role if not exists, and let's say sales, and this will be my read role. And as this is access role, I am saying AR. And let me create one more role. I will say create role if not exists. I will name this as sales reporting right access role. So I will say AR. Perfect. And then let's build the hierarchy. I will say build the hierarchy. Maybe my spelling is wrong, but I know you understood it. So I will say grant role, read access role to role data analyst functional role. Okay, so I am granting the lower roles to the one step higher role. Similarly, I will just copy paste this one, and I will grant my reporting role as well to data analyst role. Perfect. That's pretty much and then I will grant my data analyst role to my sysadmin role. In this way, a complete hierarchy is built. It actually allows the custom roles up to system admin for the higher visibility. Okay, so let me go and say grant role, and I will copy paste this one to role sysadmin. And now I am switching back to my sysadmin role. I will add a comment as well. I will say switching, and then I will say use role sysadmin. I will create a database and a schema. I will say create database if not exists, and I will name this as, let's say, sales db, and then I will create a schema as well. Create schema if not exist, and I will say sales db dot, let's say, raw. And now I will move back to my security admin role. I will say use role security admin. Why I am doing this? Because in order to grant the usage on these database and schema, we should always use the same role by which we had created the roles. Okay, and the best practice for creating the role is to always use security admin. That's the reason I am moving back to my security admin role, and I will say grant usage on database, and I will copy paste my database name here, and then I will grant this to role read role, and then I will also grant the usage on schema sales db dot raw to role, same role. And guys, now I will grant the select on the tables. I will say grant select on all the tables inside my schema, this one, to role this one. So I will totally copy paste this one here. Now I will grant one more thing. I will grant future tables as well. Future tables in schema sales db raw to my this one. Perfect. Perfect. So now what happened is, as per this hierarchy, my read role is having usage on schema, database and tables as well as on future tables. And this read role is then assigned to my data analyst role, and then data analyst role is assigned to my sysadmin role. So directly or indirectly, sysadmin is having whole visibility of everything we had written so far. Now it's the time to create a user. In order to create the user, it is recommended to use user admin role, and then I will create a user. I will say create user if not exists, and I will name it as Sachin, and then I will mention the password as, let's say, 123, and then I will also say my default role when I first time log in should be my data analyst function role, and then I will mention one more parameter which is must change password. So when first time he tried to log in, he will be requested to please change the password. So I will say must change password is equal to true, and then I will grant this user to my data analyst role. So for that, again, I will switch back to my security admin, and I will say grant role data analyst fr, copy paste to my user, and my user is Sachin, and that's it, guys. It's the very time that I should select all of them and click on Control plus Enter to run all these 19 scripts one by one. Perfect, guys. Everything ran successfully. It's the very time that I should log out from my current account, and I should re-log in with my user account. I will click on my account identifier, and instead of this user, I will mention my name, and inside my password, I will say my password 123. And when I click on this sign in, I am redirected to the password expire, and this is why, because I had set that property to must change password is equal to true. So I will create a new password. Let's say Sachin at the rate 123456789, and here also I will mention same thing, Sachin at the rate 123456789, and I will click on submit. And I had logged in into my user account. If I go to my workspaces, I should be seeing automatically the default role selected should be data analyst FR. So I will immediately click on a SQL file. By default, it had selected a role of data analyst FR, and I am having the roles below that as well because of the hierarchy. So data analyst FR is the parent role, and then these roles are also visible because of the hierarchy which we had created. That's how you can work with users roles and grant provisioning. We had done these things in multiple times in other tutorials as well. So as you move forward, you will automatically be getting very much familiar because we will be repeating these kind of steps, because for many tutorials we had created roles, users to show you how these things work. That's pretty much about users roles and provisioning. Thank you so much for watching. Let's now discuss about authentication policies. Authentication policies allows admins to control users and clients to connect to respective accounts. These policies define allowed authentication methods, client types, mandatory MFA requirements. So basically authentication policy is something which admins control to ensure that how users should authenticate with the Snowflake account and which client types they should be using to make the connection. If I talk about key policy components, first is allowed authentication methods. You can restrict logins to specific methods such as SAML, passwords, OAuth, key pair, or programmatic access tokens. Next up is client restriction. You can restrict the client types either to SnowSite or Snowflake CLI or SnowSQL or any specific drivers based on authentication policies. And we will see that in action in next few minutes. Third is MFA enforcement. You had already seen how we can set up MFA, and the same thing you can obviously do with authentication policies as well, where you can set up the MFA and mandate the users to enroll for MFA. Fourth is programmatic access tokens. These policies can define the maximum expiration time and the network requirements for any token. Let's say you want that the token which user is having will expire after 6 months. You can do that, and that's the best practice to expire a token after some point of time. Let's see the authentication policy in action. I will go to my Snowflake, and in order to create the authentications, I will use security admin role. That's the recommended role. Okay, so I will switch back to my security admin role, and next thing is I will create a role. We'll say create or replace role, let's say authentication test role. Okay, and then I will create a user on which we will be testing if the authentication is working or not. So I will say, let's say tutorial user, and I will mention the password as, let's say, 123, and then I will mention the default role as well. When the user first time login, please, he should be having this role which I had just created above, authentication test role. Now I will grant this role to the user. Grant role authentication test role to user, tutorial user. Now I will again switch back to account admin role. And then I will create authentication policy. You can obviously create an authentication policy with security admin. There is no restriction on that. But as practice, I create all my policies, all the things using account admin role. I will say tutorial limit, let's say policy. Okay. And first thing I need to mention is authentication methods. Okay, how I want my users to log into my account. Let's say I just want the users to type their password and get login into their account. You can obviously mention your Active Directory or single sign-ons. Next thing is I will mention the client types. Okay, that which Snowflake instance they should be accessing, either Snowflake CLI or SnowSQL or command line or Cortex CLI, which client type they should be accessing. Okay, first I will only mention SnowSQL as I want to show you the error. Okay, and after that I will mention the Snowflake UI. The last thing is comment which is a best practice. I will say policy ABC and perfect. And once I had created the authentication policy, I need to apply this authentication policy for the users. For that, I will say alter my user, and my username was tutorial user, and I will set my authentication policy here. My policy name I will copy paste. And then I will run these scripts. I will say Control A and I will hit run. Perfect. I had ran all my above scripts. It's the very time that I should first see my user, then I should see my policies tutorial underscore user. I will hit, and perfect. I am able to see my user on all those things here. Let's also see my authentication policy. So I will just show all my authentication policies in this account, and I should be able to see this policy. And see guys, here I am able to see my authentication policy and the database on which I had applied the authentication policy, the owner and authentication kind and the role, everything is displayed here, which is good. Now I will log out from my account and I will log into this user. Okay, I will copy paste this user and I will log out from my main account, and yeah, and then I will try to log in with my user and I will mention my password. And as you know that inside my authentication policy, the client type which I had mentioned is SnowSQL, but this is not SnowSQL, as you know, right? This is Snowflake UI. So if I hit sign in, I should be getting the error, right? So let's do that. And see guys, authentication attempt rejected by the current authentication policy. This user is only allowed to enter the Snowflake using SnowSQL. There is no other way that tutorial user can access Snowflake. This is the beauty of authentication policy. Let me go back, and this time I will change my SnowSQL to Snowflake UI. And then we will try to log in again. Okay. And now instead of my SnowSQL, I will say Snowflake underscore UI. And I will run all the scripts again. Okay. And perfect. Now let's again log out from my main account and try to re-log in using my tutorial account. In this time, I will again mention my username as tutorial user, and the password I will mention 123. And this time, if I click on sign in, I should be redirected to my Snowflake UI because I had mentioned my client type as Snowflake UI, right? Let's hit sign in. And see guys, this time I am not getting the error that authentication is failed. I am very successfully able to log into my tutorial user account, and I should also be seeing here my default role once it's open. So see guys, see authentication test role is there and everything is there, and I can able to see my Snowflake default database. This is how authentication policies work. You need to understand that authentication policy plays a very critical role if you are working as an admin and also from the advanced architect point of view. Please take notes and please do practice this out. Now let's focus on authentication. Snowflake has fully modernized this authentication landscape. Password only access for human users is being phased out in favor of strong authentication, and service accounts are moving towards purely programmatic methods. So first is multi-factor authentication, the most popular one. So it is the second lock on the door. It is very important and advisable for all the users accessing Snowflake via UI to have MFA connection established. Let me quickly show you how you can add MFA in your Snowflake account. On the bottom left, click on your profile and go to settings and go to authentication, and here you will be seeing an option called multi-factor authentication. Click on add new authentication method, and it will ask you to which authentication you want to add, either passkey or authenticator. Let's go with authenticator, and it will ask you to scan this app, download the Microsoft Authenticator application, and pass the code here in order to continue. Okay, this is how you can establish MFA on top of your username and password. This is very recommended approach. Second one is federated authentication and SSO, single sign-on. So federated authentication separates identity providers from the service. And so SSO is the result of this setup, allowing users to log in once in their corporate network and access Snowflake without a separate password. Snowflake redirects the user to the IDP like Okta or Azure Active Directory. Once the IDP verifies the user, it sends the digital token back to Snowflake that, hey, you can grant entry to this user. So this is pretty much about SSO. Mostly all the enterprise using this SSO feature, and they are having all these tokens established in the AAD, Azure Active Directory, and it is sending back the Snowflake grant entry. And this is how all the enterprises are now working. OAuth is used to secure application to application communication, and instead of sharing password with third-party tools, tool receives a temporary access token. There are two types of oath. First is Snowflake oath. This is Snowflake where act as an authorization server, and second is external oath where you need Okta or Azure to issue the token to the third-party provider. This is the new for 2026 is the Snowflake oath for local application is now preferred method for desktop app scripts and local applications, removing the need for users to store any secrets locally. Fourth one is key pair authentication. This is the gold standard, and it uses a public key and private key. And public key is stored in the Snowflake and private key is given to the developer so that they can access that and log in into the Snowflake account. So this is pretty much about authentication. Next up is security integration. There are two things related to integration before I talk about security integration. One is storage integration and second is security integration. Both are integrations. Both are actually bridging the gap. One is bridging the gap between Snowflake and your provider, and security integration is bridging the gap between the security and the Snowflake. Let's understand the definition. Security integration is an object that acts as a bridge between Snowflake and external security services, while an authentication policy, which we just looked at, defines the rules. Security integration enables the mechanism for external communications. Okay, this is very, very important, guys. Authentication is for rules and security integration is the mechanism. Let's understand the core types of security integration. There are four primary categories for security integration, which is very important for advanced and architect exam. First is external OAuth. It is used when you want to allow third-party tools like Tableau or Power BI or any custom Python application to access Snowflake without sharing a username and password. Okay, the use case is if you want to connect a dashboard, so it uses the viewer's identity to run the queries. Next up is SAML one. This is the most widely used one, and more than 90% of organizations are using this way for security integration. And this is the most common integration for enterprise environments. It connects the Snowflake to identity providers like Okta or Azure Active Directory or even Google Workspaces. The use case is it allows employee to just by a single clicking, they can easily go into the Snowflake portal. Third one is SCIM. SCIM is for cross-domain identity management. It automates the user management. When you add a new data engineer to your Okta data team group, SCIM automatically creates the user and assigns their roles in the Snowflake. And fourth one is API authentication. It is specifically built for Snowpipe REST API or SQL API using key pair authentications. These four types you should definitely learn: external OAuth, SAML2, SCIM, and API integration. That's pretty much about lesson 1.3. With that said, I want to congratulate you as we had successfully covered domain 1. Please do like the video if you are really enjoying it. See you in the domain 2. Thank you so much for watching. Have a nice day. Bye bye. Let's now start with lesson 2.1, that is outline the benefits and limitations of various data models in the Snowflake account. First up, we will be covering data models, and then we will be covering the use of key and column constraints. Those are enable, rely, and validate. Let's discuss about very interesting topic, that is data vault. Think of it as data vault is like a set of super smart building blocks designed specifically for holding your data. Okay, and these blocks are not just for building any old structure, they help you create an organized, easy to understand, and super flexible data that can grow and change as much as you need it. Okay, it is completely super flexible way to create, organize, and store your data. If I go to the definition, Data Vault is an agile, scalable model method for enterprise data warehouse designed to handle large scale historical data integration from multiple sources. It uses a hub and spoke structure. Okay, this structure have three core components. That those are hubs, links, and satellites. We will come into that one by one in 1 minute or so. To separate business key from descriptive context, okay, allowing for easy incremental updates without disrupting your existing data structure. So this is really cool. It is a very flexible way to have your data structured. Okay, it consists of three core components, and as you just listened that it uses a hub and spoke structure, which obviously consists of three core components. The first one is hub. Think of a hub as the main landmark for your data city. It's the central point for everything related to a specific business concepts. Imagine we have a hub for customer. Okay, this hub only stores the unique ID. Okay, it don't store anything else than unique IDs, maybe their names. Okay, it's like the city hall for your customer data. Okay, so as the definition say, hubs are only used to store the unique business keys. Okay, and next one we have links. Links are like roads and bridges connecting all the different hubs together. Okay, if we have a hub for customer and we have another hub for product, okay, a link block would connect them to show that a specific customer bought a specific product, right? It is a connection between multiple hubs. Okay, it's like a highway connecting the customer to the product warehouse. Cool. Lastly, we have satellites. Satellites are like the buildings that hold all the detailed information. Imagine customer hall has many floors. Okay, each floor represents a different satellite. One satellite might hold the customer address, and even another might store their contact information or other information, and another might track even their preferences. So this is hub, links, and satellites, where hubs are used to store the business keys. Links are used to represent the relationships between the multiple hubs, and satellites store the descriptive time variant information about all the hubs and links. If I talk about the key benefits, the biggest benefit for Data Vault is scalability. It is very efficient to manage even petabytes of data, because we just need to create the hub, link, and satellite, and we just connect the dots and our work is done. It is very flexible, as self-explanatory, because we can easily adapt all the business requirements and even the new requirements very easily. It is very good for auditability. It provides a complete historical, immutable records of data, and it is really a good example of automation. Let's discuss about two of the most common database schema types for organizing analytical data, that is star schema and Snowflake schema. What is star schema? A star schema is a way of structuring your data to make it easy to understand and fast to query, especially for reporting and dashboard uses. So at the center, we have a fact table. okay, which contains all the measurable business data like sales, clicks, revenue, inventory changes, etc. Around it, we are having the dimension tables that add the context to each fact, right? So if you see, the dimension tables are not having any kind of sub dimension table. So these are denormalized, okay, meaning it stores all the descriptive information in one place only instead of defining more subcategories, right? So it is storing all the information in one place, and this makes this kind of schema as star schema. When it's come to performance, it is very, very fast, and it is very optimized for reporting and dashboard use case purposes. Okay. Now let's discuss about Snowflake schema. Snowflake schema use the same basic concept as the central fact table connected to dimension table, but but with more structure. Okay. It means we are normalizing the dimensions. Okay. In Snowflake schema, dimensions are normalized, meaning they are broken down into subtables. If you see here, dim customer is further broken down into two more dimension tables: dim customer city, dim customer country, right? Same way, other dimensions are also broken down into other subtables. Okay. So it actually creates a hierarchical model, which is very, you know, hard to maintain, and it is not optimized for performance, but it still is very useful because it is reducing the redundancy across your data. So Snowflake schema is very best for that. It is known for reducing your redundancy, and it normalizes your data. Cool. Let's now discuss about the difference between star and Snowflake schema. So if I talk about the structure, a star schema stores all the related dimensional data into a single denormalized table where product name, category, and brands all sit together. We just seen that. While the Snowflake schema splits the same data across normalized tables. Okay, it divides the data into more sub tables. Like for one for product, we will be having other tables like product category, product brand as sub tables, right? This makes the star schema flatter and easier to query, while the Snowflake schema more accurately reflects the real world hierarchies. Okay. And next is ease to design. A star schema is very easier and faster to design because it avoids any kind of normalization, and you create the fact table with the few dimension table. This is very straightforward. And but while in Snowflake schema, it requires more forethought. Defining hierarchies is very important here. You need to normalize the data, and splitting dimension into subtables is also very important. And also you need to maintain the relationships between those tables as well. So that makes a star schema a good fit for ad hoc reporting, while Snowflake still works better for long-term structuring, right? You notice things, right? You notice this, right? Snowflake schema is focused on structuring the things. Okay. So it actually increases the reusability of the tables as well, right? Now let's talk about the query speed. Obviously, star schema often run faster because we are having fewer joins to make. Okay, and it is a big win for your large data sets. While the Snowflake schema introduce more joins, as we are having more hierarchical tables, so more joins, more normalized tables, more joins. We know that. So which actually slows down the performance unless it is very well optimized. Okay. That said, there is another out of context point. Nowadays, even cloud data warehouses are very intelligent, and they are having a very intelligent query plannings like Snowflake and BigQuery have. And anyway, this performance gap is narrowing down now, but it will still take a couple of years to really narrow down to the level of star schema, but it's work in progress from many big companies. Fourth is storage. A star schema duplicates data, obviously, because we are storing all the information in a single table, and we are repeating multiple rows here. So it will obviously take the more storage. Okay, because we are having duplicate data in the same table, but in Snowflake schema stores the unique value only once because we are reducing the duplication and actually saving the space. Okay. That actually translates to lower cost in cloud environment where storage also adds up, right? So this is the perk in favor of Snowflake schema. If I talk about updates, so a star schema can make updates painful. Changing a category name might mean updating thousands of rows because we are having duplicate data. So updating star schema is very, very painful, guys. Okay. But when it's come to Snowflake schema, you just need to update a single entity in the related dimensional table and you are done. So that is something which is very, very efficient when it's come to updating the data. Okay. And last point is debugging. A star schema can obscure the data lineage since values are obviously packed into a single table. So debugging is not going to be an easy task here. But in Snowflake schema, it keeps the relationships very clear, and that makes it easier to track issues or audit the data. Okay. This clarity is crucial in industries with the strict compliance or data governance needs, as you know, right? So this is the pretty much about star schema and Snowflake schema. There are pros and cons for each and every of these things, but majorly star schema is denormalized and Snowflake schema is normalized. When it's come to performance, star schema will give better performance and Snowflake schema will lag. But now this gap is also narrowing out. This is still out of context, but you should know that this process is also going on. Okay. Storage, star schema will be more costlier compared to Snowflake schema. Okay. And update is really very painful in star schema, guys. Really very painful. Okay. But in Snowflake schema, it is very, very easy. Just go to the related table and update it on the one entry and you are done and dusted. Okay. That's pretty much about star and Snowflake schema. Let's now discuss about use of key or column constraints. In Snowflake, key and column constraints on standard tables such as primary key, unique key, and foreign key are largely not enforced. Instead, they serve as a metadata for data modeling and query optimization. The properties like enable, which is used for metadata, rely, which is designed for Snowflake query optimizer, and validate, which check the existence of data, control how Snowflake treats these constraints. To be very honest, these constraints exist, enable, rely, and validate, but they are really not enforced and no one is strictly enforced by Snowflake. Okay. But you should know where you need to use them and where you don't need to use them. Okay. By default, Snowflake don't enforce them. It's up to the business use case. If we discuss about constraint properties, first is enable and disable. It specifies whether the constraint is active as a metadata or not. For standard tables, even when enable is set, Snowflake does not enforce the constraint as we had just discussed, right? For check constraints, enable is the default and required. Disable is not supported for the check constraints. Next up is rely or no rely. Rely tells the Snowflake query optimizer that it can trust the data adherence to the constraints even though Snowflake is not enforcing it. It enables performance optimizations like join elimination, whether the optimizer removes the unnecessary joins if the result can be determined from a one table alone. If you set rely but the data violates the constraint, the query may return incorrect or unexpected result. This is the warning provided by Snowflake. Last up is validate or no validate. These determines if the Snowflake should check existing data for compliance when a constraint is created or altered. For standard primary key, unique key, and foreign key constraints, specifying validate is generally not supported for existing tables and is primarily included for syntax compatibility with other databases. For check constraints, validate is the default one for all the new tables and it ensures the existing rows comply before the constraint is applied. With that said, we had covered the lesson 2.1 as well. See you in the next one. Let's now discuss about lesson 2.2, that is design data sharing solutions based on different use cases. There are multiple use cases today we will be covering, like sharing with the same organization, sharing with the same cloud, sharing with the different cloud, sharing outside of the organization, sharing to a non-Snowflake customer, sharing to a customer, creating a readers account. Then we will be shifting on Snowflake marketplace, then data exchange. Then we will be discussing about the data sharing methods, best practices, and what are the the benefits, and we will also cover about cross cloud auto fulfillment. First up is sharing within the same organization or same Snowflake account. Sharing data within the same Snowflake organization or account utilizes secure data sharing, which enables read-only access to live data without copying or moving it. Data providers create a share, grant access to the specific data objects, either tables or secure views, and add consumer accounts typically within the same region. If we talk about the key concepts for same organization or account sharing, the first concept is no data movement, because you are sharing data live and updating the provider account immediately ensures that the changes are visible to the consumer account. Next up is storage and compute cost. The provider pays for storing the data while consumer pays for the compute resources used to query the data. Third concept is read-only access. Shared databases are always read-only. Consumers cannot modify data or create new objects in the shared database. Fourth is scope. Sharing is typically intended for different Snowflake accounts within the same region. Let me go to Snowflake and show you how you can create the share within the same organization. Quick disclosure is that I am only having a single account, guys. As you already know, I am using the trial account. Because I am not having multiple accounts, I cannot really show you how the sharing works, but I am still providing you the complete end-to-end scripts. Okay, you can literally use them if you have more than one account, and you will be definitely seeing what I will be talking about sharings. In order to share with the same organization, first thing, I had created some database and schema, and I had also created a table, and then I had inserted some dummy data into the table. If you have to share the data, definitely you need to create the share. That's what I am doing on line number 17. I am creating a share named sales share, and then I am granting the usage to my sales share for database and schema. And once the usage is granted for database and schema, I am going to grant the select of the table to my share as well. This is the very first thing which you need to do. And after that, I will need to add the consumer's details. Okay, for that, I will alter my share and I will add the account detail for my consumer. Okay, so here my organization will be same because I am sharing with within the same organization, but the account name will be different. So I will be passing those details inside this commented section, and I will hit run. After that, I will go to the consumer's account. Okay, let's say I will move to another Snowflake account, and in that Snowflake account, I will first use the account admin role to see the shares. And once I am able to see the share which I had already shared with the consumer, I will create a database on top of the share. Okay, and I will grant the usage to the role which I will be having in that consumer account. Okay, so here I had written analyst role, but I am removing this and I am just adding here a comment as role. So you can just mention your role and you are good to test this whole script. Okay, and once you had grant the usage, it's the very time that you write a select query on the table which you had created inside your account. There are three steps which we had followed for sharing within the same organization. First is we had created the share. Second is we had granted all the relevant access to the share and assigned the share to the account. And third one is we had logged into the consumer's account and created the database from the share which we had shared from my provider's account. That's pretty much about sharing within the same organization. Please do go through these queries and try to run that in your systems if you have more than one account. Next up is sharing within a cloud region. Sharing within the same Snowflake cloud region is achieved through direct shares, which provides instant read-only access to live data without moving or copying it. Both provider and consumer account must exist in the same region, allowing for 1:1 or 1:many sharing, where consumer will only pay for the compute cost. If I talk about key aspects of same region sharing, first is performance and cost, because actually you are doing zero copy cloning and it eliminates the storage cost for the shared data, and data is really never moved or never copied, and it also ensures the live updates. Second is security. Data is shared directly from the provider database to the consumer account. Secure views can be utilized to restrict the access. Third one is mechanism. Providers can create a share, add objects, and grant access to the specific consumer account. That's the mechanism. And fourth is limitation. The limitation here is that shared database are read-only and cannot be reshared further with other consumer. Okay, if provider is sharing with consumer, that's well and good, but consumer cannot be sharing with other consumer. He cannot become provider for next consumer. Okay, there should not be any kind of transitive dependencies. Let's see this in action. I will go back to my Snowflake. Again, guys, this is the complete end-to-end SQL script for sharing within the same account region. First thing first, I will use my account admin role and I will create a warehouse, okay, sharing warehouse, and I will mention my warehouse size and auto suspend, and I will again create a database, schema, table, and I will do some dummy inserts. Once I had done all these prerequisites, I will again create a share. Okay, I had created a new share named finance share, and then again, which we had repeated for sharing with same organization, we need to grant the usage for database and schema and select for the table to my share, which is finance share. Once this is done, I will add the finance share to the account. Okay, I am sharing with the same cloud region. So here org name and account name will be the target's account identifier, which I will be passing. And once I hit and run this query, my finance share will be assigned to the respective account identifier. Once I had done these things, it's the time to go to the consumer's account. Okay, you move to the consumer's account, other person will log into his account. Then first thing, he will use the account admin role and see all the shares. And on top of the share, he will create a database, and then he will grant the usage on database schema and select on the tables. And when he will try to query, he will be able to see the data. If you had noticed that sharing within the same organization and sharing within the same cloud, both share kind of similar scripts. Only the major difference is in the alter statement. That's pretty much about sharing within the same cloud. Let's now come to sharing across cloud regions. As of now, we had seen within the same cloud region and within the same organization. It's the very time to go one step ahead and discuss about sharing across cloud regions. Sharing data across Snowflake regions require data replication to move data from source region to consumer region, enabling secure access across different cloud providers, either AWS or Azure or GCP. This process involves creating replication groups to sync your databases, creating shares from the replicated data, and then using listing for the easy consumptions. If I talk about key concepts and steps here, the concept which sharing across cloud region is replication groups. You must use replication groups to add database and shares for replication to target regions. Next concept is enable replication. An organization admin must enable replication for both source and target accounts. Third one is replicated database to the share. The data must be replicated to the secondary region, okay, before it can be shared, as data sharing is limited within the same region. So whenever you are moving across the accounts, you need to replicate the database within the secondary region first, then only you can share with the consumers. Fourth one is listings. It is the easiest way to share data across regions and cloud providers using Snowflake listing. Okay, you can obviously replicate the data and share, but there is an easy way to do that. That is listing, which supports auto fulfillment and cross region sharing automatically. Let's now go to Snowflake and see this in action. These are the scripts for sharing across the cloud regions. Here, first thing first, we set the replication policy to allow. Okay, after using the account admin role, then we create a replication group. Without creating a replication group, you really cannot share the data across multiple regions. You need to replicate the data to the secondary region, then only you can share with other cloud regions. Okay, so for that we will create a replication group, and replication group demands three parameters. First is types, then allowed databases, then allowed accounts. Once you define the replication group, you need to create a replica of your replication group in the primary account. And once you create the replica in your primary account, which is obviously read only, you will refresh the replica so that all the changes will come into your cross region share group. And once that is done, you will create a database in your secondary account from this replica. Once this is done, you will go to your secondary account or consumer account or whatever other person is there. He will open the account, he will create the share, and once he create the share, he will grant the usage, grant the schema, grant the select. And after doing all of this, he can just assign the cross region share to the respective target account. This is how sharing across cloud regions in Snowflake works. Next up is sharing between different Snowflake accounts. Sharing data between Snowflake accounts in different organizations is primarily achieved using Snowflake data sharing, which enables secure real-time sharing without copying data. Data providers create a listing which can be shared across different regions and clouds, while consumer access this data read-only. The process involves sharing metadata via the service layer, where the provider grants access to the specific databases and views, and the consumer creates a database from that share. If we talk about the key aspects of cross-organization sharing, first aspect is listing and data share. While direct sharing works within the same organization, data listings are typically used across different organizations and regions. We had just discussed this, guys, that how important is data listing when you have to perform sharing across other Snowflake regions or accounts or cloud provider. Cool. Next is no data movement. Data remains in the provider's account. Consumers query data using their own compute resources with no data storage cost for the consumer. Third is setup requirement. The provider defines a share. He grants the select privilege on the specific objects to the share and grant usage on the database and schema. And this is something we had already covered a lot of time. You should already be knowing the setup requirements. Fourth one is consumer access. The consumer creates a new database from the shared listing to access the data. Okay. Fifth is security control. Data is shared read only. This is valid for any kind of sharing. Whenever you are sharing, the data is read only. The provider can revoke access at any time. This is also universal valid thing. It is not only for sharing between different Snowflake accounts. It is valid for any kind of sharing. And last one is cross region or cloud. For cross region sharing, the provider must need to use replication to move data to the consumer region or rely on listing mechanism that handle cross cloud functionality. Till the time we had covered these things, guys, I guess you had already understood what is sharing and how exactly we are sharing. Whenever we are sharing within the same region, same organization, we have secure data sharing or data share. But when we are talking about external providers, we have to do data replication to the secondary accounts, and then we can share them, or we need to use Snowflake data listings, right? This I hope you had really understood. Now it's the very time that I will take you to my Snowflake account and show you the scripts for sharing between different Snowflake accounts. These are the scripts for sharing between different Snowflake accounts. First thing, I will use my account admin role. Then I will create a share. And once I had created the share, I will grant the usage on database and schema. And after that, on top of my table, I will create a secure view. And this is the best practice to use secure views for the external stages. Once this is done, I will grant select on my newly created secure view to the share which we had created, that is partner outbound share. Once this is done, I will assign this share to the newly account identifier. And once this is also done, that consumer will go to his account and he will first select the account admin role, and then he will create a database replica from the share. And once this is done, he will again grant the usage on database and schema and select on all the tables. And once he had done these things, he should be able to see the data which we had shared. This is how sharing between different Snowflake accounts work. Next up is sharing to a non-Snowflake consumer. Sharing data with non-Snowflake consumers is achieved using the reader's account, which allows you to create a secure read-only Snowflake account for them. The provider covers the cost and it enables real-time access to shared data without requiring the recipient to have their own cloud contract. So basically, whenever you need to share with a non-Snowflake consumer, you just need to create a reader's account for that person. Now I am back to my Snowflake and I will show you that as well. First thing first, obviously I will use the account admin role to do all these things, and then I will create a managed account. Okay, managed account here means the reader's account. I will mention the admin name and password and type as reader, and this will create the reader's account. And once this is done, I will see the managed account. I will retrieve the URL for the customer. The main reason of showing the managed account is I will retrieve the account name and URL for the customer, which I have to share with him via email. Once this is done, I will create a share for the reader's account, and then again I will grant usage on database and schema and select on the table. And once this is done, I will assign this reader's share to the reader's account. This reader's account I can found inside my show managed account details. And once this is done, I had set up the reader's account. My work is done. Now I will share the URLs and the other details with the reader via email, and then reader will log into his account. And once he will log in, he need to create the warehouse first. If the provider had not created, this is the optional step, because usually providers create the warehouse for them. But if it is not created, then first thing he need to create the warehouse, and then he need to create the database from the share which had been shared by the provider. And once this is done, he should be able to see the data using the select query. And guys, if he is not able to see, then obviously you need to grant the usages on database schema and select on the tables. And after you do that, he should be able to see the data. Next up is sharing across cloud providers. Sharing data across different cloud providers, either AWS or Azure or GCP in Snowflake, is achieved by replicating data to the target region and using Snowflake secure data sharing feature, that is listings. This allows for zero copy sharing or replicated sharing, reducing the need for ETL. The process involves setting up replication, creating shares from the replicated database, and managing access controls. If we talk about the key aspects of the closed cloud sharing, the first is replication is required here. Data must be replicated to the target cloud or region to allow access, enabling sharing across AWS, Azure or GCP. Second is secure data sharing. Replicated databases are used to create shares, allowing consumers to query data without even moving it. Third is Snowflake listing. This approach supports automatic fulfillment and it enables the data sharing across clouds with options to monitor usage and charges for data access. Next one is direct share. Direct share is mainly for same region sharing. It can be combined with replication for cross cloud scenarios. And last one is governance. All the fine grained access control and security are maintained throughout the process. Let's see all the scripts for sharing across cloud providers in the Snowflake. In order to share across the cloud providers, first thing I need to enable the replication for the target account to the another cloud. For that, I need to set is replication allowed as true. Once this is done, I need to create the failover group. And once I had created the failover group, I need to log into my consumers account and I need to create a failover group there as well as the replica of my original failover group. Okay, once this is done, I will refresh my failover group and I will create a database replica on top of the failover group. After that, I should be able to do the select star on the tables. Now let's discuss about the very interesting topic and very famous topic that is data clean rooms. It's the native data collaboration solution between multiple parties without even directly exposing the raw data. And it actually allows the organization to combine and analyze the data sets within a governed environment to gain insights while ensuring the compliance with privacy regulations like even GDPR or HIPAA or CCPA. For example, there are two companies. First is Xbox and second is Epic Games. As you know that both of them are competitors, but they still wants to know how many users have both Epic Games Pass and as well as Xbox Pass. With only one side of data, they can't know, right? They can't know that how many users of Epic Game is also active users of Xbox and vice versa, right? So what they will do, they will create a data clean room, okay, and using this Snowflake service, they can get to know about all these overlappings, that which users are having both the accesses, and even they can get to know about collaborative trends, and they can also know like how many users are premium users on both the platforms. This is how even they are competitors, they will still do a handshake, and they come together in a data clean room, and they do a collaboration to know about the statistics and the trends and also the users overlapping data. Cool. Without even exposing their personal data. Okay. If we go to the definition, so data clean room are configurable isolated Snowflake environments where collaborators can import data, specify what queries can be run against that data, and configure data protection settings such as differential privacy and specifying joinable and projectable columns. Okay, so access to the clean room is by invite only. Very important. The Epic Games can create a clean room, but Xbox can never be able to access the clean room until unless Epic Games invites the Xbox to that clean room. The key concepts involve secure collaboration. Data never leaves the owner's environment. Instead, the analysis is run within a secure, controlled space where only aggregated, privacy enhanced results are returned. Second is consumer and provider roles. A data owner is a provider who sets up the clean room and defines the rule for the data usage. An invited party is a consumer who can run approved analysis on their data. Okay. Third is access control and policies. The provider strictly controls what data is accessible and what type of queries can be run. Okay. Using predefined templates and policies like join policies or column policies or aggregation policies or even differential privacy. Okay. Fourth is no code UI and developer APIs. The coolest part of Snowflake data clean rooms is that the solution supports both non-technical business users via web UI and developers via SQL APIs, and Snowpark for building custom solutions and machine learning models. As we discussed, Snowflake data clean room is a controlled environment where multiple users can analyze combined data sets without exposing their raw data to other competitor. This diagram clearly shows and demonstrates that there is a party A and party B, and they had created a data clean room where they are securely collaborating and getting the insights and getting the overlapping data. The common use cases involve Snowflake data clean rooms are used across various industries, especially for the scenarios requiring sensitive data analysis, like advertising and marketing company, marketing campaign performance, optimizing ad spend, and building look-alike audience without sharing user level data. Second is healthcare. It actually helps them in accelerating drug research by enabling secure data analysis between labs and healthcare facilities. Personally, this I had used previously in my organization. So we had created a data clean room, and there we was collaborating with other companies to get the insights on the drug research and all these injections. And third is financial services. This is improving the fraud detection models and credit scoring while safeguarding the customer data. Cool. Snowflake Marketplace is where you can explore, access, and provide listings to the consumer. You can also use the Snowflake Marketplace to discover and access third-party data and services, as well as market your own data products across the Snowflake Data Cloud. This is pretty much about Snowflake Marketplace. There is nothing much covering to cover here. Next up is data exchange. Data exchange provides a data hub for securely collaborating around data with a selected group of members that you invite. It lets you as a provider publish data which can then be discovered by consumers participating in your exchange. With data exchange, you can easily provide data to a specific group of consistent business partners taking part in the data exchange, such as internal departments in your company or vendors, suppliers, and partners external to your company. If you want to share data with a variety of consumers inside and outside of your organization, you can also use listings offered to specific consumers or publicly on the Snowflake marketplace. So basically, whenever you have to share the data either within the organization, outside of the organization, within the same cloud provider, outside of the cloud provider, there is one option which is valid for every kind of scenario, that is listing. You can create the list and literally you can give them to anywhere. So this is what majorly is data exchange. Snowflake also focuses a lot on data listing in data exchange. Next up is configure shares, account parameters and privileges. In that privilege chain, in order to share an object, the provider role should be account admin, or at least the role should be having the create share privilege. Okay, and once any of this is valid, we just need to grant the usage on database and schema and select on the table or view to the share which we are having. There are critical account parameters. First is data retention time in days, and I guess you already know that what this means, but just to give you gist, if you drop a share table, it disappears from the consumers instantly. Ensure retention is set high enough on the source table to prevent any kind of accidental outages. Second is share restriction. You can restrict which regions or accounts can view your shares. Next is security patterns for data sharing. First pattern is secure views, and this is non-negotiable, guys. Whenever you are sharing the data, you need to ensure that you are only creating secure views. Standard views allow a user to run that DDL function and they can literally know what is happening under the hood. But secure views eliminate this thing and they don't let the consumer to see your DDL, and the consumer can just run the view. They cannot just see the under the hood working scripts and the joins and the tables used and the filters used. Okay, so the pattern is always use create secure view for sharing. It prevents the consumer from seeing the underlying logic and stops the certain query optimization that could leak your data. Second is row level security. This is a massive one. If you have one massive sales table but you want 50 different consumer to see only their respective data, you can use a mapping table and you can again create a view and you can create a mapping table and you can join them based on the roles. In that way, it will ensure that only respective consumer can see the respective data and nothing more or nothing less than that. Next up is outline the purpose, benefits and capabilities of the multiple data sharing models. So I had divided into three things: method, purpose and key capability. The first method is data sharing. It is one-to-one or one-to-many sharing within the same region. Okay, data sharing is only for same region. The key capability here is it provide instant access to the provider's metadata, zero storage cost for the consumers. Next up is data marketplace. It is a publicly listing datasets for many consumers. The key capability is you can monetize this, you can use that for automated discovery, and it is a very simplified way to access the data. Third is private exchange. It is the walled garden for the specific group of partners. The key capability is branding, custom memberships and centralized auditing. And last one is readers account. This is for sharing with the non-Snowflake customers, and provider is responsible for compute and storage, and every billing is tagged to the providers. Last one is cross cloud auto fulfillment. Auto fulfillment is the managed service layer on top of replication. Auto fulfillment automates the global data mesh. When a consumer in the different cloud or region requests data from your listing, Snowflake automatically creates a hidden replication group and it replicates the data to that region, and it keeps the data in sync based on the freshness goal. It is a fully managed service provided by Snowflake. If we talk about checklist for auto fulfillment, the cost factor is a big one here because the providers face because If we talk about the checklist for auto fulfillment and cost factor, the provider pays for data transfer and the storage in the remote region. The minimum addition required here is business critical or higher. This is often required for certain failover or failback replication features, but standard cross cloud sharing is available only via listings. Third is efficiency. It only replicates the data once per region, regardless of how many consumers in that specific region gets the data. This is again a fully managed service, closed cloud auto fulfillment, and it is useful when you have to share the data without worrying about underlying scripts and without you personally taking a lot of overhead. With that said, we had covered lesson 2.2 as well. Thank you so much for watching. See you in the next one. Let's now move on to lesson 2.3, which is create architecture solutions that support development life cycles as well as workloads requirement. Here we will be covering everything on data lake and environment, from storage directory structure, zones, support of DevOps, production, data workloads, warehouse, ETL, lifecycle management that includes migration, CI/CD pipelines, CLI, Git integration, rollback process, and we will also be covering the AI ML pipelines and the applications like Streamlit, Cortex, Snowflake native app framework. Let's start with storage directory structure. In Snowflake, directories are managed in two ways: either physical cloud storage, which is also known as external cloud storage, or Snowflake objects, which is known as internal hierarchy. Let's discuss about external stage structure. Before data even hits a Snowflake table, it's live in a cloud bucket. A clean partitioning strategy is vital for performance. In case of AWS, the recommended pattern is S3, then the path which is relevant to the work which you are doing, then the folder which should be relevant to the structure of the data, and then the actual file. Second one is Snowflake internal hierarchy. Once the data is inside the Snowflake, the structure follows a logical path. These are databases, schemas, tables, and stages. And as you know that database represents the environment, schema represents the domain, stages represent the objects that point to a physical storage location, and tables and views are the final objects for the business consumptions. Now let's discuss about support of DevOps or DataOps principle. There are 5 categories in which I had divided this. First is environment management, second is versional control and continuous integration, third is continuous development and automation, fourth is observability and monitoring, and fifth is security as a code. Let's discuss about environment management, which is also known as zero copy cloning. It is one of the most powerful DevOps feature. In DevOps workflow, you need to isolate the environments. Dev should be having different instance, QA should be having different instance, and UAT should be having different instance. And you can clone a multi-terabyte production database in seconds without duplicating the physical storage or incurring any kind of extra cost. If we talk about impact, developers can test destructive scripts on real production data in sandbox environment without any kind of risk or time waste for data refreshes. Next up is version control and continuous integration. Snowflake supports a declarative approach to infrastructure, allowing you to treat your database objects like application codes. And here comes the database change management. Using tools like schema change or Terraform, you can version control your DDLs. And then we have Git integration. Snowflake support Git integration natively. You can connect Snowflake account directly to GitHub or GitLab repository. This allows Snowflake to see your SQL scripts or Python files directly from your repo. And then we have CI pipelines. When the code is pushed to a branch, a CI tool like GitHub Actions can trigger the Snowflake to create a temporary clone of production and run the new SQL scripts which we just had pushed, and run all the automated tests using dbt if you are working on dbt. Next up is continuous development and automation, where our second point, continuous integration, can trigger Snowflake to create temporary clones. Continuous deployment creates automated self-healing pipelines that move data using your Medallion architecture. Okay, Snowflake provides several built-in objects to automate data part of DataOps. First is task and streams, and as you know, streams track CDC on the table and task execute the SQL code on a schedule or when the stream has data. If we talk about DataOps benefits, this creates automated self-healing pipelines that move data through your Medallion layers from bronze to silver to gold without any kind of manual intervention. And dynamic tables are declarative way to handle data transformation. You specify the end state of the data and Snowflake automatically manages the refreshes and dependencies. Next up is observability and monitoring. This is the core pillar of data ops, where we track if something is breaking in the system or not. Okay, a core pillar of data ops is knowing when something breaks before the business users finds out. We have information schema and account usage inside our Snowflake that provides comprehensive metadata on query performance, credit consumption, data access history, and many more. You can literally explore this. There are a lot of tables and views inside these schemas. Please do explore it. Next is alerts. You can set up Snowflake alerts to trigger notifications or emails if the pipe fails or if the pipe is successful, if the query is running too long, and if there is some business specific requirement or some kind of data quality issues. You can set the alerts inside your Snowflake environment. And the last is quality testing. Integration with tools like DBT test allow you to validate data. Example, checking your unique keys or null values as an integrated part of the deployment pipelines. Last one is security as code. Security is not an afterthought in Snowflake DataOps model. We have RBAC, we have network policies, we have data masking, and all these three things we had already covered in the previous chapters. If you hadn't watched that, please do watch them. That's very important to know the security aspects of Snowflake. And in Advanced Architect, you can expect questions on security in Snowflake. Let's discuss about environments, production, development, and sandbox. This is pretty much understandable, and I believe as you are going with Advanced Architect, you already know what is production environment, what is development environment, and what is sandbox environment. But just to give you a gist, I had created a comparison table dividing into environment, purpose, access level, and data freshness. If we talk about sandbox, sandbox is our high-level experimentation layer where we can play with our tools, either with our codes, and you can check whatever you want to check. And access level is for power users. And if we talk about data freshness, it have a sample data or very static data. Next up is development. It is where you build your new pipelines, you write your SQL Python code, and you perform all kind of unit testings. And access level, it is accessible by developers or data engineers. If we talk about data freshness, it is the recent snapshots from production data. We keep on refreshing the instance based on the requirements. Third is production, and this is the gold layer, and all the power business dashboards and all the end consumers live here. And if we talk about access user, this is a service account, and normally we should not be having access to this one. If we talk about data freshness, here the data is latest data, and it is the real-time latest record present inside the production environment. Let's now discuss about data workloads. Data workloads are specific application processes or capabilities such as data ingestion, transformation, analytics, or machine learning that consume computing resources to extract value from data. These are categorized into OLTP and OLAP for processing large complex data sets. Let's discuss about the differences between OLTP and OLAP systems. The difference between OLAP and OLTP. OLAP stands for online analytical processing and OLTP stands for online transactional processing. These both systems are integral part of data management, but they have very different functionalities. Okay. So if I talk about the differences, I had divided them into categories. So first category, if I talk about the data sources, OLAP is the data source where we have all the historical data from multiple databases. It is a single source of truth for me. All my data from any kind of source will be sitting here, right? And if we talk about OLTP, the data source is my current operational data. So now let's talk about the purpose. We know that purpose of OLAP systems is to use them for analysis and better decision making and creating reports on top of them. Similarly, the purpose of OLTP is to actually serve the people, serve the front end users, serve my operational staff or customers. So it should be used for my day-to-day transactions, right? So what are the methods used? And obviously, OLAP is the method which we use in data warehouse, and OLTP is a standard for DBMS. And if we talk about normalization in OLAP systems, tables are not normalized, but in OLTP systems, tables are normalized up to third normal form. Now, if I talk about the query type, OLAP system is very read heavy. It is able to query complex queries and all those things, but OLTP system is basically used to read and write the queries. That's why OLTP systems are very fast and OLAP systems are slow in nature. If I talk about the data volume, as we know, OLAP system stores all my historical data. So it actually makes sense to say that the data volume will be in terabytes or in petabytes. But OP system is only having my recent data, which is useful for your day-to-day transactions. So the size will be small compared to OLAP systems. If I talk about the update frequency, so we update our OLAP systems periodically by using batch loadings or by even doing OTL processes. And if I talk about OLTP, these systems are updated very frequently by users. This is something which is very user centric. So you can expect even updates every millisecond as well. So there is a possibility that might also be happening. Okay. If I talk about backup and recovery, it is something which we have periodic backup. For that, we have multiple data warehouses like Snowflake, Big Google, BigQuery, Redshift. They do these backups. They have those features. OLTP systems backup, we have to be doing continuous and rigorous backup. And if I talk about users, that thing you already know that OLAP systems will be used by analysts or your managers or your decision makers. And the users for OLTP will be operational staffs and customers and your main application users. If we talk about the focus, the OLAP system is mostly majorly analysis focused. That's why I had written here it is subject oriented. But OLTP system is more focused on operational parts. So that's why it is application oriented focused system. Now I hope that you know clearly what is OLAP and what is OLTP systems. Now I have a question that, okay, we need to ingest our data into data warehouse. I agree with you. But you hadn't told us that how we get data into data warehouse at the first place. What is the process that I am having multiple data sources, okay, and I am having database, how I will do and how I will handle all this data and ingest this data into data warehouse? What is the process? Okay, let's discuss about that as well. Now, as we just was discussing, that on the left side, let's suppose we are having tons of data stored in tons of multiple sources like Amazon S3, SFTP, SQL Server, Salesforce, SharePoint, API, files, SAP, and many more systems. Okay. And on the right side, we have our very own data warehouse. So in order to integrate or process data from multiple sources, storing it in a central repo such as data warehouse, we have a process. Okay, we have a process which is actually known as ETL or ELT. So if I talk about the ETL, so ETL stands for extract, transform, and load. Extraction is nothing, it's just the raw data which is pulled from multiple sources like database or your SaaS applications or APIs or sensor logs or flat files, blah, blah. So all these data we extract. So we call it extract layer. Then we have transform. Transform is where the extracted data is cleaned and reformatted in a temporary staging area. And common task in the transform include data cleansing, data deduplication, even standardization, or sometimes encryption. And third is load. The final clean data is moved into my target destination, such as data warehouse or even data lake, where it can be used for BI purposes. So the whole process is known as ETL Or ELT process is also there, where we first extract, then load the data, and then we, after loading the data into our data warehouse, we transform the data. If I go to the definition, ETL stands for extract, transform, and load. It is a data integration process, okay, used to collect data from multiple sources, clean and organize it, and then store it in your central repo, such as data warehouse, for analysis and reporting purposes. Now we know what is ETL or ELT. I will tell you one more thing, that we usually do ETL in layers. Okay, we don't just do it. We have layers defined to do the ETL process. Let's also touch base on these layers as well. So if I talk about the layers, first is my staging layer, and we can also call it extraction or landing zone. This is the initial or temporary storage area where my raw data is extracted from various sources, like we had just seen, like APIs, database, flat files, S3, SFTPs, right? It acts as a staging table to store the data before even it processes the data, allowing for validation without even affecting your source systems. Okay, so once we are good with our staging layer and we had extracted and landed the data in our staging layer, the second layer is known as data integration or transformation layer. This is majorly known as a processing layer, okay, and cleaning layer. And here the raw data is cleaned, filtered, or transformed into consistent format, and it applies all the business rules. Even we remove duplicates here, and even missing values also we handle here, and sometimes we even aggregate data. Every kind of transformation we do in this layer, even joinings and missing data filtering. This is a transform logic that prepares the data for the data warehouse. Okay, this is the place where we do all your logic stuff. Okay, once this is also done, the final layer is known as access layer or core layer, and this is our loading zone or created data zone, and this is where we also create our data marts. Okay, and the final layer, the created data, all the created data is loaded into your target data warehouse like data marts for consumptions. So it organizes data into dimensional models. This is all about ETL layers. There is another variation of these three layers as well, okay, in which we call the staging layer as bronze layer, data integration layer as silver layer, and access layer as gold layer. And this architecture is also known as Mendelian architecture. Next up is migration. Migration in Snowflake typically refers to two scenarios, either moving from a legacy system to Snowflake or moving objects between the Snowflake accounts. I had divided migration into two phases. First is initial migration and second is cross-region cloud migration. Initial migration is like migrating from your legacy systems to Snowflake, and Snowflake supports schema conversion here, bulk data loading here, metadata migration as well. For schema conversion, you can use tools like Snowflake scripting or third-party converters to translate legacy DDLs to your Snowflake compliant SQL DDL. Bulk loading is something where you use copy into command or Snowpipe to ingest all the historical data from any kind of cloud provider to your Snowflake instance. And metadata migration ensures that RBAC structure are recreated to maintain the security aspects of the Snowflake. Next up is cross-region and cross-cloud migration. If you need to move a development lifecycle to a different region or cloud provider, Snowflake uses data replication, and this is also we had covered recently. Please go watch the video where we had discussed that how we share data across the accounts, how we share data between the Snowflake, how we share data between a non-Snowflake user. We had covered all the parts. Please do watch that. Coming back to here, we have failover and failback. You can replicate an entire database to another region. This is often used for disaster recovery, but also works for migrating production workloads with near zero downtime. Let's now discuss about deployment in Snowflake. Deployment is the process of promoting code and schema changes through your environments. So I had divided the deployment into two processes. First is imperative versus declarative deployment, and second is blue-green deployment. We can do imperative deployment using tools like schema change, or you create a sequential script that is executed in the order. And in declarative, you can use tools like Pulumi or Terraform. You can define what the final database should look like, and the tools will calculate the difference and apply all the changes. And next is blue-green deployment, which is also known as CI/CD. Snowflake architecture is perfect for blue-green deployments. You can deploy the new version of your pipelines to the new schema or the databases, and then you can test by running the validation queries, and then you can obviously cut over if that's required. And the benefits include, if the newer version fails, you can swap back to the old version instantly. There are deployment best practices recommended by Snowflake. First is to use create or alter. For certain objects, Snowflake supports create or alter syntax, which specifies the deployment by automatically detecting if a table needs a new column or not. Second is small and infrequent releases. Always avoid migrating everything at once. Deployment should be incremental, and we should be deploying in a small release to reduce the blast radius of errors all at once. Third is idempotency. This ensures that your deployment scripts can run multiple times without even causing any kind of error, like using the create if not exist. For example, if you are creating a table, instead of saying create or replace table, you can say create table if not exist. Similarly, you can delete the anything specific delete if not exist from the table, so that it follows the principle of idempotency. Let's discuss about Snowflake CLI. Snowflake CLI, often referred to as Snow, is a next generation command line interface designed specifically for developers. Unlike the older SnowSQL, which is primarily a query tool, the modern Snowflake CLI is built to support DataOps and DevOps workflows, which we have just discussed, focusing on automation, app development, and infrastructure management. Let's see Snowflake CLI in action. So now let's install and configure Snowflake CLI. Let's begin by downloading binary installers from Snowflake official documentation. On your browser, search install Snowflake CLI. Okay, and go to that URL, and here I will go to CLI repo, and my system is Windows system, so I will click on Windows and I will install anyone. Uh, yeah, this one I will install it. I will open that, click on next, install. Yo. So installation is finished. I will click on the finish button, and I will go to my command prompt. And here, as I had installed it into my other folder, so I will go to that folder, uh, and I will go one more step, cd program. Okay, so now I will do cd snowflake CLI, and I am into the folder now. So now I am going to type snow connection list. Let's see. It's unpacking the distribution. As you can see, there is no data it's showing. Basically, it means that there is no connection list. So now I'm going to create a snowflake connection, okay, by using snowflake connection, snowflake connection add. Is it a snow connection add? Yeah. So it's asking for the connection name. connection name is my username. In my case, it's my name. Account, enter account. So what is account? So account is nothing. It's just the concatenation of your locator number plus your account ID. So this is your account ID. In my case, it's this one V511 whatever. So I'm pasting it with the concatenation. In concatenation here is hyphen. So I had entered my account. I will click OK. So now it's saying what is the user. User is same as my connection. Okay. So now it might be asking for password. So I will be entering my password here. Yes. So it's asking for which role you want to create. So I am okay as of now with account admin. I don't have any other role. It's new account I just created. So I will just hit enter. So with warehouse, if you remember, as of now, I am only having very few, I guess, two warehouses. Let's see that. Two or three. Yeah, two warehouses I am having. One is Snowflake Learning and second is Compute Warehouse. I am going to use Compute Warehouse. Okay. And I'm going to click on enter. It's asking for database. I don't feel I need anything, so I'm just clicking enter. So you can also skip some of the options. Like if you see these options, you can obviously, if you have information, you can, but if you don't, you can obviously skip them. So once everything is done, it will create a file, which is a toml file in which it is having all the configuration, all the passwords. You can see your toml file. I can't show you my toml file because I have my passwords there and it is visible from there. So you can obviously go to the directory which is showing in your system. Like in my case, it is showing this system, and you can open the toml file and see all the configurations which you had just done, and it successfully created a new connection for me. So now I'm going to test the connection. Okay. So now in order to test the connection, I guess it should be snow connection test minus connection name testing. Let's see. Perfect, perfect. So as you can see, the status is okay. Okay, this means the connection is successful, and you can see all the details like my connection name, my host name, my account name, my username, role, database, compute. You can see all the details here. So this is how you can connect with your Snowflake CLI. So now you also should connect with and try that. So now let's discuss about IDE integration with Snowflake. For IDE integration, let's download VS Code first. So I will go and download the VS Visual Studio Code and open that. I agree. Next install. Done. So now let's launch the VS Code. So I had launched my VS Code. So now I will go to the extensions. It is a very quick one. So I will go to the extension and I will type Snowflake. Okay. So then I will click on the official Snowflake one, which is ticked as a blue. I will click on install and it's installing. So let's wait. Okay, so it's already installed. So once it is installed, you can see that there is a Snowflake icon displayed here. So now I will do is, I will log in. So in order to log in, I first need the account identifier. So what's the account identifier is? You need to go to here. Need to go to your account details, and here you can see account identifier. Just copy paste this and click on enter. So now it will ask you for the username, password, and any kind of multi-factor authentication if you have. As of now, as you know, we just created the account today only. So I don't had any MFA setup. So I will just pass on my username and passwords. Okay. So let's wait for a one like minute. Yeah. Okay. Perfect. So it's connected. So as you can see, I am having all my databases, all the three databases, like even mine one is displaying. So you can see all one. So let's, try to see one sample data table. Let's see this table. In this schema, whatever table it is there, we'll see that. Okay, let's click on that. And so this is the table in the Snowflake. So this is how you can connect with the external IDEs. Now let's talk about API integration. API integration in Snowflake works in two directions. First is inbound and second is outbound. So inbound, we can use Snowflake SQL API, and SQL API is a RESTful interface that allows custom applications to interact with Snowflake without using any traditional drivers like JDBC, ODBC or Python drivers. And second is outbound. This is Snowflake external access. This is the modern way to make Snowflake talk to outside world. It allows you to call any external APIs directly from within UDFs or store procedure. This is the syntax for creating API integration. We will see that in action as well in a few minutes. Let's talk about Git integration. Snowflake Git integration allows you to connect a Snowflake account directly to a Git repository like GitHub, GitLab, Bitbucket, or Azure DevOps. This turns a Git repo into a first-class stage inside Snowflake, enabling modern data operations and CI/CD workflows. Okay, I don't have much theory here to talk. Let me quickly take you to Snow site and we'll implement that right away. I'm back into my Snow site. This time I am going to create the API integration and I am going to fetch all the data which I am having inside my Git repository. If I go to my Git app repository, I had uploaded 4 files here. And you can see I had uploaded Hello World, Taxis, Titanic and Health exp file inside my Git repo, which name is Snowflake demo. So I'm going to fetch all these files inside my Snowflake environment. For that, first I need to create a secret. Okay, I will create a secret. In order to create a secret, I need to write a script create or replace secret. And then the secret name, let's say my GitHub secret. And then I need to mention my password and username. And I will say type is password and username is my username. Then I need to mention my password. Cool, I had mentioned my password. Now I will just hit run and I had created my secret. Now I am going to create the API integration. Create or replace API integration. And let's say Git API integration. And then I need to mention few options like API provider. And in this API provider is Git HTTPS APIs. And my API allowed is only Git API allowed prefix is my Git account. I will mention my Git account here. Then I need to mention allowed authentication secrets, and it's my GitHub secrets. So my GitHub secrets, and last is enabled is equal to true. Now I will just hit and run this. Perfect. I had created the API integration as well. Now it's time to create the Git repository. In order to create, it's the same, create or replace Git repository. And then my repository name, let's say my code repo. And now I will mention my API integration, which is this one. I just copy paste. And then I need to mention my Git credentials, which I had created above. I will just copy paste those as well, my Git secret. And I want to mention my origin. This is the place from where it needs to pick all the files. Perfect. Now I will hit run. It's running. Perfect. I had created my Git repo as well. Now I will just do the last step, that I will fetch all the files from my Git repo into my Snowflake. Okay. I will write Git repository and my Git repo name, my code repo, and let me write fetch. It will fetch all the files which I have present in my GitHub to this Snowflake. See, it had fetched the my branch and the main branch. Let me see it. Let me see it. I will just type list at the rate my code repo. Then branches. Inside branches, I will go main and I will just hit run. See guys, now all the files which I had in my GitHub, all the files now in my Snowflake, and it is showing 5 columns: my file name, my file size, MD5, SHA for the file name, and the last modified date. Okay, let me show you one more cool stuff. I have one hello world SQL file. In that I had written one select query. Let me try to run that from here itself. I will show you. For that, I will just write execute immediate from execute immediate from this repo. I will copy paste, Control C, main, and then hello. Let's figure this. So it will open the file and copy the query inside that file, and then it will run the query using my Snowflake warehouse and will show the result. See guys, it has shown the result. So this is very cool thing. Let's now discuss about rollback processes. So there are 5 kind of rollback processes which Snowflake offers. First is time travel, second is the undrop command, third is the table swapping, fourth is the fail safe, and fifth is the transaction rollback. If we talk about time travel, Snowflake automatically keeps the version of data as it changed. If you accidentally delete a table or run an incorrect update statement, you can query the data as it is existed at the specific point in time, and the retention period of time travel is 0 to 90 days in case of enterprise edition or above, and for standard edition it's just 1 day. If we talk about undrop command, if a database schema or table is accidentally dropped by you, Snowflake does not physically delete the data immediately. It moves to a dropped state for a duration of the time travel retention period. You can quickly undrop the table by saying undrop table name, and it will immediately retrieve your data back. Third is table swapping. For the production deployments, the safest rollback strategy is using the swap with command. This is often used during a deployment lifecycle to switch between a new version and an older version. You can deploy changes to any other database or schema using the swap with. You can just say alter table, the previous table name, then you can say swap with the new table name. And if a user reports any kind of bugs, you can simply run the swap command again. The old table, which is now the new table, immediately will become the active table again. So this is the beauty of table swapping. It is very flexible. Fourth is fail safe, and you already know what is fail safe. This is the last resort. Once the time travel period expires, data moves into Snowflake, and you cannot just extract the fail-safe data. You need to contact with the Snowflake to retrieve the fail-safe data, and that is also up to 7 days. Last is transactional rollbacks. Snowflake supports standard ACID compliant transaction rollbacks for multi-statement operations within a session. And if a session crashes or the warehouse is suspended the mid-transaction, Snowflake automatically rolls back the uncommitted changes. Let's now discuss about Snowpark Container Services. Snowpark Container Services is a fully managed container offering from Snowflake that allows users to deploy, manage, and scale containerized application directly within the Snowflake ecosystem. It enables the developer to run any code regardless of the programming language or library on secure Snowflake managed infrastructure without the need to move data out of the platform. If we talk about key capabilities, it is language agnostic. It supports virtually any programming language and framework by packaging them into OCI compliant images like Docker images. It provides specialized hardware that provides access to various hardware configurations including GPUs and high memory instances for compute intensive tasks like ML trainings and LLM hosting. It have native data access. Containers have secure low latency access to Snowflake data, stages and tables using local credentials provided at the runtime. And then it also supports strong security and governance, which operates entirely within the Snowflake security parameter, benefiting from Snowflake RBAC and governance features. There are three pillars of Snowpark container services. First is image repository. It is the storage locker in the Snowflake where you push your Docker images from your EC2 instance or from your local using Snowflake CLI put commands. Second is compute pool. This is the actual hardware that Snowflake spins up to run your containers. In order to create the control pool, you need to first create the image, which is the first pillar. You will say create image repository, the image name, and then you will create the engine, which is the compute pool, and you will mention minimum nodes, maximum nodes, and the instance family. And once you had created the image and created the compute pool, you will create the service that is nothing just a configuration that tells Snowflake how to run your image and which port to open and which hardware to use. In order to create the service, we will say create service in the compute pool for the specification, and inside the specification you will mention all the specification details in YAML format. Once you create these things, you had successfully implemented Snowflake container services. Next up is Snowflake ML functions. Snowflake ML functions are a suite of SQL-based tools that allow users to perform advanced predictive analytics such as forecasting and anomaly detection directly within Snowflake without even needing deep machine learning expertise or external infrastructure. The core ML functions are forecasting, which predicts the future metric value based on the historic time series data. It automatically handles seasonality, holiday effects, and missing values. Next up is anomaly detection. It identifies the outliers in the time series data that deviate from the normal historical patterns. This is commonly used for fraud detection or monitoring cloud spend. Third is classification. It sorts the data into predefined classes. Common use case include customer churn prediction or lead scoring. And fourth one is top insights. It identifies the primary drivers of changes in a specific metric over time or across different categories. It is very beneficial in root cause analysis. Let's see this in action. I will go to my Snowflake instance. Here I had written all the scripts for forecast, anomaly detection, classification, and top sites. Let's go one by one. For forecast, first thing, I had created a view on top of my existing table, which is sales data. And then I had created a forecast model inside snowflake.ml.forecast, and the model name is model 1. And then I had passed my input data as the view which I had created. And inside the view, I am having two columns. First is date and sales. And those columns I had passed. Please ensure that whenever you are doing forecast, you should be having at least one timestamp column. Without that, forecast is useless. Once you create the model, we will call the model, and the command for that is call model exclamation and then forecast keyword, and then we will mention forecast period, that how in depth you want your forecast to happen. Once you do that, we will hit all these. So I will select them and I will say control enter. It will take a little bit time because it is creating a model for me. So that's the reason it is taking a lot time than usual. And I am running this on extra small. That's the another reason. Hey guys, this is how forecast function works. So as I had mentioned forecast period as 3, it had given me the forecast for my lower bound and upper bound and the current forecast. This is very handy when you want to work on predictability and analysis purposes without being a background of data scientist. Second function is anomaly detection. For that, I had created a view and then I had created second view on top of which I will test the anomaly detection, because anomaly detection demands two objects, and that's the only reason I need to have at least two objects to go and check the anomaly detection. Okay, and then I need to create a model of anomaly detection, and this model will also go inside snowflake.ml, and inside that I will mention anomaly detection and my model name. And once this is done, I need to call my model with the same way as we had called forecast, saying model name, exclamation, then anomaly. So this is what I had done here. I had said model name, explanation, and detect anomalies. And inside that, we need to mention input data and timestamp and target column. And once I trigger all of this, I should be able to identify the anomalies between these two objects. Let it run. And see, guys, it had created the forecast, it had created the lower bound, upper bound, anomaly, and percentile, and the distance. This is the generic example, but the process will remain the same. You need to create the anomaly using the same function, and I will provide you these scripts in the description as well as in my Git account. You can play with these things. Next up is classification. For classification also we need two tables. For that I had created a training purchase data table and second is prediction purchase data table. Once you had created the table, I had created a view. Again, I need to mention the same thing, snowflake.ml.classification, my model name. And once I had defined the model name, I can just do select on the model name using the function predict. Then I should mention the input data from my respective table. And in this way, you can see the functionality of classification. Let's run them as well. I will just select them all and let's see if this even working or not. Perfect. I can able to see the predictions based on the tables which I had created. And the last one is top insights. Similarly, for top insights, I had created a table and I had inserted some data inside the table. And then I had created a view on top of the table. And then again, I need to say snowflake.ml.top insights and my model name. And once I create my model name, I need to call my model name, and the function to call this is get drivers. Okay. And once I mention all the parameters, I just need to trigger run and I should be able to see the insights based on this ML function. These are very handy when you are not from a data scientist background, but to still want to do kind of analysis and sentimental analysis and all these predictions. These parameters then become very, very helpful. See guys, it had shown me the results of top insights as well. That's pretty much about Snowflake ML functions. Next up is Cortex LLM functions. Snowflake Cortex LLM functions are set of fully managed SQL and Python functions that provide direct access to industry-leading LLMs like LLAMA, Mistral, and Snowflake Arctic natively within the Snowflake Data Cloud. These functions allow you to perform advanced text analysis, generation, processing tasks without needing to move data out of your secure Snowflake environments. If we talk about core generative AI functions, first is AI Complete. This is the primary generative function used to produce a text completion for a given prompt. It supports multi-turn conversations and is updated version of the complete function. Next is AI extract. It automatically pulls specific entries or information from the unstructured data like text, images, or files. Third is AI embed. It generates vector embeddings for text or images, which are essential for similarity searches, clustering, and building RAG pipelines. Next are task-specific functions. The first function is AI summarize. It generates a concise summary of a given text, ideal for condensing long document or customer feedback into a summarized format. Next is AI sentiment. It returns a sentiment score between -1 to +1 to help you gauge the mood of the text data. Third is translate. It translates the text between the supported language, either English to French or any other language, directly within a query. And fourth is AI classify. It categorized text or images into a user-defined labels, useful for automated tagging and data organization. And last is AI redact. It automatically identifies and masks the PI data like names, emails, phone numbers from your unstructured text. Last category is analytics and helper functions. First is AI aggregator. It aggregates the insight across multiple rows of text based on a user-defined prompt, bypassing standard context window limits. Next is AI filter. It returns a Boolean value based on the semantic check of that input, allowing you to filter results using natural language in where clauses. And next is sound tokens. It is a helper function that returns the number of tokens in the string according to a specific model's tokenizer, useful for managing cost. Last one is AI similarity. It calculates the semantic similarity between the two input values. Let's now discuss about Streamlit in Snowflake. Streamlit allows developers to build, deploy, and share interactive Python-based web applications directly within the Snowflake Data Cloud. By running natively in Snowflake, these apps benefit from built-in governance, security, and immediate access to your data without moving it to the external systems. If we talk about core features and benefits, first is native integration. Apps are treated as first-class Snowflake objects governed by RBAC and existing security policies. Next is no front-end experience required. Developers can write pure Python code using Streamlit open source library to create widgets like filters, sliders, and charts. Third is Snowpark support. It seamlessly uses Snowpark for Python to query and process data at any scale. And fourth one is unified governance, because data and application code are sitting inside the Snowflake parameter that ensures the compliance and security of the data. Let's talk about the native apps. Snowflake Native App Framework enables the developer to build, distribute, and monetize data applications that run entirely within the consumer's Snowflake account. Okay. This approach brings the application logic to where the data already resides, eliminating the need for data movement and enhancing security and governance. If we talk about key features and concept, the biggest key feature is in-account execution. Native apps are installed and run within the Snowflake account, so all the sensitive data never leaves the environment. Okay. Second is monetization and distribution. Providers can list their application on Snowflake marketplace using various licensing and pricing models. Third is development tools. Applications can be built using familiar languages and tools within the Snowflake ecosystem, including SQL, Python, or Snowpark, and user interface via Streamlit in the Snowflake. Okay. Third is development tools. You can build applications in the Snowflake environment, and you can even use interface like Streamlits. Fourth is intellectual property protection. This framework is designed to protect the provider's underlying code and business logic, even while it executes within the consumer's account. Fifth is Snowpark container services. These are just the native containerized workloads, which actually allows you to integrate to the external softwares and sophisticated AI/ML models and even third-party services. This is the Snowflake native workflow. It includes 4 parts. First is develop, second is publish, third is install, and fourth is used. Develop and publish comes under the provider, and install and use comes under the consume service. Okay. So if we talk about develop, so a provider builds the application logic, right? And an application package also sometimes, which is a container that holds all your necessary code, right? Even metadata and even your setup scripts it can hold, and sometimes even data content it holds. So everything it comes within the develop. Okay. Second is publish. Once the application is developed, obviously the provider publish the application package through a specific public listing on the Snowflake market, or even if he wants, he can list to the private listing to for the specific consumers. Okay. Third is install. And this is where the consumer discovers the app. Okay, it accepts the terms and conditions for the app and it installs it into their own Snowflake account, where a new application object is created and configured by a setup script. For this use, the consumer runs the app against their own data, leverage the provider logic without moving data out of their secure environment. So this is the Snowflake native workflow. And if I talk about the use cases, it is used for AI ML solutions, okay, where companies can distribute the proprietary AI ML model as native apps, and it allows the customer to run their predictions against their private data very securely. Second is it can use for data analytics purpose, where providers offer ready to use analytics tools that can integrate seamlessly with the existing consumer data, and it offers immediate insights without requiring a separate data warehouse build. Third is data connectors. So data developers can build native that data ingestion connectors for various platforms like GitHub or Kafka that run inside the Snowflake to streamline their data pipelines. Let's now start with lesson 2.4, where we will be covering everything about virtual warehouses, object hierarchy. Inside that, we will be covering about databases, schemas, tables, views, and stages. Then we will be discussing about functions, store procedure, task, and file formats. Let's start with virtual warehouses. Virtual warehouses are nothing just a compute engine. Virtual warehouse, often referred to as a warehouse, is a cluster of compute resources. So virtual warehouses are available in two types: standard and Snowpark optimized. Standard one is the normal regular virtual warehouse, and Snowpark optimized are the latest new addition. Snowflake recommends to use Snowpark optimized one for workloads that have large memory requirements, such as ML training use cases. Snowpark optimized warehouses let you configure the available resources and CPU architecture on a single node instance for your workloads. The default configuration for Snowpark optimized provides 16x memory per node. Okay, this is very important to remember that Snowpark optimized by default provides 16 times more memory per node compared to the standard warehouse. So you can obviously optionally increase or add additional nodes and CPU as well using the create warehouse or alter warehouse property. And the following options are available in the Snowpark optimized one. If we talk about memory, so default one is 16x, which is 256 GB. If we talk about memory of up to 16 GB, the resource constraint value which we need to pass is memory 1x or either memory 1x x86. So this is the minimum warehouse support in the Snowpark optimized, and it is extra small. Same way we have medium and large. Aligning with the same, we have the resource constraints. This is a default one, and obviously you can increase or decrease, you can add additional ones as well. If we talk about the standard warehouses comes with two options, okay, Gen 1 and Gen 2. Gen 1 is Snowflake Originals one, and it is industry standard for using the virtual warehouses. Gen 2 is the next generation warehouse. So in Gen 1 warehouse, the ratio of CPU to memory is fixed because it is designed for general SQL tasks. In Gen 2, Snowflake swaps out the virtual machines, okay, for instances that have more memory and faster SSDs. Okay, so this is the difference. Okay, so Gen 1, it's a general memory to compute ratio, but if we talk about Gen 2, it is having a significant more memory and faster SSDs in order to process your queries. Snowflake universe, Gen 1 and Gen 2 generally refers to the evolution of virtual warehouse hardware and performance architecture, while Snowflake manages all the underlying infrastructure for you. Understanding these shifts are very, very important. Okay. So if we talk more about that, so you can alter a standard warehouse and specify a different generation clause or resource constraint based on your requirement. You can change it from Gen 1 to Gen 2 or Gen 2 to Gen 1, and you can change this whether the warehouse is running or whether the warehouse is suspended. So this is the general NVMe SSD Gen 2 uses to provide you more significant and faster query performances. In order to create a warehouse, that's the typical script we need, that create or replace warehouse with the warehouse name. And in the resource constraint, you can mention which kind of warehouse you want to create, either Gen 1, either Gen 2, or either you can also mention the resource constraint for Snowpark optimized one as well. Okay. And obviously, the warehouse size is required when you are talking about Gen 1 and Gen 2 specifically. So you should mention the warehouse size as well. So this is a typical thing between Gen 1 and Gen 2 and what is Snowpark optimized compute. So Snowpark workloads, can be run on both standard and the Snowpark optimized warehouses. Okay. But Snowpark optimized warehouses are recommended for workloads that have large memory requirements. Difference between Gen 1 and Gen 2 workloads. So these are optimized for row and columnar SQL, and these are optimized for memory heavy object. In Gen 1, we have high risk of remote spilling, okay, because of large kind of workloads. But in Gen 2, it is designed, actually to eliminate this remote disk spilling because of its significantly large RAM and faster SSDs, where it is highly unlikely that it gets remote spilling. So if I talk about concurrency, it is great for smaller queries and it is great for fewer massive and complex tasks. So obviously, when it comes to cost, so it will be less costlier than this one, because it is obviously using higher compute and higher SSDs on the cloud. So it is almost charged double credits. So this is the pretty much about Gen 1, Gen 2 and Snowpark optimized warehouses. We will be mastering Snowflake object hierarchy and types. If you see this image at the very top, we have organization. Think of this as the CEO of your Snowflake footprint. It's a global entity that allows you to manage multiple accounts across different clouds like AWS and Azure all in one. Under this umbrella, you have organization objects like account, replication, and network policy. So we have three objects under this account. Account, which you can create on the fly, and replication is for syncing data across the globe, and network policies, is to set security guardrails for your entire company. Please take notes, guys. This is very, very important. All right. Next up is the account. Okay, this is where the actual work happens. Some users think that this is the top level, but it's actually a child of the organization. At account level, we manage the big three, that is virtual warehouse, users and roles, and third one is integrations. All right. So we manage these three big threes here. Virtual warehouse are the compute engines, users and roles is your security layer, and the integration is the security and resource integrations where you can connect Snowflake to the outside world. Now we are moving into the data storage side. An account hold databases, and inside these databases we have schemas, and inside schema we have all these table views, materialized views, UDF, store procedures, etc., etc. Okay, if I have to recap this in very easy words, I will say organization handles the billing and accounts. Account handles the security and compute power. Databases and schema handles the organization, and schema objects handle the actual data. All right. So now if I go to organization definition, okay, so it states that an organization is a first class Snowflake object that links the accounts owned by your business entity. All right. So this is the main most upper level of object. Okay, organization simplifies account management and billing, application failover and failback, Snowflake secure data sharing, and other account administration tasks here. Okay, so this is a upper level of Snowflake objects. Usually we don't have access to that level. This feature allows organization administrator to view, create, and manage all your accounts across different regions and cloud platforms. Think of it like a apartment building. The organization is the building, The account is a specific apartment, and the database warehouses are the furniture inside. Now, as you understood the organization, so you know that it's a first class Snowflake object, and it plays where it simplifies all these billings and replications and everything out. Let's more dive deep into Snowflake accounts, which consist of many features like account scalability. Anyone can have any number of accounts and unique access. Each account have its unique URL as obvious. Infrastructure, each account is deployed on a single CSP, either any of their cloud it is used. And geography, each account exists in only single geographic region. There is no way that a single account can be present in a multiple geographic region. This is a very important to note. Addition, either accounts exist in one edition at a time. If the account is a standard, it will be standard. It cannot be existing in others. Same way, if the account is existing in other, it will not be existing in the standard or any other. Similar way, account uses tracking. Okay, each account comes with a built-in read-only database called Snowflake. It contains account usage schema. This is where you find views to track how many credits you have spent, who logged in, and which tables are taking up the most storage. Right? So basically, account is, place where you will be having access and you will be using your account to query and, to load data and to do all the tasks in Snowflake. Now, let me take you to the Snowflake and show you accounts as well as the account usage schema, which contains multiple views. Now I am in my Snowflake account. I will quickly run the command show accounts. This will show me all the accounts, basically one account which I have. So it's showing the organization name, account name, region of the account, edition, it is enterprise edition, the date for signing up the account and other stuff like its organization account or not and all those things. So now let's understand the account uses. So in this Snowflake database, you will be having a schema called account usage, and inside that account usage, you have a lot of views, which is very helpful. Let me show you that. If I go to account usage, you will see views. There are multiple views, which is basically metadata or other information required. So I will show you one view which is widely used, that is known as access history, right? So this is, a view which is used to see who accessed the account and at what time and what is the query ID and who is the user who did try to access and what is the object access and all these details here. So there are multiple other tables like backups and Cortex and columns. You can explore them and it is a really very helpful, when it comes to seeing the overall picture of your account. Now let's discuss about the database object. There are many database objects like stages, schemas, tables, views, UDF, and so on. As you can see on your screen, we'll basically go one by one to each object. And let's start first with stages in Snowflake. So Snowflake Stages is the platform which helps loading and unloading data into tables. Basically, in very easy words, it's essentially a landing zone or a waiting room for your data files. So if I go to the Snowflake stage definition, it's saying Snowflake stages are locations where data files are stored, which helps in loading data into and unloading data out of the database tables. Okay, as I just told you, the stage locations could be internal or external to Snowflake environment. There are two types of stages. One is internal stage and second is external stage. And internal stage is internally within the Snowflake. External stage is outside of the Snowflake in other cloud vendors. So we can also access that and we can reference the stage in the tables. Now let's discuss more in depth about what are internal stages. So there are three types of internal stages. First is user stage, second is table stage, and third is named internal stage. If I talk about user stage, a user's stage is allocated to each user for storing files. To store files that are staged and managed by a single user but can be loaded into multiple tables. And user stages cannot be altered or dropped. This is very important. And this option is not appropriate if multiple users require access to the files. A single user can stage and manage the files, but multiple users cannot manage the same file which is staged by some other user. It can be used to load multiple tables. Let's try creating it an internal stages, starting obviously with the first type, that is user stage. In order to work with the internal stages, we will use SnowSQL, and for that we will go to Chrome and type SnowSQL download. Here you can see there is an option to download the latest version, either for Linux or Mac OS or Windows. My system is Windows, so I'm going to just hit on this button and it will start the downloading. So it's downloaded. I will go to the location and install it. Okay, my installation is finished. Now I will click to finish and I will quickly move to command prompt. And here I will first create the connection between the SnowSQL and my Snowflake account. So for that I will say SnowSQL and my account identifier. I will go to my Snowflake and get the account identifier. In account details, I can see my account identifier. I will copy paste. And then I will also paste my username. Okay, and I will hit run. Time to mention my password. Cool. As I had mentioned my password, I am able to log in into my Snowflake. Let's just try to run one script, show databases, to see if the connection is successfully established or not. See guys, so the connection is successfully established. I'm able to see my all the databases and all the information. Okay, and now I will configure some properties, like I will mention to use database, let's say company, and then use schema public. Perfect. Earlier it was showing my name with the warehouse and no database, no schema. With the use database and use schema, I am able to see my compute database and schema. Cool. Let me try to run a select query as well. Company dot public dot employees. Cool. See here guys, I am able to see the data. I am able to access all the databases and all the schemas in my Snowflake. A proper connection between SnowSQL and Snowflake is established. Cool. Now it's time to understand the user stage. For that, I first need few dummy files, dummy CSV files download, and I will go here and I will download some random files. This one, this one, this one. Once I have the files, now I need to place the files. For that, I will use the command put file the. This is the location where I am having all my files which I just downloaded. And this is my symbol for user stage. Always remember that whenever there is a user stage, you need to mention @ following with this Asian symbol, and then you need to mention the stage name. I had written the script. Now I will just hit run. Cool. So it had read the data from my local disk, and it is showing couple of information, like the source file name was titanic.csv. The target in Snowflake, it's stored as a Titanic CSV is gzip. So it had done the compression. The source size is 60,302 and the target size is 21,000 something. So it had compressed my data while loading into Snowflake, right? So the compression technique it followed is gzip. This is very, very cool feature. It automatically compressed the data and the status is uploaded. Now I had staged the data in the Snowflake. Now let me try to list it. See, my file is now staged. Let's load this file. I'm going to create the table inside the Snowflake where I will be loading this file. For that, I will write a DDL. Here is the DDL script I had written, and I will just hit enter. Cool. It had created the Titanic table inside my Snowflake. Now I will write the copy into command to load data from my user stage into Snowflake. For that, I will say copy into company dot public dot table name is Titanic from the user stage with the file format type CSV. Field delimiter is comma. Skip header 1. Field optionally enclosed. This is the copy into command which I had written to populate to load data into company public Titanic table. And here the type of the file is CSV, the field delimiter is comma, and so I had mentioned comma. Skip header because the first column is the columns which I had already defined in DDL, so I don't need that. The field optionally enclosed by I had used because if you see this file in my notepad, you see that there are double quotes in this column, right? So this is the reason why I am using the field optionally enclosed. It ensures that all the double quotes also get removed and all the data don't get spill over to another column. Cool. I will hit the run button. As I had hit the run button, there was a typo error. So I fixed that. That's why you are seeing some failures. So I had hit the run button and I am able to see the data is loaded inside my table and the rows total parts are 891 and total rows are loaded are also 891. So let's now query the table and see whether the data is really loaded or not. See guys, so all the data is loaded into my Snowflake table. Let's one time also validate this from Snowflake. I will just run the select query in my Snowflake as well. I'm just going to copy paste the query and I'm just going to hit the run button. See guys, see, this is the magic. This is how you can load the user stage into Snowflake. Now let's move to the table stage. The symbol for table stage is @%. The table stage is available for each table created in Snowflake. Table stage have same name as the table. This is very important to note. For example, if the table name is my table, the stage referenced by that table should also be @ my table. Table stage are also used to store files that are managed and staged by one or more users but only loaded into a single table. In the users, a single user can load the same file into multiple tables, but in stage, one or more users can load the file into a single table. Tables also are like user stage which cannot be altered or dropped. And note that table stage is not a separate database object. Rather than it is an explicit stage tied to the table itself. Let's see that as well in action. I have a taxi.csv file which I am going to load into that table. So for that, I first need to create the DDL. Perfect. My table is created. Now I need to stage the file which I am having in my local storage so that I can copy the file data into my taxis table. For that, you already know that we need to use the put command. So I will write the same command here, taxis.csv. This time I am going to create the table stage. So I need to mention modulus. The table stage name should be same as my table name. So I will mention here as taxis. I will just hit run. Perfect. So I had staged the local file now. It again compressed the file. This is something which I really love about Snowflake. Whenever it is going to stage the file, it compressed the file and it stores a lot of my space. I had created the table. I had ran my script. My files are staged now. Let me have a quick view as well. List@taxis. I'm having the file here, my file date, everything. Now I am going to use copy into command to load the data into my table. Perfect. I had loaded that file as well. This is how table stage works. In table stage, the differentiating is the symbol @ and modulus. In user stage, we need to use @ with the Asian sign. Now we had loaded the table. Now, as usual, we will also see this table as well. Let's start from taxis. And we are able to see the data. Now let's again see this in Snowflake as well. Here I will just say taxis and hit the run button. See, I'm able to see all the data which I was having in my local. This is pretty much about table stage. Third one is named internal stage. Name internal stage is a database object created in the Snowflake to store files that are staged or managed by one or more users and loaded into one or more table. And create stage using create stage command. Let's create that as well. I am going to create a stage name health exp. I will hit the run. Stage is created. Now I will create the table. Cool. I had written the DDL for table creation. Now I will click enter. and table is also created. Again, like same way, we need to stage it, and we need to use the put command so that my local files get into my Snowflake. I will use put file and my again the same location dot CSV. I had created a put script. Now I will hit run. Cool. This is also staged and data is now in my Snowflake. Now I am going to list it followed by copy into, and I am able to see my data. And now let's write copy into for that as well. I had written my copy into script. I will just hit enter and it will load the data into my Snowflake table. Cool. Everything is done and dusted. We had created the user stage, we had created the table stage, and we had also created the named stage. And you know the difference between user stage, table stage, and named stage. Now let's, as usual, we will also see the life expectancy table quickly. And cool, I'm able to see my data. Let's now move to external stage. External stage is an external cloud provider location where data files are stored, and loading data from any of the cloud provider is supported regardless of the platform that hosts your Snowflake account. External stage is a database object created in the schema. Okay. And this object stores the URL of the files in the cloud storage. Okay, it also stores the settings used to access the cloud storage accounts like storage integration object. A storage integration object is a specialized object that manages the authentication and trust relationships between Snowflake and your external cloud storage. Syntax for creating the external stage is create stage command, and this is the syntax. Let's see external stage as well in action. For that, I will first go to my S3. I need to create a S3 bucket if I am not having. I'm already having the S3 bucket, so I'm not creating it. Cool. And the second step is you need to create the IAM policy. That also I had already created. I will just show you that this is the IAM policy I had created, Snowflake S3 Access. And the third step is you need to create the IAM role as well. Okay, this role will be going to responsible to have the relationships between S3 and your Snowflake accounts. I had already created my roles. Okay, the fourth step is we will go to Snowflake now and we will build the handshake between S3 and Snowflake. For that, I just discussed with you that we need to have a storage integration. So we will create a storage integration, create storage integration. If not exist with the, let's say, S3 integration, Jaswinder, and the type of storage integration here is external stage. These are all the properties which are mandatory required to create the storage integration. Okay, and then it asks for storage provider name. So in my case, it's S3, and then it will ask for enabled. I will say it is enabled. Enabled is equal to true. And then I need to mention my storage AWS role ARN. This is the point which will ensure the connection is made. Okay, and I will pass my ARN number here. Then it asks for one more, which is storage allowed location, and I will mention my S3 path here. Cool. This is pretty much required to create the storage integration. I will just hit enter and run. Okay, I had ran. Now I am going to create the handshake. For that, I need to say describe integration and my integration name. What I need from this is I need two properties. First one is this one, storage AWS IAM user ARN, and second one is this one, storage AWS external ID. So these two are required to me, and I will copy paste these values and I will go to my role. Let me show you. I will go to my role and I will go to trust relationships, and here I will add my ARN which I had copied from this one, IAM user ARN, and I will similar way I will copy my external ID, this one GQ15001, and I will copy paste that here and I will update my trust script. In this way the handshake is completed, okay, which I had already done. And now once we had updated the trust relationships in AWS role, now we will create a stage. Okay, in order to create a stage we need to say create or replace stage followed by my stage name, let's say my S3 stage Jaswinder, and then I will mention my storage integration. Storage integration is equal to, I will copy paste this, S3 integration Jaswinder, and then I will mention URL on which I am having my files which I need to stage here. I had pasted my URL as well. Okay, now I'm going to run this query. Cool, I had ran the stage. Now let's list the data inside this stage which we just had created. Perfect. So we are able to see the files which we had placed in our S3 bucket. I had placed this Titanic file, if you see here, and now I am able to see that file inside my Snowflake as well. Cool. Now I am having all the files inside my Snowflake. I will again write the copy into command and I will load the data into the table. Okay. This is my stage. And then I will mention my how many files. If I have multiple files, but as of now I am having one file there, so I will mention that. Now I need to mention the file format. Type is CSV. Field delimiter. So I had mentioned every property which is required to load this file. Now I'm just going to hit run button. The table does not exist. Cool. Let me create the table quickly. Done. Now let's try again the copy into command. Perfect. It had loaded the data into my Titanic underscore backup table. Let's query the table. Perfect. Perfect. I'm able to see my data inside my Snowflake, which I had placed in my S3. So this is a kind of batch loading process by using copy into command. So now let's move to schemas and let understand what is schemas. In simple terms, a schema is a logical folder inside a database. In Snowflake, you cannot have a table or a view just floating around in a database. It must live inside a schema. Let's try creating schema. So I had created the schema. Now similar way, I will create a transient schema. There are additional functionalities which are available in schema. We will talk about that now. So I will create a schema which is having these additional functions, and I will also explain you one by one. Okay. So now let's create that. Create, or I will say alter, because I will do in the same instead of creating multiple. Create or alter this one, and then I will mention alter schema, this schema, and then I will mention the first functionality in schemas we have is with managed access. Okay, so this is the first functionality we have. What is this is, in regular schemas, the owner of an object, okay, can grant further privileges. Okay, but in managed schemas, the schema owner manages all the privileges grants, including the future grants on objects in the schema. Okay, so if I say with managed access and if I create this, it will eventually have all the rights to the owner to manage all the privileges and grants. So see, this is created successfully, right? So this is the first one additional functionality here. Second one is yeah, data retention time in days. So as from name, it is clear that what it means. So data retention time in days is like how many days it should retain the data at least. So for enterprise edition, this is This is something we can mention between 0 to 90. And for transient schemas, this we can mention from 0 to 1. So that's the difference. In enterprise edition, we can mention 0 to 90 for permanent, and for 0 or 1, we can mention if the schema is transient schema. Okay, so this is the another property. So let's create that as well. This is the another property. Oops. Yeah. So this is the another property. So now we know the second property. And now let's add another property, which is max data extension time in days. So what is this? This is the maximum number of days Snowflake can extend the data retention period for tables to prevent streams on the table from becoming stale. Okay, so this is a very important one when you have streams in picture, and you can mention here, the days for which you want to get your data retained over and above this period of data retention. Okay, so this is second, this is third one, and next one is replace invalid characters. Okay, so if you have any invalid characters while loading the tables, you can mention this here, and it will either be true or false. I will mention as a false. Next one is default DDL collation. Okay, so this is also a very important one. A collation is a set of rules that determines how string comparisons are performed. Okay, so you can mention the default DDL collations if you have, like in my case, I will mention English CI, and that's case insensitive one. And last one is you can have one as comment. Okay, so every time I create a schema, I usually add comment that what the schema is for, so that a broader audience can have a better understanding that why I created this schema and what purpose it is fulfilling. If I just hit run and oops, what happened? Okay. Okay, perfect. So I had ran it and it ran successfully. So these are a few additional advanced functionalities which we can have while creating the schema. Now let's talk about the tables. There are majorly these kind of tables supported in Snowflake, that is permanent, temporary, transient, external, dynamic, hybrid, iceberg tables. So permanent is the normal table and most widely used tables in Snowflake. So it is normally used to persist the data until we actually explicitly require to drop the data. And for permanent table, the time travel we can do is up to 90 days, and there is a fail safe also available for 7 days. So it's a usual regular long time data storage tables, which is highly used in Snowflake. Second one is temporary. So temporary tables, are built for data that's only needed for your current session. Afterwards, it's purged. Since the data is automatically dropped when the session ends, they are very lightweight and cost effective. So as you can see, it's written that persistence is only session duration, and there is no time travel support, no fail safe support available. Fine. So the transient, third one is transient, and transient, are like the middle ground between temporary and the permanent tables. They are similar to permanent tables, with the key difference being that they lack fail-safe protection and they have limited time travel up to 1 day, as you can see. Typically, you would use them for intermediate storage needs where the data you are working with isn't it mission critical and but still needs to be accessed for more than one session. So that's a very, in detailed difference between permanent, temporary, and transient tables. So creation of these tables are very, very easy. I will just create a transient table for you. So I came into my Snowflake. I will just create a transient table, and I will name it as my temp table, let's say. And I need to specify my database and schema. So I am specifying this here. And then I will mention few columns. Let's say I mention one column ID, number data type, and created date as date. Cool. So let me run this one. Yeah. Perfect. Perfect. So I had created the transient table. Same way you can mention here temporary, and for permanent you don't need to mention anything and it will create the tables. So now if I go to what Snowflake documentation says about transient table, let's read that. So transient table is like Snowflake supports creating transient tables that persist until explicitly dropped. Okay, please take notes, that's very important. That transient table persists the data until it is explicitly dropped and are available to all the users with the appropriate privileges. Okay, transient tables are similar to permanent tables with the key difference that they do not have a fail-safe period. So now let's talk about external tables. External tables are, made to let you query data outside of your Snowflake warehouses. They are read-only, time travel and fail-safe are not supported. But external tables are an easy way to integrate with data lakes or archive data sets without ingesting them into Snowflake. Let's try to create the external tables here in Snowflake. So now in order to create the external tables, you need to have, three things. Okay. First is you need to have a storage integration. Second is you need to have the stage. And third thing, you have to have the external table created on top of the stage. Right. So let's create the storage integration first. Okay. So I will also write it here that what we need is we need storage integration. Second thing is we need is creating the stage, and third thing we need is external table DDL. Perfect. So now let's start with creating the storage integration. Create storage integration, and I will name it as S3INT, let's say. And type of this should be external stage, and then storage storage provider is my S3, and then there is a function called enabled. It's true. And then the most important one here is storage AWS role ARN. So this is the Amazon resource locator, which you can get via admins. This ARN number is required if you want to create a storage integration. And the last thing which is required is storage allowed location. Okay. Storage allowed locations. Okay. So which locations it can access, because it had created the ARN and it can, you know, go to the S3 bucket, and which location you want. Suppose I will just mention a one dummy one, S3, suppose my bucket Okay, let's suppose this bucket. So this is how you create the storage integration. As of now, I don't have a AWS account, and so that I can get the ARN and do a handshake between Snowflake and AWS and pass on the bucket name. I guess this should also work. Perfect. So it worked, right? So you create the storage integration. Storage integration, ensures that there is a handshake between Snowflake and your cloud provider. If your cloud provider is anything other than S3, you can mention that. And second thing is, create the stage. Okay, you need to stage the data, right? Create or replace stage. Let's say this is my schema. And if you see, this is my schema, Dima. And in this, I will create a stage name. What should I name? Okay, I will name it as my S3 stage. And the most important thing it requires is passing the URL. Okay, you need to pass the URL. Okay, that's the most important thing. And second thing you need to pass is file format. Which file format is this? As you know, I hadn't created any storage integration so that I can pass the actual S3 URL, but there is a open source URL. Type is equal to CSV. So let's try to run this if this works. Okay, so let's run this. Okay, so I had created the stage. Now let's try to list the stage. List at the rate. I will copy paste this. Let's try to list now. Oh, it's working. Perfect. So now if you see, it has already staged the data, and I am able to see all the files present in that location. Now I will create the third part, which is external table DDL. So what I will do, I will mention create or replace external table, then the table name, and I will copy paste this because I need to create in here. And then I will mention the external table name as ext, and this data is city bike. So let's mention city bike only. Let's see. So inside this, I will pass all the parameters. So for that, I need to see the file. So here is the file, which is open sourcely available, and in that S3 bucket. So what I am going to do is I'm going to copy paste all these names in my worksheet so that I can quickly create the DDL for external table, and I will just paste it here and I will just comment them. Perfect. So now I need to first create trip duration. I will mention here trip duration, and it's integer type. And as this is the standard, you know, process to, create it, and you need to follow the same. So this is first one. Okay. So I had filled this one. So I had create the replace external stage. I had mentioned the table name and I had filled that information which I had mentioned. And now there are another few things I need to mention below that. First thing is, how it get the data. In order to get the data, I need to mention the location for my stage. So what is the location for my stage? This is the location for my stage. I will copy paste here, and perfect. So next thing I need to mention is file format so that it can understand that which file format I am referring, and enter. And then I will mention type as CSV. And then I want to mention one additional, which is skip header, because in the file I had seen the header. So I need to skip that. And other which I can mention is, I usually mention is field optionally enclosed. It checks if it have that double quotes, and it removes them. Enclosed NumPy, and here I will mention double quotes, single one. And yeah, that's okay. Let's mention one more, null if. Okay, and if the option is null, then put as null, or even put blank. That's fine. So now let's run this. Okay, null if. Oh, perfect. So I guess I had created the table. So now I had my external table created. So let's query my table. Hopefully we will be able to see the data. Perfect, perfect. So if you see, I have got the data. I have got all the required data, uh, as you can see. So this is how we can create the external tables. And the external tables, that's why I mentioned that external tables are made to let you query data outside of the Snowflake. So if you remember, this is the outside of the Snowflake, this S3 bucket. So you can query the data, they are read only. So you can do much on that. Let's suppose if you want to try to update one, you can't update them because that's only read only. But let me try to show that as well in action. Let's say set rip duration is equal to 1. Let's see. See, update statement target must be table. So it does not support update script because it's external table. So, but external tables, are an easy way to integrate with data lakes and archive data sets without ingesting them into Snowflake, as you had seen. So this is the 3 steps you need to follow in order to create the external stages. So now let's move to the definition of external. So external stage is a Snowflake feature that you can use to query data in an external stage as if the data were inside a table in Snowflake. As you had just seen that our data was in S3, but we was able to query the data inside the Snowflake, right? The external stage is not part of Snowflake. You are already clear on that. So Snowflake doesn't store or manage the stage. Okay, Snowflake is not managing anything for you. It's you who are responsible for all those things, right? External tables let you store certain file level metadata, including file names, version, and related file properties. Okay. External tables can access data stored in any format except XML format. Make sense? So this is very important. Okay, please take notes. Okay, external tables are read only. You cannot perform any DML operations on external tables. And you had just seen that I was doing update and it was throwing error. So that's why, it is really important to do hands-on, and I will be ensuring that I will be doing hands-on as well. Querying data in the external table might be slower than querying data on the native Snowflake tables, obviously, because you are accessing data from outside. So it will take some time, to get the data from there. So obviously it is slower. So for optimal query performance, when you work with Parquet files, consider using Apache Iceberg tables, which we will be obviously covering in coming next, minutes, in few minutes only. So this is how, we can have external tables created. Okay, how we can have a transient table, temporary tables, and permanent tables created. Okay, now let's understand the dynamic tables. Okay, so dynamic tables, are Snowflake answer to real world and near real time analytics in a very, very easy words. Okay, so as you can see, it's written that dynamic tables is the virtual data generated on the fly. So it doesn't support any time travel. It doesn't support any fail safe. So it's just a real time data generation tool. Okay. So let me now go to Snowflake and create a dynamic table. In order to create a dynamic table, the command is very similar to normal table, but with additional features like target lag and warehouse. Target lag and warehouse, which it should use to refresh. Okay, so how to create it? It's very, very easy. Create or replace dynamic table and then table name. I will create the table in the same, database. I don't want to create much mess here. So I will use the same database. Dynamic table name, I will give it as DT as dynamic table, and I will say, let's say city bike only. Yeah, city bike. So now I need to first mention target underscore lag. So what is target lag? Target lag is the function in dynamic table by which it will wait till the time we mention the target lag, and after that it refreshes. So suppose I mention the target lag as, let's say, 5 minute 5 minute. So what is going to happen is, after every 5 minute, this this dynamic table will be going into the table, with its source table, and checking, hey, do you have a new data? If it is having new data, it will fetch the data. So every 5 minutes it will go and check the data, and if there is a new data, it will fetch the data. Okay, so this is the target lag. And it Snowflake says that it is near real time. So you if this is a near real time, the maximum target lag we should be having must be, suppose, 0.1 milliseconds, right? But ideally, that's the limitation, that data will be at most 1 minute old. Okay. Note, if you want 30 seconds, that's not possible. At most you can go is 1 minute. Okay, so I will mention this as 1 minute only. So next is warehouse. This is the second most important property we have. So as of now, I will use this one only, compute warehouse, compute underscore warehouse. And then I will mention alias, and I will do select, and I will run this one. Perfect. So I had created the dynamic table. So the most two important features is mentioning the target lag and warehouse. And suppose in next minute there is new data coming into this, it will automatically be flowing within a minute in here. Okay, so this is how dynamic tables works. Okay, so these tables allow user to materialize the results. Okay, and using both object references as part of any query, along with the input with the desired lag. If you see here, so the lag in this case is 1 minute. So this is the dynamic tables. So let's go to the definition. Definition says dynamic tables are tables that automatically refresh based on defined query and target freshness, simplifying data transformation and pipeline management without requiring manual updates or custom scheduling. So if you see this diagram, so this is, if these are the base table A, B, and C, and we are doing some kind of transformation. So it automatically refresh the process based on the target lag we had mentioned, and it automatically populates the data into the dynamic table. So it is basically materializing the results of a query into a table. Dynamic tables aim to refresh within the target lag you specify. For example, a target lag of 5 minutes ensure the data in dynamic tables is no more than 5 minutes behind that data updates to the base table. Okay, please take notes, guys. This is really important. And when we can use dynamic tables, okay, that's something which is very essential to know. So if you want to materialize the query results without writing custom codes, okay, if you want to avoid manually tracking data dependencies or managing any refreshing, and if you want to have multiple tables chained together to do some kind of data transformations, so this is where you can use dynamic tables. Now we'll discuss about the hybrid tables. So without getting too into the weeds of how data is stored and retrieved, let's just say that hybrid tables are generally optimized for one of two workloads. First is the use of data, and second is storage of data. Okay, so hybrid tables promise to support both of these workloads with optimizations for both a high volume of transaction and a single row lookups. So as per the definition, if you see, a hybrid table is a Snowflake table that is optimized for low latency and high throughput using index-based random reads and writes. Hybrid table provide a row-based storage engine that supports row locking for high concurrency. Okay. Hybrid tables also enforce unique and referential integrity constraints, which are critical for transactional workloads. So this is, very high level. What is hybrid table? So hybrid table basically is a row based storage engine, and it is known for low latency, and it provides very high throughput. Let's see how hybrid tables are created. We are going to discuss about hybrid tables. Cool. So in order to create the hybrid table, the command is very same as dynamic table one: create or replace hybrid table. And I will copy paste this one and just name it as hybrid tables. Okay. So here I need to mention obviously some column category name. I will say string not null. Let's run this now. Okay, so hybrid tables are not available to trial accounts. Basically, these are not supported on my trial account, but you understand how we create the hybrid tables, right? So as we just read the first one, so we'll focus on next one. So hybrid table leverage a row store as a primary data store to provide excellent operational query performance. Okay, when you write to a hybrid table, the data is written directly into the row store. Okay, so some of the data might be in columnar storage, but it is known to be stored as a row storage based tables. So if you see this image provided by Snowflake, so if you see the database storage part, all the other Snowflake tables are columnar based storage as we had discussed earlier, right? Snowflake stores data in the columnar format only. Exception here is hybrid tables. Hybrid tables store the data in the row based and for some extent in a columnar base. So majorly it stores in the row based format. That's why it is highlighted as a yellow different block. So this is hybrid table. Okay. So it's time to talk about the latest iceberg tables. Okay. So it's actually a reference to the table format created by Netflix. Okay. And then they donated that and is now Apache open source licensed one. So Snowflake had supported iceberg file formats in the past as well, but only via external tables. So they are great for managing robust data sets in distributed storage environments. So you can say that, Jaswinder, what's the major difference between iceberg tables and external tables then? As you just mentioned that Snowflake earlier used to provide this feature via external tables. So what's the difference? Okay, so the difference here is that for external tables, Snowflake looks the folder, scans the folder to find the file, okay, as you had just seen. But for iceberg tables, Snowflake uses the metadata file, okay, to know exactly which files to read before it even touches the S3 bucket. Okay, so it's much faster, and it supports full DML. Like in external tables, you don't have any DML access. You can just have read-only access. But in iceberg tables, you have full DML access. You can insert, update, or delete as per your requirement. So this is the major difference between external tables and iceberg tables, and that's why it is introduced as a next. It is introduced differently than external tables as iceberg tables. Okay, so iceberg tables use, as I just mentioned, Apache open table format specification, which provides an abstraction layer on the data files stored on open formats. Okay, so you are responsible for all the management of external cloud service location, including the configuration of data protection and recovery. Snowflake does not provide fail-safe for iceberg tables. Okay, that's point to be noted. There is no fail-safe for available for iceberg tables. Okay, you are yourself responsible for all the Parquet files behind the scene you are having. Okay, so there is iceberg catalog, which enables a compute engine to manage you and load iceberg tables, and it is a 3-layer architecture. Okay, 3-layer architecture includes obviously the data files. So these are the actual records stored in Parquet formats. Second is manifest files. These are index files. which stores the version of the tables. Okay, if I stay in a very easy words. And the third is metadata file. This is the source of truth. This is where we have all the snapshots, all the data, and it is the brain that tracks where the latest metadata store is located. Why we should use iceberg tables? So the first benefit of iceberg tables is no vendor lock-in. So as you know, your data is already outside of Snowflake in somewhere in S3 bucket. So you don't need to export anything out of Snowflake. So you can leave the Snowflake whenever you want. Okay. Second is interoperability. So you can query the files in S3 bucket or for all your BI needs, and same files can be used for Spark machines in parallel as well without impacting your Snowflake. And performance wise, where external tables are very slow, iceberg tables are actually quite fast, and it is very much similar native to Snowflake tables. Reason is it is skipping to look for the files in S3, and it is seeing the metadata layer to get all the details, and it is based on that it is working. Okay. So this is the image which shows how Snowflake operates with iceberg tables. So there is the external volume, if you can see, and the external storage cloud, suppose S3 or GCP or Azure, the files are there in Parquet format. And then comes into picture is external volume. So this is the secure connection, you can say a bridge that allows Snowflake to talk to your external cloud provider. Okay. So external cloud provider is different, and Snowflake is different, but this external volume works as a bridge. Okay. The next part is this iceberg catalog. So this acts as a librarian. It stores the current state of table and point in time snapshots. Okay. Allowing for features like time travel, if any you can. Okay. So next is metadata, this one. So it is showing metadata going to external cloud as well as to iceberg catalog. So this is known as metadata sync. So the arrows show a two-way relationships. Okay. Snowflake writes metadata to your storage. So other tools like Spark can also see the table updates. So this is a architecture of how iceberg tables work into Snowflake. External volumes comes into picture, and it creates a bridge, and then based on the bridge it creates the iceberg table, and eventually that iceberg tables require a catalog and the base location and external volume name. So let's create that, right? Okay, so we are back on Snowflake. I am unsure on trial version they will support it. It will support creating iceberg tables or not, but let's try to do that. Okay, if not, then obviously we will at least having the idea that how it is getting created. So the first thing we require in order to create the iceberg table is volume. As you had just seen in the image, that volume is very important. It is a bridge. So second thing we require, that is iceberg table with iceberg catalog. So these two things we require in order to work with iceberg tables. So I will start with creating a volume. Quickly create or replace volume, and then volume name I will mention the same way here. Okay, Control C, and here Control V. Create or replace external volume. Yeah, external volume. And then here I will mention, let's say, ice volume. Okay, ice volume. Okay, anything. So now I need to pass storage underscore locations. Okay, that's how it will create. So now inside this, I will create one more box, and inside that I will mention name of my storage bucket. Let's say my bucket name is my S3 US East. Okay, one also. Okay. So now what's the storage provider? Storage provider, and obviously in S3 here, and then storage base URL. Storage base URL. So we need to mention the base URL as well. So I will just mention as of now some dummy S3, let's say my iceberg. Cool. And then I need to mention storage AWS role ARN. So this is very important. Amazon resource one is really important. This is the only way you can have a handshake with, your external providers. Without handshake, nothing will work. You need to have a handshake. I will just mention something. So I guess you will get it what I mean here. So now after passing all these parameters and now this is my volume. Okay. So I will try to run it if this works. Unsure, but let's see. Okay. Spelling is wrong. Storage locations. Okay. Invalid one. Perfect. Let's try to leave it empty. Okay. So basically I cannot create that with the dummy ARN because I don't have that. So I guess you got it how we can create this volume. Once we create the volume, we need to create iceberg table. Replace iceberg table and I'm so sorry, spelling mistakes. And I will mention here my iceberg table name. Let's say TB. And here I will just mention one column ID integer. And I will come out. And as I just mentioned, first we need to create the volume. Second, we need to create iceberg table with iceberg catalog. So let's define the catalog. So for catalog, I just first need to have my external volume in place, external underscore volume, and the volume name is this one. So we just defined the volume. This one is my external volume. It will come here. We'll mention catalog as Snowflake because I want Snowflake to manage my metadata. So I am mentioning catalog as Snowflake and my base location. I will mention any table name here. Okay. As of now, I'm just putting it here. My table data. Okay. Let's suppose this is example, right? So this is how we will create iceberg tables. So invalid property, external volume. Oh, yes. Okay. So this is how we can create external volume. So now let's understand the views. So a view allows the result of a query to be accessed as if it was a table. Okay. Views serve a variety of purposes, including combining, segregating, and protecting data. Snowflake supports two types of views. First is non-materialized view and second is materialized view. There is third thing, which is secure views. Both materialized and non-materialized views can be defined as a secure views. So secure views are, very advantageous when it's come to privacy and data sharing. So, but they have some little impact on performance as well. So we need to take into that consideration. That's about views. And Snowflake, recommends to create a materialized view when all of these are true. Okay. The query results from the view don't change often. This almost always means that underlying base tables for the view doesn't change often. Okay. Or at least that the subset of the base table rows, okay, don't change. Okay. So the second is the results of the view are used often, and that's obvious. And third is the query consumes a lot of resource. Typically, this means that the query consumes a lot of processing power, time, or credits, but it could also mean that the query consumes a lot of storage space for intermediate results. Okay, so this is where Snowflake recommends to use the materialized views. Although, the materialized view is named as a type of view, in many ways it behaves more like a table. Okay, the materialized views results are stored almost as though the results are stored in the table. So this allows actually faster access, but it also requires storage space and active maintenance, both of which, obviously incur additional cost as well. So you can create a materialized view. Okay, so let's define a materialized view. In order to create a materialized view, that is again same like above, and create or replace materialized view and the view name view materialized ABC. Okay, as select star from one dummy table here. Control C, Control V. So let's create this. Perfect. So it created the materialized view as well. So there are, limitations for materialized views as well. So materialized view, as you know, they are highly optimized. So, but they come with strict house rules, you can say, like they can only query one table. Okay, you cannot use joins in materialized views. If you want to use joins, better to go with dynamic tables. Okay, and you cannot use violate functions like current timestamp and random functions like that. So let's try with that one as well. So let's mention comma current underscore timestamp as created. See, so you cannot use this. So this actually violates the materialized views features. So this is the limitations. Okay, the first is you cannot have multiple, you cannot query more than one table. Basically you cannot use joins, and you cannot use volatile functions like random, current timestamp, auto increment. So this is the limitation in materialized view. Otherwise this looks fine. Let's understand user defined functions. When there is a process we require to repeat multiple times, okay, at that time in any programming language we create functions, right? So that functions in Snowflake, technically called as UDFs, which is user-defined functions. So UDF allows you to perform operations that are not available through the built-in system-defined function. Okay, so we create UDF whenever there is a need to repeat the same functionality. So Snowflake supports 4 languages for writing UDFs: SQL, JavaScript, Java, and Python. This is really important. And UDF can return scalar as well as tabular results. And Snowflake supports UDF overloading, means if the same name we are having and we are passing different parameters, it will behave accordingly. So if I show you the sample UDF examples, as I told you, UDFs can be scalar or can be tabular. So I am showing you both the examples. So the keyword syntax for Snowflake is snow create function and then any function name, like as you see here, area of circle, and then you need to return the UDF. Okay, returning of UDF is very, very important. There is no way that you can create the UDF without return. You need to mention return and you have to return something. That's the function definition, right? It returns something. You create the function. If it is a scalar function, you can mention the return with a data type. And if that's a tabular function, then you need to mention return table and the columns required as the result. Okay, and this result you can directly use in any SQL queries. That's the biggest perk of UDF. This is the sample examples of how you can create UDFs and you can try that out. So let's focus on next topic, that is store procedures. And it's self-explanatory that it allows you to write procedural codes. Okay, that includes SQL statements, conditional loops, cursors, iterations. So you can create a stored procedures. It's a procedural code as in other languages as well. So Snowflake supports 5 languages for writing procedures. That's very, very important to remember. So Snowflake supports Snowflake scripting, JavaScript, Java, Scala, and Python. Okay. So from a store procedure, you can return single as well as tabular data. It's same as UDF. Okay. UDF also returns singular as well as tabular data. Same store procedure can also return it. It supports branching and grouping and it supports dynamically creating a SQL statement and executing it. You might say, what's if UDF is also doing some like that, and store procedure is also doing some things like that? What's the difference between them, right? So we will come to that. I will just show you the store procedure example. Okay, then we will go into the difference between UDF and stored procedure. Cool. So this is a sample procedure. Syntax for creating store procedure is create or replace procedure name. Then it can return or it cannot return. So you mention the return if you want to return something. And if you don't have anything to return, just skip that point. Then you need to mention your language, and then you need to quote everything inside double dollars. All the code will go inside that. And this is the simple store procedures example which I am showing you. If you have to call the store procedure, you just need to write a keyword call. It will call and with this name, and it will eventually call your store procedure, okay, in Snowflake. So that's how store procedure works. Now let's come to the most important part. What's the difference between UDF store procedures? Okay, so store procedure may or may not return values. Okay, store procedure can or cannot return. It depends. It's up to you. It's up to the requirement. But UDF should always returns the results. Okay. This is very important to remember. Very, very important. Okay. That UDF always return values. Okay, so now procedures are called as independent statements. Okay, functions are called in the SQL statements. So I told you earlier that you can use UDF directly. You don't need to worry, but you cannot use store procedure directly. Okay, so UDFs are directly callable using SQL statements, but procedures are not. Okay, values returned by procedures, as I just told you. So it's saying the same thing. Values returned by procedures are not directly usable, but whatever returns by functions, we can directly use anywhere. Okay. We can only have a single call per procedure. Okay. Single procedure per call, but we can call the function any number of times. Okay. Multiple number of times, a million number of times you can call the same function at the same time. It don't have any impacts. Procedures can execute DDLs and DML operations. Okay, this is another plus point, that procedures have DML and DDL support, but UDF don't have any kind of DDL support. That's a negative point, right? So this is the major difference between UDFs and procedure. Now you know what's the UDF, when you need to use the UDF, and when you need to use the stored procedures. What's the syntax for that, right? Cool. So let's move to the next point, that is file formats. Okay. So file formats is something which is very important when we have to stage something from outside of the Snowflake into Snowflake. We actually need to create the file formats. It is mandatory requirement to create a files format before creating the stage. Okay, because in stage property we do require that. So there are multiple file formats supported, and as you already know, it's CSV, Parquet, ORC, JSON, right? So there are multiple format type options based on each file format. Okay, so if I show you, this is the syntax for file format: create or alter file format, and then you need to mention the file format name. Okay, and then you need to mention the properties which we are just going to see. First property, if the type is CSV, okay, the file type option, format type options are compression, record delimiter, field delimiter, file extension, skip header, trim space, for field optionally enclosed, null if empty, field as null. So these are the major highly useful options which I use on regular basis. So it's nothing I had remember them. With the experience, with the hands-on, it automatically, I had learned that. So these are the most widely used format type options in case of CSVs. Okay, similarly, we have other format type options for JSON. Okay, like compression, date format, strip outer array. Okay, this is very, very, very widely used in JSON. Okay, replace invalid characters. So these are very, very important one. Okay, and then third, Parquet. So in Parquet, again, compression is there. Then use logical type is there. Binary as text. This is always, usable when we are, creating the file format. So same way in Avro ORC, we have these options, and same way in XML, these are the highly usable options. Okay, so You don't need to learn them, but you should have a quick gist that uh, about the most important ones. Like if you see in any kind of file type, there is a common file format type option, that is compression, right? So it's everywhere. So other very important are record delimiter, field delimiter, and file extension, obviously skip header. These are very, very important. Field optionally enclosed, null if, and in the same way here, trim space and replace invalid characters and then strip outer elements. These are those format types which even I use kind of regular basis. So you need to understand them, that what are the file formats and how we create them and what are the file types we supported in Snowflake, right? So what is stream? A stream object records DML changes made to table, including inserts, updates, and deletes. Also, stream stores metadata about each change. So streams are basically CDC process which ensures all your updates, inserts, and deletes are recorded in the streams, which is created on top of the table. Okay, so we call this process as CDC process. So stream tracks all the row level changes to the source table using offset, but doesn't store the changed data. Okay, once these changes are consumed by target table, this offset moves to the next point, and streams can be combined with tasks to set the continuous data pipelines. And if we have the Snowpipe and we also have streams and the task integrated, that process we can say is continuous data load. Okay, along with the changes made to the source, stream maintains 3 metadata fields as well. Those are metadata action, metadata is update, metadata row ID. Action indicates whether the DML operation is either insert or delete operation. Whenever you are doing something on the source table, it actually reflects into the stream in the metadata action table. If you are doing update, it will reflect as either true or false. Same way, it maintains a unique and immutable ID for the row, which we can say row ID, and we can track. This is used to track the changes for specific rows over the time. How does stream works, or how the data flows into the stream? For that, we need to go to Snow site and see the streams in action. Let's go there and see it. So first, I will go and create a stream. In order to create a stream, we need to mention create or replace stream and the stream name. Let's say stream name is Titanic stream. Okay, and I want to create stream on the table Titanic. Cool. Now I will hit run and my stream is created. Perfect. I had created the stream name Titanic stream. Now let me show you my stream. As of now, it will be empty. As of now, it is empty, but you can see there are 3 additional columns: metadata action, metadata is update, and metadata row ID is added inside along with the other columns. Okay. Now let me try to insert one entry and see if this stream is even working or not. This is my insert script. I will just hit run button, and my insert script, I had inserted one entry into my Titanic backup table. Now let's see how it impacted my stream. See guys, there is a new entry which is recording the row which I had inserted, as well as in the metadata action I am seeing the operation which I did is insert on the source table, which is Titanic backup, and this is the row ID, and I hadn't updated anything as of now, so this is saying metadata is update is equal to false. But this is how stream works, consuming data from streams. So we use merge statement for consuming the changes from streams and applying the same on our target tables. So to identify the insert script, we can use metadata action, as we just had seen that metadata action is insert, and metadata is update is false. Similar way for update, we can filter on insert and true, and for delete we can filter on delete and false. If you want to consume these changes to multiple tables, then we have to create multiple streams. Types of streams. So there are three types of streams. First one is standard streams. A standard stream track all the DML changes to the source object, including your inserts, updates, and delete. Okay, and this is the syntax which we had just seen. Second one is append only streams. Append only streams track only row inserts, and updates are deleted, are not recorded for this. So for the syntax change here is that we will just add append only as well in the above syntax. Third one is insert only. For that, we will add insert only. Okay, and it is supported for external tables only. Let's see what are tasks. Tasks are pretty much about scheduling. Okay, so if we go to the points, so we use task for scheduling in Snowflake. We can schedule either SQL queries or store procedures, and tasks can be combined with streams to implement the CDC processes. We can maintain a DAG of task to keep the dependencies between other tasks as well. Task requires compute resources to execute SQL, and we can choose either of them. If we mention the warehouse, then it will be a user managed, and if we don't mention the warehouse while creating the task, it will be a Snowflake managed. Okay, and this is the syntax for creating task. Let's see task in action. In order to create task, I need to write the script as create or replace tasks, and I need to mention the name of task. Let's say Titanic data refresh, then task, and then I will mention the warehouse. If I don't mention the warehouse, it will go to Snowflake managed, but I want to mention the warehouse, compute warehouse. Then I will mention the schedule, that how frequently you want to schedule this one. And as of now, I just want 1 minute. And similar way, I will mention a filter where system dollar, this is a Snowflake provide function, stream has data. Okay, it's a self-explanatory. I will mention my stream name, Titanic underscore stream, and it will ensure that it only runs when data exists inside that. Now I will mention insert script, insert into, let's say, Titanic final table with the few columns. I'm not writing the complete script. Okay, I'm just giving you syntax how we do that, column 3 and so on. And then I will mention select query, select star from Titanic stream. This is most important filter condition here, where I just want metadata $action is equal to insert. So this is a one example of task. Once you create the task, by default tasks are on suspended state. So you need to write one more script, alter task name, and then you need to resume manually first time. Okay, and then you need to mention resume. Then you need to mention resume. This is how you create the task. And if you want to stop the task in future, you can, instead of resume, you can mention suspend. And if you want to see the tasks, you can mention show tasks, and it will show you all the currently available tasks. As of now, we don't have, but if you have, these will be clearly visible to you here. Let's now begin with lesson 2.5, that is determine the appropriate data recovery solutions in Snowflake and how data can be restored. Here we will be covering about time travel, their cost, availability, and data corruption impacts, zero copy cloning, fail safe, and disaster recovery using replication and failovers. Let's talk about time travel. Time travel is a very famous feature of Snowflake. In Snowflake, time travel lets you access data that has been modified or deleted by querying previous versions of a table or a database at any point within the retention period. Okay, up to 90 days, depending on the Snowflake additions. Okay, the retention period define how long the Snowflake keeps the historical data, enabling you to use this feature for things like data recovery, debugging, or auditing. Now let's dive into three methods which you can use to query data from specific time in the past using the time travel feature. First is querying data using time travel with an offset. Okay, the first method of querying historical data is to use an offset. The offset actually represents a time difference from the current timestamp expressed in seconds. This method is great if you want to query data from a fixed amount of time in the past. Okay, the syntax for this is at offset, and then we will mention the number of seconds by which we want to go back. Second is querying data using a specific timestamp. This is the another method of using timestamp. Okay, and it is like to query data as it was at a specific timestamp. This method is helpful if you know the exact point in time you want to refer to, like the precise moment when the data was last modified or a known change occurred. Okay, the select query will be looking like that you can mention before and even after as well, and you can mention timestamp, and this is how you can query and do time travel using specific timestamps. Third is querying data using a query ID. Sometimes you want to look at a state of data before a specific SQL statement was executed, right? Snowflake actually allows you to do that as well, okay, by referencing the query ID. So query ID refers to the unique identifier assigned to every SQL query executed in the Snowflake. Okay, and this is the sample select statement how you can use the query ID to perform time travel. Okay, the keyword is a statement and you can mention the query ID here. It is unique throughout your Snowflake account. Cool. If we discuss about time travel use cases, time travel provides invaluable benefits in a variety of real world scenarios like recovering data, audit and compliance purposes, data corrections, and even business intelligence and analytics purposes. You can read the more details here. And now let's talk about the important considerations for time travel. First, a most important consideration of time travel is the retention period. Snowflake only retains the historical data up to 90 days. That's where you can only do time travel for up to 90 days. Second is cost. Time travel does incur cost for maintaining historical data versions. Be mindful for that as well, because you are creating versions in your storage, so it will incur you additional storage cost. Third is data modification and time travel. Time travel allows you to access data as it was at any point in time, but it won't be able to recover dropped objects like tables, schemas after the retention period has passed. Let's now see time travel in action. I am on my Snowflake, and first thing first, I will create a database, a schema, and table, and I will insert some dummy entries. I will say control enter. And perfect. I had inserted the records inside my employee salary table. I will comment this out so that you can use when you are querying. And first thing, it is just for my purpose. What I am going to do is I am just going to set a parameter which will just record the time before I am going to create disasters in your screen. Okay, so I just want to record it, and it will be much beneficial for me. Just a current timestamp. So I will store my current timestamp inside this variable. Now, as I had stored it, it's the time to create disasters in Snowflake. Okay. First thing what I will do, I will run an update script without any condition. Okay. I will simply say update employee salary stat salary is equal to, let's say, 99999. Before that, let's query the employee salary table as well. So I will say select star from the table, and let's see what are the current values inside my employee salary. As of now, I am having three records, and I am seeing distinct salaries for these employees. It's the time to create the disaster, and I will just run this update script. Okay, I had ran the update script. Now I will again query my table. And see guys, now I had messed up the data by updating the table without any condition, right? So now I need to do time travel, right? Because this is unacceptable. If anyone else see, they might raise an incident or concerns on that. So it's the very time that I should go, and before anyone notice, I should do the time travel. So I will say select star from my employee salary, and I want to retain my data. That's why I had stored that current timestamp inside a variable. But in your case, if you hadn't stored it, that's fine. There is nothing on that. You can just mention at timestamp, and then you need to mention the actual timestamp. Let's say you want to retrieve the data as per yesterday, so you can mention the yesterday date and time. But as I am having my variable, so I will just pass my variable here. And if I will do the select star, I should be able to see my data, which was before this one. So see guys, now I am able to see the data. This is how we can use add function, and add function is very specific for the timestamp. It will give you the data at the exact timestamp. But if you don't know the exact timestamp, you still can get your data using before function. So if I run this, it will give me the data before this timestamp. This is the one way to retrieve the data using time travel. Another way is using the offset. If you just ran the query and you don't want to go with the time travel, you know that I just ran this thing and the disaster happened, let's say just 5 minutes back. Okay, so you can simply say select star from employee salary at, you can mention a function called offset. Okay, and it will also give you the data. I just want to get the offset, let's say 2 minutes back. So I will say 60 into 2 because it's in seconds. If I run this, I should be able to see the data 60 minutes back. So 60 minutes back, it was 9999 only. So I need to go more back. Let's say go 4 minutes back. And see guys, now I got the data. So if you know timestamp, that's okay. But if you don't know that, no problem. You can still use the offset and go back in time. There is one more which you can use, that is statement. Okay, so you can do that. I will just write a select for you. You can just try that as well. Select star from employee salary, and you can say before, and inside that you can mention statement. And here you need to mention the statement. Okay, let me go to my query history. For that, I will go to monitoring and I will click on query history. Here you can see the query ID, which is nothing my statement. So I will go to the update statement, which I had ran. Once I click there, I can see my query ID. I can just copy paste my query ID from here, and I will go to my worksheet again. And inside this, I will copy paste my query, and if I run this, I should be able to see the data. This is how time travel works. Let me show you one more thing. Suppose you accidentally dropped the table. Okay, you want to drop some other table, but due to some typo issue, you accidentally drop the table. In many other data warehouse solutions, you cannot do anything. You just need to refresh from the production back to your environment. But inside Snowflake, we have undrop function. So I will say undrop table employee salary. So I will not run this. Okay, first I will try to query this employee salary table. If this is the query, because I had dropped it, if I query the table, I should be able to see object does not exist. Now if I again click on undrop and run this query, it ran successfully. Now if I try to run the select star, I should be able to see my data back. This is how time travel works. Let's discuss about cost of time travel. Time travel is not free. While there is no extra fee for the feature, you pay for the storage of the historical data. If we talk about storage calculation, Snowflake uses 24-hour averages to calculate storage. When you update a row, Snowflake does not copy the whole table. It only stores the before image of the changed micropartitions. Next is churn impact. Tables with high DML, like frequent updates or deletes, will accrue significantly higher time travel cost because more historical micropartitions are being preserved for that data, right? And third is fail-safe transition. This is not in your hand, but you can request to Snowflake to retrieve your data It is not something which you can do. It is something which Snowflake support can do on behalf of you. Once the time travel expires, data moves to the fail safe for 7 days. You are built for storage in both the stages, either in time travel, either in fail safe. If we talk about time travel availability, in standard edition, the time travel availability is maximum of 1 days, but in all the other editions, you can set a time travel availability from 0 to 90 days. Next topic is query performance impact. First is metadata overhead. Queries using at or before rely on metadata layer to find the correct version of micropartitions. While Snowflake metadata layer is highly optimized, extremely complex time travel queries on table with 90 days of heavy churn can involve scanning of massive number of historical metadata entries. Next is cloning performance. Zero copy cloning from a point in time is nearly instantaneous because it only copies the metadata pointers. It does not impact the performance of the source table. Third is warehouse impact. Time travel queries use the standard virtual warehouse resource. There is no specific time travel compute. If you query a 10 TB table from 40 days ago, your warehouse must still process that data, which may be slower if those historical micropartitions are no longer cached in the warehouse SSDs. Next up is data corruption impact. For Snowflake Architect exam, understanding how the platform prevents, manages, and recovers from data corruption is critical. Snowflake's architecture is designed to be self-healing in many respects, but we must understand the levers available to maintain data integrity. And the first way to prevent data corruption is preventive architecture, which is immutable storage. Snowflake places data within micropartitions. When the micropartition is written into a S3, Azure Blob, or GCS buckets, it is immutable and there is no in-place updates. If you try to update or delete, it does not modify the existing file. Instead, it creates a new micropartition and flag old ones for deletions. And the original data is still accessible through the history tool so that deletes are effectively snapshots rather than the actual removals. And the impact of immutable storage is it prevents bit rot or partial writes, which are a source of inconsistency within the state of a table. If a write attempt is interrupted, the entire transaction aborts and there are no intermediate states produced. Next up is recovery mechanism. When records are logically incorrect, Snowflake provides 3 primary recovery layers. These are time travel, fail-safe, and table streams and CDC. Time travel allows you to query or restore records from a specific location beyond the time up to 90 days for enterprise edition and 0 to 1 day for standard edition. You can use the undrop or clone command to a table with a specific timestamp. And the failsafe is a 7 days non-configurable extension after the time travel expires. And this is something which you cannot do, which you need to request to Snowflake support team, and they will be involved in recovering the information due to catastrophic corruptions. And third is table streams and CDC. We should use streams for changes. If the corruption occurs at some stage of a transformation, movement metadata can help realize exactly which offsets have been processed incorrectly. Next up is data validation during ingestion. The most corruption enters the system at the point when you are using copy into command, and we have validation mode to use as a parameter to parse the files without loading them. It identifies the errors like inconsistent schemas or incorrect CSV delimiters before they even hit your staging tables. Next up, data validation parameter is own error. This provides us options such as abort statement or skip file percentage, which saves the partial dirty records from entering the staging layers. And then we have external tables. Since Snowflake does not own the documents in the external tables, corruption in the underlying cloud storage will defeat the purpose of queries. You must use refresh and metadata inspection to ensure the synchronization is happening properly. Next is data encryption and integrity. For that, we have hierarchical key model, which we had already discussed multiple times. Snowflake uses a multi-layered encryption key hierarchy. If a key is exchanged or managed incorrectly, records can appear as inaccessible, a form of functional corruption. Then we have checksums. Snowflake typically places checksums on registry files at some point of migration and garaging to ensure that the information red is exactly what was written in the staging tables. Last up is cloning for sandbox and lower environments. To save you from corruption through complex migrations or system changes, zero copy cloning is a number one tool. Clone the production's environment directly into the pre-prod or sandbox or dev. Run the architecture changes there. If the metadata pointers involve incorrect logic, production facts remain unique and secure due to the fact that cloning creates a separate metadata layer. This is pretty much about data corruption impacts and the guardrails provided by Snowflake to prevent the data corruption impacts. Now let's talk about cloning. Zero copy cloning is a powerful feature in Snowflake that allows you to create a clone of database, schema, or tables without duplicating the underlying data. Okay, it does not duplicate any data. This means that the clone is created almost instantly and does not consume any additional storage space initially, making it an efficient way to manage and experiment with the data. So this is very helpful and most important topic, zero copy cloning. Whenever we are doing zero copy cloning, we just point to that data. We don't duplicate any kind of data to the lower environments. Cool. Key features of zero copy cloning. First is instant cloning. Clones are created quickly as they reference the same data as the original object. This allows for near instantaneous creation of clones, even for large data sets. Second is storage efficiency. Initially, the cloned object does not take up additional storage space as it points to the same underlying data. Storage is only consumed as changes are made to either the original object or the clone. Okay, this is very important to note, guys. The changes are only storage is only consumed whenever there is actually change in the original object or even in the clone. Third is independent changes. After a clone is created, it can be modified independently of the original object. So changes made to the clone do not affect the original object, and vice versa is also true. This is very useful for testing and development without risking the integrity of actually the original data. Point in time cloning, you can create a clone of a table, schema, or database as it is existed at a specific point in time using time travel features, and we will obviously cover that in a few minutes. This allows you to recover or analyze data from previous states very easily. How to use zero copy cloning? To create a clone in Snowflake, you needs to use the clone command, and here is the example. You can clone table, database, and schema, and you can say create table by table name, and then you can use the clone function and then your clone value. Now let's discuss about failsafe. Failsafe again is a very interesting topic, but this is something which is Snowflake managed. So let's discuss about the definitions. Snowflake failsafe is a feature to ensure data protection. Failsafe is a part of continuous data protection life cycle provided by Snowflake, and it is a non-configurable 7 days further storage of your historical data when actually your time travel period has ended. So suppose you had set the time travel period of 90 days and today is 93rd day, you can't access the data of 93 days as it has already passed the 90 days window. In that case, if you want to recover the data, you need to touch base with the Snowflake support team, and they can only get your data back to you, and that too if that comes in the range of 0 to 7 days after the time travel window is expired. Cool. If we update or delete the n number of rows from a table, then these updated rows will be retained first in the time travel history we just discussed, which is up to 90 days. Once the time travel history ends, Snowflake still keeps the data for further 7 days as a backup. Okay, this is however important to note that time travel data can be directly queried by customers, but fail-safe data can only be recovered by requesting to the Snowflake support. Okay, you cannot recover during your fail-safe time. Only Snowflake support can help you in recovering the data. And also time travel and fail-safe both contribute to the storage cost as well. So you will be paying for fail-safe as well. Cool. Why even fail-safe exists? Data are backed up at regular intervals. There can be situations between two backups during which data has been accidentally changed or deleted due to some mistake. So the fail-safe provides a quick and efficient way to recover such data with minimal cost and minimal efforts. Okay. Now, the key features of failsafe, as we discussed, that the amount of storage for failsafe can be of 0 to 7 days and it is non-configurable. And for permanent table, fail safe is 7 days. This is very important from examination point of view. For transient and temporary table, fail safe is 0 days, and users are not allowed to query on fail safe. So data can only be recovered through the Snowflake support. Let's start with data replication and failover. If you see this diagram states how Snowflake enables customers to replicate objects such as database, keep them synchronized across multiple accounts in different regions or cloud providers. Customers can also fail over to another region or cloud provider to continue the business operation during outage or availability disruption. Snowflake provides us URL for clients to connect to Snowflake, which automatically redirects to the target account during failover. So if there is a failover in this area, automatically Snowflake provides a URL for the clients to connect this target area whenever there is a failover. If you see the second diagram states if a data is replicated across multiple cloud regions or providers, either when the disaster occurs in one region or cloud providers, customer can immediately access and start querying data in different region or cloud provider, as you can see in this diagram, by spinning up new stateless instant on scale to 0 virtual warehouse in the target region. Let's move to the definition. Replication is the process of syncing database objects from primary account to one or more secondary accounts in different regions or even different cloud providers. Make sense? Cool. So key objects replicated includes permanent and transient table, metadatas, and even integrations as well. And if I talk about the replication process, that includes primary databases, secondary database, and refresh mechanism, which incrementally transfers data to minimize the overall cost. Cool. Let's talk about failback and failover. When replication moves the data, failover is the action of switching operations to the secondary side during an outage. Whenever there is an outage in a region 1 and we had already done the replication in region 2, failover ensures that it automatically switch operations to the secondary side. The business continuity features include failover groups. You group the databases and the account objects together, and if a region goes down, you fail over to entire group to the another environment, and your process keep functioning. You don't need to wait till it's come back. Second is client redirection. Snowflake provides a connection URL. Instead of changing your application code, you simply point to the URL to the new primary site. Cool. Third is promotion. Whenever you are having a failover, the secondary database is promoted to the primary database and it is now eligible to do all the reads and writes. Okay, this is very important to note. We need to also remember these specific rules. When it comes to database objects, only permanent and transient databases are replicated. Second is credit consumption. Replication uses the compute credits and cloud service credits. You are also charged for data transfer fees. Okay, this is over and above the compute credit charge across regions or clouds. Third is database shares. You can replicate database that are being shared, but there are specific steps to ensure the share objects exist in the secondary region. Okay. And external tables. Standard replication doesn't include the physical files in your external stages, but you must manage those underlying storage replication by yourself. This is not something which Snowflake manage. Cool. With that, let's also quickly discuss about the replication cost. So replication cost includes data transfer cost, compute cost, and storage cost. They are billed to the target account. Okay. Snowflake provides compute to copy data between account across regions and build to the target. Whenever there is any replication, the billing will always be going to the target. This is very important to note. And the target account also incurs the cost for all the background processes that service, even materialized views, or even you have search optimization. All the things will be tagged to the target account. Furthermore, the target account incurs storage cost for the data in even secondary databases as well. Okay, so this is pretty much about application cost as well. So in very short, replication cost is tagged to target account and it includes data transfer cost, compute cost, storage cost, and even background processes cost for services like materialized view and search optimization as well. Here are the steps to create replication in Snowflake. So first step is we will enable replication to the account. Before you can replicate a database, the source account must follow replication to the target account. This is actually a security handshake. Step 2 is create a secondary database, which is also known as a replica. And on the target account, you create a database linked to the primary one. This creates a shell that is ready to receive data but is initially empty. Step 3 is perform the initial refresh. So creating a secondary database only creates the metadata link, and we just discussed that initially these are empty. So to actually move the data, you must trigger a refresh. This is where the Snowflake performs the heavy lifting of copying data across the regions. Okay, in order to do the refresh, you need to use the script like alter database and database name and with the refresh function. Fourth step is scheduling the recurring refresh. This is optional but recommended approach. For production environments, you don't want to run manual refreshes. You can automate this using Snowflake task or even by using a failover groups, which allows you to schedule synchronization. And the fifth step is configure a failover group. This is at least supported for business critical editions. Well, we had reached the domain T, that is data engineering, and we are gonna start with lesson 3.1, that is determine the appropriate data loading or unloading solutions to meet the business needs, where we will be covering all the topics which are required for Snowflake Advanced Architect. That includes data sources, data ingestions, architecture changes, and data unloading. And we will be going in depth in all these topics which are required for Snowflake Advanced Architect exam. Let's begin with data at rest. Data at rest refers to information that is physically stored on storage disk within the Snowflake environment. This includes data in permanent tables, transient tables, and metadata. Snowflake automatically encrypts all the data at rest using AES-256 strong encryption. This happens transparently, meaning you don't have to manually encrypt columns or files before loading them, and this is known as transparent encryption. Then Snowflake uses a multi-layered key hierarchy. The higher level keys wrap the lower level keys, and this is we had already covered in hierarchical key management system. Next up is key rotation, where Snowflake automatically rotates the key periodically to limit the blast radius if a key were ever be compromised. And then we have try secret secure. This is valid for business critical editions or above editions. For more higher security tiers, Snowflake allows a composite key approach, where the master key is the combination of Snowflake managed key and a customer managed key stored in the customer's KMS. Next is data in motion. Data in motion is data that is traveling between Snowflake and the BI tools or between different cloud regions. All the communication between Snowflake UI, CLI, and connectors is encrypted using TLS 1.2 or higher, and this is known as TLS SSL encryption. And when you move the data from any external stage like S3 bucket to Snowflake, the data remains encrypted during the transfer. This ensures secure data loading. And then we have internet network communication, where data moving between Snowflake's internal services stays within a secured private network environment provided by the cloud vendor. Next up is external sources and formats. Snowflake, when connects to the big three cloud providers, are configured as external stages or external volumes. First is S3. This is the most common source. You can use IAM roles by creating storage integrations for secure keyless access. Then we have GCS. You can integrate GCS via GCS service accounts. Then we have Microsoft Azure, which supports Azure Blob Storage and Azure Data Lake Storage Gen 2. If we talk about the formats, the CSV and TSV format supports loading as well as unloading, and this is the most flexible, and it supports custom delimiters, headers, and encodings. Next, JSON. JSON also supports data loading as well as unloading, and it supports new line delimitation and standard JSON arrays. Similarly, Parquet also supports data loading and unloading, and it is optimized for columnar storage, where Snowflake can infer the schema directly from these files. If we talk about Avro, ORC, and XML, they are supporting for loading, but they don't support data unloading. They are popular in Kafka, columnar storage, or in a variant column scenarios. Next up is OLTP and RDBMS sources. Snowflake primarily focus on OLTP lab systems designed to ingest and analyze data from various OLTP and RDBMS sources. The most common sources and methods for integrating these databases into Snowflake are PostgreSQL. This is frequently used for real-time application data and integrates via native connectors or streaming tools. Next is MySQL. This is a popular source for e-commerce and web applications, often replicated to Snowflake for reporting layer. Third is Microsoft SQL Server. This is often migrated from on-premise or cloud environments for centralized analytics. And next is Oracle. It is integrated using CDC to capture transaction logs without impacting the production performance. If we talk about native ingestion methods, Snowflake have Snowflake native connectors, which provides direct connectors for PostgreSQL and MySQL that uses a universal agent to handle initial snapshots and incremental CDC. Next is Snowpipe streaming. This is a low latency ingestion service that allows RDBMS data to be streamed directly into Snowflake tables as rows are updated in the source. And we will see this in action in next few minutes. Last up is hybrid tables. While Snowflake is mainly OLAP, but hybrid table allows for some OLTP workloads directly within Snowflake by providing fast single row lookups and writes. Next one is API sources. The Snowflake provides several API sources for both managing its infrastructure and ingestion data from external services. These can be categorized by primary functions like APIs to ingest and manage Snowflake. These allow you to interact with Snowflake resources like tables and warehouses or users programmatically. First up is Snowflake SQL API. This is a REST API used to submit SQL statements, manage deployments, and check the status of executions without needing a persistent connection. And then we have Snowflake Python APIs, a unified layer that provides a first-class Pythonic way to manage Snowflake resources without writing a raw SQL. Next up is Snowflake REST APIs. This is open API compliant endpoints that enable developers to build end-to-end automation for resources like databases, virtual warehouses, and security policies. Then we have Snowpark API. It provides libraries in Java, Python, and Scala for querying and processing data at scale using native programming constructs instead of SQL. And then we have Cortex REST API. It is specifically for assessing AI ML features like LLMs from providers like OpenAI and Anthropic directly within the Snowflake. Next up is the most important and my favorite topic, Snowpipe. Snowpipe is a feature that enables automated micro batch loading of data as soon as files are available in the stage, typically within minutes. It utilizes serverless compute resources, eliminating the need to manage virtual warehouses for ingestion. Snowflake supports continuous data ingestion from cloud storage like S3, GCS, Azure from structured and semi-structured data. The key aspects of Snowpipe are automation, because you can use event notification to detect new files and remove the manual copy into commands. Then it is serverless, because Snowflake uses compute managed by Snowflake and you don't need to worry about warehouse but incurs additional cost which is separately billed to the user. Next is pipe object. A first-class Snowflake object pipe is created to define a copy into statement and source target mappings. Last is Snowpipe streaming. This is the newer feature that allows loading data directly into tables within seconds without needing the staging files, offering lower latency for real-time applications. Let's see Snowpipe in action. I will go to my Snowflake instance. I am into my Snowflake and I had created a file name as snowpipe.sql. Before I do anything in my Snowflake, I need to move to my AWS, and first thing I will go to my S3 and I will create a S3 bucket. I will click on create bucket and I will name the bucket as, let's say, Snowpipe demo 2026, and I will click on create bucket. I had successfully created my bucket. Now I will create the IAM policy so that I can have a handshake between my S3 and Snowflake. So I will go to my IAM and I will click on policies and I will click on create policy. And now I will select a service, and in my case service is S3. So I will type S3 and I will select that service. And once I select it, I want all the S3 actions to be performed. So I will select the manual actions as all S3 actions. And once I select them, I will go down and I will select all the resources as of the moment. And then I will click on next. Then it's time to create the policy. I will say my policy name is Snowflake S3 policy, and then I will create the policy. And perfect, I had created my policy. Let's check the policy. I can see my policy. It is customer managed, and that's what I want. It's the time to go to roles and create a role as well. I will go to my roles. I will click on create a role, and service I want is S3. I will click on S3, and then I will go next, and then I will select my policy which I just created. That was Snowflake S3 policy. I will attach the policy and I will click on next, and then the role name I need to mention that. Let's say role name is Snowflake S3 role. Cool. And then I will just click on create. And that's it, guys. I had created my role in AWS as well. Cool. It's the very time that I move back to my Snowflake, and first thing I will create a storage integration. So I will say create or replace storage integration, and my storage integration name, let's say S3 Snowpipe integration. Okay. And then I need to mention the type is external stage, external underscore stage. And then I will mention storage provider in my case is S3. And then I will mention enabled is equal to true. And I also need to mention my storage AWS role ARN, and I also need to mention my storage load location. Cool. How can I get this storage AWS role ARN is, I will go to my roles. Okay, this is my role. I will click here. And here, once I click on my role, I should be able to see my ARN number. I will copy paste this ARN number and I will go to my Snowflake and I will paste it here. Inside the single quotes, I will place this. And similarly for storage load location, I need my S3 location. So I will move back to my AWS. I will go to my S3 and I will copy the S3 path. For that, I will just click on my bucket and then this Snowpipe demo 2026, I will copy paste this and I will come to my Snowflake. I will say S3. Then I will copy paste and inside this, I will be having my files. Cool. And that's pretty much, guys. So I will hit run and create the integration. And perfect, guys. I had successfully created my integration. It's the very time that I should describe my integration. I will say describe integration S3 Snowpipe in, and I will hit run. And from this, I will copy two things. First thing, I will copy this storage AWS IAM user ARN, and the value of this is this one. I will just copy paste on my screen. I will just comment it here. And second thing I need is this one, storage AWS external ID. Okay, I will copy paste this one as well. And below that I will comment that. So these two things I need to specify inside my role trust relationships. So now I got these two things. I will first copy paste my IAM user ARN and I will move back to my AWS and then I will go to my roles. I will first go to IAM and inside the IAM I will go to roles. Then I will select my role which we just had created. Then I will go to trust relationships, and inside the trust relationships I will edit the trust policy. Okay, here what I will do is inside the principal I will remove this one. Okay, and then I will mention AWS and I will paste my IAM user ARN here, and similarly I will go back and copy my external ID as well. I will go back here and after the actions, I will add a comma and then I will add a condition. And here I will say string equals and I will say STS external ID and I will paste my copied one. And Guys, that's pretty much I require. Now I will just click on update policy. And that's it, guys. Now my role should be having access to the Snowflake. So there is a bridge we had established between Snowflake and my S3 bucket using storage integration. It's the very time that I should create other things like file format. So I will say create or replace file format, and then I will mention, let's say, my CSV format, and then I will mention my type in my case is CSV, and then I will mention field delimiter, and my field delimiter is comma, and then I will say skip header because my first record inside my file is header, so I will say skip header is equal to 1, and then I will say field optionally enclosed, and I will mention single quotes, and then I will say null if there is any null value, I want to replace that with null, or let's say null, and let's say empty field as null as well. Empty field as null is equal to true. Cool. Now I will hit run, and I had successfully created my file format. It's the very time that I should also create a table. I will say create or replace my employee table, and I will fast forward here. This is my employee data table DDL. I will hit run, and then I need to create the stage, right? So for that, I need to say create or replace stage at the rate stage, my S3 stage, let's say, and I will mention the URL here. And then I will mention my storage integration. And my storage integration name is S3 Snowpipe int. I will mention that here, and I will hit run and create the stage. And perfect, guys, I had created my stage as well. It's the very time to come back to the main topic of creating a pipe. Now I will say create or replace pipe. Let's say my CSV Snowpipe. And then I will say auto ingest whenever the new file is coming. Please ingest is that file ASAP. So I'm saying auto ingest is equal to true. And here I will mention my copy into command. So I will say copy into my EMP data table from my stage. My stage name is my S3 stage. And then I will mention my file format. And I will pass on my format name, which is my CSV format. Perfect. And that's it, guys. I will hit run and create a pipe. Once I had created the pipe, I will click on show pipe. And I am able to see my newly created pipe. Now I will copy this notification channel, and the reason why I am copying this notification channel is I need this notification channel to create the event notification in the AWS S3. I will go back to my AWS. I will go back and hit on the AWS homepage, and then I will go to S3, and then I will move into my bucket, and here I will go to properties. And if I go down, I have an option called create event notification. So I will click on create event notification, and I will give the event name, let's say Snowpipe ingestion. And then I will mention the suffix if it is valid that only CSV files load into the stage. Then I will click on all the create events and then I will go down, go down, go down. And here I will click SQSQ and then I will say enter SQSQ ARN. And inside this, I will copy paste my notification, which I had copied from my Snowflake by using Snowpipes. So I will copy paste this notification channel here. And once this is done, I will click on Save Changes. And that's it, guys. That's it. It's the very time that I go to my Snowflake and I will just run the select star from table. So initially my table is empty, as you know, but I will still run it. And as you can see, query produced no results. This means my table is empty at the moment. I will just go to my S3 bucket. I will click on here. I will upload a file. I will click on add files and I will upload, let's say, employee file. And then I will say upload. And now within a minute or so, this file should be consumed and automatically I should be having data inside my employee data table. Okay, let me try refreshing it. It might take a minute or so. So we have to be little bit patient. Snowpipe is not something which ingest your things in milliseconds. It take time, maybe a minute or something, depends on the file size. Let's keep on querying this employee data table and we will be able to see data. As you can see, we are able to see two records because my file is only having two records. If I open this file and show you, I am only having two records. So that's the reason I am seeing both the records here. And let's now consume one more file. Okay, I will rerun this and I can see both the records. Now I will go back here and I will upload one more file. Okay, and this time I will upload employee underscore one file as well. Here also in this file we are having two records only. I will click on update, and once I had uploaded this file, now this time Snowflake should not be consuming this file. It should only be consuming this file, and it will be only consuming this file because it tracks the history that which file it had already consumed. The files which are consumed, they are not eligible to be reconsumed. Okay, so if I go back to my Snowpipe and I will keep on running this select star, maybe in the 10 seconds or 20 seconds, I should be able to see four records now. So I will wait for a, yeah, see guys. So I don't even need to wait. So it had completed his work within seconds and now I am able to see all the four records. This is how Snowpipe works. Hope you really enjoyed it. I had to copy pasted all my scripts, but I am removing my these ARN numbers because of security reasons. Okay, and yeah, that's pretty much ready for you guys. Let's now discuss about Snowpipe streaming. Snowpipe streaming is Snowflake real-time ingestion service built on the high-performance architecture. It enables applications to load streaming data directly into Snowflake tables as rows, arrive without staging files or managing any kind of intermediate storage. Data becomes available for query within seconds of ingestion, supporting use cases from IoT telemetry and CDC pipeline to fraud detection and live analytics. Snowpipe streaming delivers up to 10 GB per second throughput per table, as low as 5-second end-to-end ingest to query latency, exactly once delivery through built-in offset token tracking and ordered ingestion within each channel, and also streaming into Snowflake managed Apache Iceberg tables. If we talk about the use case where to use Snowpipe streaming and where to use Snowpipe streaming is intended to complement Snowpipe, not to replace it. Use Snowpipe streaming in scenarios where data arrives as rows, for example, Apache Kafka topics or IoT devices or application events instead of files. With Snowpipe streaming, you don't need to create files to load data into Snowflake. So always remember, Snowpipe is recommended for the use case of with files, and if you don't have files, the data is coming in the form of rows, then you need to switch to Snowpipe streaming. Cool. Next up is reload process. In Snowflake, the reload process typically refers to the actions required to re-ingest data that has already been recorded in the load history, which is the metadata Snowflake uses to prevent duplicate data from being loaded. How it works is that Snowflake stores the load history in the target table metadata for 64 days for bulk loads and in pipes metadata for 14 days in case of Snowpipe. And when executing the copy into command or Snowpipe operation, Snowflake checks this metadata to skip the files that have already been successfully processed. This we had seen in our Snowpipe demo, that we had two files there. One was processed and second was going to be processed. Snowflake only processed the file which is not processed and it skipped the file which is processed. This it achieved using the metadata persistence. How to reload data? To force Snowflake to reload files that are already present in the load history, you must override the deduplication check using the force option. You can set force is equal to true into your copy into statement. This ignores the existing load history and reprocesses all the files. Okay, and then in case of Snowpipe, you can just refresh the Snowpipe. You can just say alter pipe, your pipe name, and refresh, and this command will automatically check the stage for the files added within the last 7 days, and it will queue them again for reloading. And the third thing you can do is you can reset the history. If you truncate a table, the load history for the table is often cleared, allowing files to be reloaded without the force parameter as well. Next up is incremental updates compared to the full updates. Incremental updates in Snowflake, often used with dynamic tables or streams or merge, calculate and apply only the changed data since the last refresh, making them cost effective and fast. In contrast, full updates or full refresh build the entire data set, which is resource intensive and expensive. Incremental is best for large high frequency data, while full is used when complex logic inhibits incremental tracking. We talk about speed. Full refresh is slower and obviously incremental refresh is faster because it only scans the delta records. Full refresh cost is higher than incremental refresh. And if we talk about complexity, full refresh is very simple. Actually, you are just doing truncate and reload. But for incremental, it is a little bit more complex because you are required to do CDC to detect the delta changes. If we talk about accuracy, full refresh is highly accurate because eventually you are just truncating the whole system and reloading the whole history. But incremental, it depends on the tracking integrity, which columns you are using for incremental refresh and how it working internally. Next up is schema detection and table schema evolution. This is one of the most advanced architect exam topic. You should definitely conquer that. This is non-negotiable one. Snowflake provides native capabilities for both identifying the structure of incoming data and automatically adapting table schemas as that data changes over the time. Talk about schema detection. Schema detection allows you to automatically define the column names and data types of the files staged in the cloud storage without any kind of manual inspection. Supported formats are Apache Parquet, Apache Avro, ORC, JSON, and CSV. And the functions which required for schema detection are infer schema. It scans a set of staged files and return the dedicated schema metadata like column name, column data type, nullability, etc. And second is generate column description. It uses the output of the input infer schema to generate the formatted list of column names and types for DDL statements. Third is create table using template. It automatically creates a table structure based on the schema detected by the infer schema. We will see this in action, but you should know that whenever you are working with schema detection, you need to take care of infer schema, generate column description, and create table using template. Next up is table schema evolution. Evolution allows a target table structure to automatically update during data ingestion when new columns are added or constraints need adjustments. It is very simple to implement. You just need to say alter table my table set enable schema evolution is equal to true, and next time whenever the copy into command will run, it will automatically detect the schema evolution and do the needful. Let's see this in action. I will go to my Snowflake, and here I had already written the scripts for schema detection and schema evolution. First we will create the file format, and once the file format is created, we will create a stage. In stage we will mention the file format, the URL where I am having the file, and the storage integration which we will be using. Here I am not creating the storage integration because I am reusing the storage integration which I had created in the Snowpipe tutorial. So I will run these two scripts. I will hit run. And perfect. I had created my internal stage. It's the very time to go for schema detection. Okay, for schema detection, we first need infer schema. So infer schema needs two parameter, location and the file format. If I just do select star using the infer schema, I should be able to see the schema structure. If you see guys, I got the three columns which is present in my file: the type, the null label one, the expressions, the file name. Okay, how it is getting is because I had already placed a file sample.json inside my S3 bucket, and it had successfully retrieve the data from this sample.json file only. Cool. And next thing, I will create a template as we had just seen in our PPT: create or replace table, table name, then using template. Then I will pass infer schema parameters using array aggregator and object construct, and I will run these two. I will run this one. And now it had created that template. Okay, till that time it had not loaded any kind of data. Let me show you. If I do select star from row data, I will only be able to see the DDL, and I will not be able to see any kind of data. See guys, the table is empty because the whole process of creating table using template only creates a template, which is my DDL. So once my DDL is created, I need to run the copy into command, and then only I can able to see the data. So let me run my copy into command. And see guys, it had loaded the data and it had loaded the two records. Let's see now our table. And see guys, I am able to see both the records. In my file, I am only having two records, so I am able to see both the records. It's the very time, okay, to load one more file. But before that, I want to show you schema evolution now. In order to do schema evolution, we need to say schema evolution is equal to true. I will hit run, and now I had set my schema evolution as true. Let me go and show you the file. This is my sample JSON file which we had loaded for schema detection. Inside that we was having three columns: ID, name and role. And this is the new file which I am going to load for showing you schema evolution. Now I had added new column which is location. In sample JSON 1, let me copy paste in that one first. See guys, let me show you now. In sample JSON, which we had loaded for schema detection, we was having three columns, but now for schema evolution, I had added one more column with the location Ahmedabad. Let's try to run this out. I will go back to my S3 bucket and I will click on upload. I will add file and I will just upload my sample JSON underscore one file, and I will say upload this file. Cool. My file is successfully uploaded. It's the very time that we should also understand schema evolution. The first thing we need to do in order to have a schema evolution is we need to alter the table and set the schema evolution as true. Once this is done, we need to copy into table, okay, using the same copy into command, and I had mentioned my file as sample json1.json. So if I run this one, I should be able to see one record loaded successfully into my raw data, and now total we will be having three records. If I just run raw data, I should be seeing three records. First are from sample JSON file and second is from my sample JSON1 file, and now I am also seeing my location column. This is how you can handle schema drifting inside the Snowflake. You can use schema detection to detect the file schema automatically and create the DDL. If your file columns are changing over the time, use schema evolution to detect the schema drifting and load the data accordingly. This is pretty much about schema detection and schema evolution. Let's now understand data source changes. In Snowflake, managing data source changes typically involves CTC, schema evolution, and time travel. These features allow you to track, automate, and recover from modifications in your data sources. First is tracking CDC. Snowflake provides native objects to track row-level changes, either inserts, updates, deletes in tables, and views using streams. A stream object records DML changes made to a source table. It provides a change table showing what changed between 2 points in time, what can then be consumed by task or Snowflake. This we had already seen our streams and task tutorial. If you had not watched that, please do watch that before jumping into data source changes. Next one is changes clause. This SQL clause allows you to query change tracking metadata for a specified time travel without needing an explicit stream object. And third is dynamic tables. These tables automatically refresh based on the defined query. They simplify CDC by managing the refresh schedule and incrementally updating data as source objects keep on changes. Next one is handling schema changes. When the structure of your data source change, example, new columns are added, Snowflake can adapt automatically. All you need to do is you need to just enable the schema evolution. Tables can be configured to automatically add new columns or drop not null constraints when new data files containing additional fields are loaded via Snowpipe or copy into command. And for semi-structured data, the variant data type allows you to store and query JSON, ARA-C data without predefined schemas, making it resilient to frequent source structure changes. Third one is recovering from changes. If a change needs to be reverted or historical data needs to be audited, Snowflake uses time travel, and this is also we had covered how you can restore your data at a specific timestamp using time travel. And second is fail safe. This is a non-configurable 7-day period where you request Snowflake support to retrieve your data, and they charge you based on the data size. Fourth one is database change management. For managing DDL changes like table creation or alterations across the environments, DCM projects come into picture. It is a native Snowflake object used to deploy and manage database objects defined in SQL or YAML files, often integrated with Git for version control. Second is schema change, a popular open source tool for automating Snowflake migrations and managing database schema changes in the DevOps pipeline. Let's now discuss about data unloading. As we already know how data loading works, data unloading also works in a very similar way. Data unloading in Snowflake is the process of exporting data from database tables into flat files such as CSVs, JSON or Parquet, and store them in an external or internal stage based on your requirement. Let's see this in action. I will go back to my Snowflake instance, and here first thing I am going to create a stage. Okay, I had already written all the scripts. So the stage which I am going to create is inside my bucket. I had created a new folder, unloads. Okay, and this is where I will be loading my CSV file, and then I will copy into, and I will mention my target file name, and then I will mention my table from where I need to create this file. Then I need to mention the file formats and override property if it is true or you need to create multiple files. And once you hit the copy into command, you will able to see that there are 3 rows unloaded and the total bytes loaded are 75. So if I go into my S3 bucket and if I refresh my instance, I am able to see the unloads folder, and if I go inside, I can see final test folder, and there I can see my user report.csv. Let me download that. Perfect. So now if I open this one, I can clearly see that I am having the 3 records from my table. This is how data unloading works. Now, next topic is change data capture. Change data capture refers to the process of tracking all the changes in data sources such as databases and data warehouses so they can be captured in the destination systems. Before CDC, we used bulk loading. This means every night, let's say at 2 a.m. or based on the schedule, the system would grab everything from the source database, millions of rows, and dump it into your data warehouse. The problem is it is very slow, it's heavy, and if you have billions of rows but only hundreds changed, you are wasting 99% of energy moving data you already have in your target data warehouse. Here comes the CDC to help. It's like a security camera that only records when something moves. Instead of scanning the whole table, CDC watches the database logs. Every time a row is either inserted or updated or deleted, the database makes a tiny note in its logbook. This is the logbook. It will make the note here that what's happened in our source, and then CDC will read this notebook in real time and say, hey, this customer just changed his address. Okay, so it will send only the update to the data warehouse instead of sending all the data right now. Okay, usually CDC detects changes in data using three methods. Those are timestamp based, trigger based, and log based. Let's talk about all these three one by one. First is timestamp based. It captures the most recent changes by using columns such as last modified or last updated. Any downstream applications or systems can query these kind of audit fields and get the record that have been updated since the last execution time. Let's see this with an example. This is my source table and it is newly created with two records, and now I have defined my target table which is empty, and as this source data will be flowing first time into my target table, I had stored my timestamp as 1900, which is way back than my last modified time here. So what will happen when I will go with the timestamp based CDC, it for the first time, it will see that the stored date is always less than these dates. These dates are eligible for processing into our target table. So it will process these two records into my target data warehouse successfully. Okay. The second scenario is now next day in the source table, the new record came. Okay. And now what will happen? On the second day, it won't start from this 1900 to look into last modified and process it. It will store the latest date from the previous run, which is this one. So it stores that date, and this time it will trigger from this date onwards. So second run or next time run, it will trigger from this dates onward, which eventually will only populate single record in my data warehouse instead of populating all the three records. There are pros and cons for every process, and same for time based as well. We have couple of pros and cons for this approach. The first pro is it is simple to use and implement, as we are just storing the date and based on that date we are extracting the data, and it provides a straightforward way to track changes over time, as you had just seen this, right? The biggest con is it can only process soft delete, not the delete operation. Suppose you had deleted something here completely, okay, it won't be tracking that, right? There is no way that it will track, because you are only storing the date, you are not storing the complete record. Okay, it adds the computational overhead to the source system, because the target system have to scan each row in the table to identify the last updated value. Okay, and it requires changes to the existing database schema sometimes. Next one is trigger based. The most database uses trigger functions. These are store procedures that are automatically executed once a specific event such as insert, update, or delete a record occurs on your table. One trigger for each operation per table is needed to capture any kind of data changes. These changes are stored in a separate table, commonly referred as a shadow table, as you can see here. So this is the shadow table where we are only tracking the changes. Additionally, developer can include messaging systems so that these data changes can be published to the queues where relevant targets subscribe to them. If you see this diagram, in my source system, these three operations happened. For customer 101, the new record came, so the operation in my shadow table go on insert, and I deleted the customer 127 from my actual source table. Due to that, it is showing that 127 got deleted, and I updated the address for customer 142 in my source table, and it is showing that customer 142 is updated. So this is my shadow table. Now I will use the shadow table to populate data into my final target table. Okay, so I will see the operation is deleted, I will delete the record. I will see the new record is inserted, I will insert it, and if there is any update like email or phone number, I will update it. This is how the trigger based CDC works. Okay, obviously here also we have couple of pros and cons, and the pros here is that we can detect and capture all the type of changes to the records, and the triggers are widely used and are supported by majority of the databases, and it enables real-time data capture without pulling anything out. Okay, And the cons are it negatively impacts your source database performance since updating records require multiple writes into your shadow table. It requires changes to be to the source database schema, and it can become complex to manage with a large number of triggers, right? Suppose you are having tons of trigger, it will be complex for your system to manage all these triggers, right? Third one is log based. Transactional databases log all the changes like inserts, updates, and deletes committed against the database and their corresponding timestamps into files called transaction logs. This is the difference, okay? Here we are maintaining the transactional logs to store all these information instead of storing in a table earlier in the trigger based, which we did. Now we are storing the changes in the transactional logs, okay? And these logs are primarily used for backup and disaster recovery purposes, but they can also be, used to propagate changes to target systems. Data changes are captured here in near real time. Since target system can read from transaction logs, this method does not impose any computational overhead on your source database. That's the biggest pro for this log based CDC. So you are changing something in your source, and that change is flowing into your transactional log, and using the log miner you are detecting the latest logs and populating and updating your target database respectively. It reduces the overhead on your source database, and all these things are tracked in your transactional logs. If I talk about the pros and cons here, the biggest pros are it does not add computational overhead. Second is it can detect and capture all type of changes to the records. And third is there is no need to change the schema of the source databases. And if I talk about cons, there is not standardization around the format of transactional logs. This means that each vendor opts to implement their own method, which could change in future releases. Okay. And second con is target systems have to identify and eliminate any changes that were written to the source database but then rolled back. So if you are rolling back something, it become a con in the log based CTC. Cool. Let's now discuss about copy into command. Copy into command is the workhorse of Snowflake data ingestion. It's a bulk loading tool designed to move data from files either located in internal or external stages into your Snowflake tables efficiently. You had already seen the copy into command when we was just doing internal stage load and external stage load. This is very helpful when we have to do bulk loading. Without this command, we can do bulk loading. It's highly performant because it's leveraged Snowflake horizontal scaling. It splits files and process them in parallel across your virtual warehouses. Cool. This is the generic syntax for copy into command, and there are multiple copy into command options which we can use as per our requirement, like validation mode, return failed only, own error, force, size limit, truncate columns or enforce length, purge, load uncertain column. So these are pretty much copy into command options which are highly usable and you can use based on your requirement. Let's discuss about these copy into options one by one. First is validation mode. This is the syntax for validation mode. Inside this syntax, you can see that you have mentioned validation mode is equal to return n rows, return errors, or return all rows. You can mention any one of them. So it validates the data instead of loading them into tables. So return errors gives all the errors in the file, and return all errors give all the errors from the previous loaded files if you have used on error is equal to continue. Okay. And return n rows displays first n rows and fails at the first error record. Similarly, next is return failed only, and the syntax here is return failed only is equal to true or false. It specifies whether to return only files that have failed to load in the same result. Default one is false, but obviously you can change the property as per your requirement. Third one is own error. Same way, own error, we are having options like continue, skip file number, percentage, or even abort the statement. So if you continue, it skips the error and load the remaining data. If you mention skip file, it skips the file that contains the error. If you say skip file num, and it skips the file when the number of error rows found in the file is equal to or exceed the specified number. Okay. And if we say in percentage, it skips the file when it exceeds the specific percentage. Default one is abort statement, and it aborts the load if any error is found at all in the data file. Fourth is force and size limit. Force and size limit is also pretty much same. Force is used to load all the files regardless whether they are loaded or not. Okay, the default is false obviously, and if you don't specify this property, copy into command won't fail, but it skips loading the file. Okay, and similarly size limit, it specifies the maximum size in byte data loaded in that command, how much the data you want to load at max, and when the threshold is exceeded, the copy into command stops the loading immediately. In case of multiple files of the same pattern, also it will stop the process after the size limit is reached. Okay, and all the files are partially loaded. So this is kind of, I feel it's a destructive one, but again, there might be a use case for you when you require that. So please use this very carefully. Next one is truncate columns or enforce length. This is like when a string is way too long than your mentioned data type length, then you can use truncate column as a true. Default is false, and it will truncate all the other columns. And let's suppose you have a description and you had mentioned the data type of description as 100, but the string which is coming now in the file is having a length of, let's say, 180. In that case, it will, in usual case, it will fail the process, but if you mention truncate column or enforce length is equal to true, it will load the first 100 characters, and then it will skip them. Okay, this is how truncate or enforce length works. Default one is false for both of them, but you can tweak as per your use case. Next one is purge. Purge specifies whether to remove the data from the stage automatically after the data is loaded or not. Default one for purge is also false. You manually need to archive your files from the stage. Last one is load as uncertain files. This specifies to load for which load status is unknown. The copy into commands skip these files by default. And please note that load status is unknown if all of the following conditions are true. Either the file last modified date is older than 64 days, or either the initial set of data was loaded into table more than 64 days earlier, and if the file was already loaded successfully in the table, this event occurred more than 64 days earlier. Okay, so basically load status is getting unknown when you are trying to load a file which is already loaded greater than 64 days back. Cool. This is pretty much about copy into command. Let's see error handling. In Snowflake, error handling is split into two worlds. First is data loading and second is script development. Okay, Snowflake is designed to be a fail-safe, okay, meaning it usually prefers to stop everything rather than let bad data through, but you can override this behavior as well. Okay, so error handling in data loading, this is the first type. And when bulk data is on, you can mention on error property to ensure that you are handling the errors accordingly. And second is handling error in SQL scripting. So if you are writing Snowflake scripting and or store procedure, you can use exception handling. This is the example for that. You can mention exception when other than return error. That's pretty much about lesson 3.1. Let's now begin with lesson 3.2, that is outline key tools in Snowflake's ecosystem and how they interact with Snowflake. We will be covering all kind of connectors, then we will be deep diving into drivers, and we will be doing hands-on specifically for ODBC drivers. Then we will be looking into API endpoints. Then we will look into SnowSQL. Then we will be looking into Snowpark as well. Let's first start with connectors. In Snowflake, connectors generally fall into two buckets. First is infrastructure and developers connectors, and second are native SaaS connectors. If we talk about infrastructure and developer connectors, these are the tools you use to build your own custom data pipelines. First is Python connector. It is the most flexible way to interact with Snowflake using code. It It allows for bulk loading, standard queries, and Snowpipe streaming. Next is Kafka connector. It is used for real-time data. It sits on Kafka cluster and pushes messages directly into Snowflake tables. This is perfect for high-velocity logs or transaction streams. Third is Spark connector. It is essential for big data environments if you are doing massive processing in Databricks or Apache Spark. This connectors allows Snowflake to act as either a source or a destination, taking advantage of Spark's parallel processing. Next is native SaaS connectors. These are managed connectors. Snowflake does the hard work of API integration for you, so you don't have to write custom Python scripts. First is Snowflake connector for ServiceNow. It automatically pulls records, incidents, requests, users from your ServiceNow account into Snowflake. This is huge for IT service management analytics. Next is Snowflake connector for Google Analytics. Since Google moved to GA4, raw data export can be complex. This connector simplifies the process, landing your marketing data directly into Snowflake for ROI analysis. If we talk about use cases now, if you are working on custom app or automation, Snowflake recommends using Python connector. If you are working on real-time event streams, Snowflake recommends you using Kafka connector. If your use case include marketing attribution, Snowflake recommends you to use Google Analytics connector. And similarly for IT and help desk analytics, Snowflake recommends ServiceNow connectors. And for massive data transformations, Snowflake recommends Spark connector because it is having the capability of MPP, which is massive data processing. Next up is driver, and let's discuss about JDBC. This is a standard for anything running on Java virtual machine. Enterprise applications, BI tools like Tableau or Metabase, and big data tools like Apache Spark or Talent use these kind of connectivity. If we talk about key feature, it is platform independent. As long as the system has Java installed, the JDBC driver will work. Next is ODBC connector. ODBC stands for Open Database Connectivity. This is the old school but incredibly powerful driver used primarily by Windows-based application and C++, C# environments. Microsoft Excel, Ultrax, and legacy enterprise softwares use ODBC connectivity. It requires installation on the actual operating system. You configure it using your ODBC data source administrator on your computer. Let's see this in action. I will first go to my drivers library page of Snowflake. So this is the URL for that, snowflake.com in developers, downloads, drivers, and libraries. Here I have a lot of clients. Okay, I will go down and I will select my ODBC driver. I will say download from Snowflake, and here my system is Windows, so I will click ODBC for window and it will immediately start downloading it. I will just select my folder where I need to download, and then I will hit download option. And it started downloading. It's just 55 MB of file. Now I will go to this folder and I will install it. In order to install, this interface will come, then you click on next, then install, and it will ask you for the permissions. You can just give the permissions and it will start the installation for you. Here guys, installation is also finished. I will click on finish. Now inside my search option, I will select ODBC. And it will automatically display here ODBC data sources. I will click on open, and here I will move to user DNS, and then I will click on add. And once you click on here add option, you will be able to see a Snowflake connector. As of now, I am not able to see. Why? Because I had already established the connection using the Snowflake DSII driver. So it is nothing guys. When you click on this, when you add and click on that specific one, let me show you this one at least. So it will ask you for the other things like data source, passwords, and the schema name and all those things. Okay. And then you need to select everything which is required, and then you just click on OK. Okay. And once this is done, I will open the Excel. And then I will go to my data tab, and inside that there is an option called get data. I will click here and I will go to from other sources, and here I will select from ODBC. And then it is asking me that which data source name you want to establish a connection. I want to establish a connection on top of Snowflake Collaborative Demo. I will click OK, and I will wait for a few minutes. And see guys, it had shown me my ODBC connection, and I am able to see all my databases, schemas, and objects inside my Snowflake from my Excel now. I will select one of the table to show you that it is actually working. I will go to my public and I will, let's say, select sales data. Okay. And then I will click on load. Okay. And it will start getting the data from my Snowflake instance, and it will try to pull all the data inside my Excel. So it's doing his work. So it might take 20-30 seconds or so. And see guys, it had successfully retrieved the data from my Snowflake instance. This is how you can work with ODBC. It is very helpful when you are working with the tools like Alteryx, or you have something requirement on Excel to fetch the data and within the Excel. Let's now discuss about API endpoints. The first is system $allow list. When you work in a high security corporate environment, companies don't just let any internet traffic go through. They use firewalls to block inbound or outbound traffic as per the policies. And system $allow list is a built-in Snowflake function that gives you a list of every specific URL and IP address your local network needs to trust, so that Snowflake can work perfectly. The script for that is select system $allow list, and it returns a JSON block containing the host name for your Snowflake account, your stage name, and the OCSP security certificate servers. Next up is SQL API. The SQL API is a RESTful interface. You send a standard HTTP post request with your SQL query, and Snowflake sends back the data as JSON format. Let's now discuss about SnowSQL. SnowSQL is a Snowflake next-gen command line client, enabling users to execute SQL queries, perform DDLs, DMLs operations, and manage data ingestion directly from their terminal. It acts as an interactive shell or in bash mode, supporting standard SQL scripting, file loading and unloading. Let's see that in action. I am back into my snowflake.com, and here I can see the option called SnowSQL download. So I will download SnowSQL for my Windows machine. Just click on download here, and it's just 56 MB, so it will be quick. It had downloaded. Now I will go and install the SnowSQL into my system. I will just click on next, and I will provide all the required permissions, and I will say finish. And before clicking on finish, they are saying that how I can check and create the connection with SnowSQL. They are saying open a new window terminal, execute this command, and then add your connection details and execute the command SnowSQL, and you should be able to establish the connection with the SnowSQL and your local system. Okay, I will click on finish, and I will click on my command prompt, and first thing I will say SnowSQL -v, and I will verify my terminal, and I can see the version 1.4.5. This means SnowSQL had been successfully installed on my desktop. Now I will pass all my details like my account identifier and my user. So I will say SnowSQL -a. -a indicates account identifier, and then -u indicates the user, and I will hit enter. And it will ask me for the password. I will pass my password here, and I will hit enter. And see guys, I am able to log in into my Snowflake instance. I can see my compute warehouse. I can see my username. And as of now, I hadn't selected any database and schema. I can select that as well as per my requirement. Now I will create a database and create a table, and I will hit run. And it had successfully created a database as well as a table inside my Snowflake. Now I had mentioned my put command. Okay, and I had earlier I forget to mention that in single quotes because the name was having a space. As I had put the put command and I tried to create a user stage, I am able to load the data inside my Snowflake. Now I will list my user table, and I am able to see the size is 144 and last modified date and MD5 of my user table. And once I had list this, now I can even load the data inside my Snowflake using SnowSQL. This is how SnowSQL works, guys. Let's talk about Snowflake CLI. To be in very, very easy language, think of Snowflake CLI as a direct text-based hotline to your Snowflake data cloud. Okay, so Snowflake CLI is an open source nature means that developer can leverage communities' collective knowledge and contributions to improve and enhance the tool. All right. So, in very general words, instead of clicking through the web interface like Snowflake, Snowsite UI to move files or to manage tasks, you type specific commands into your terminal, okay, or command prompt. It's designed to be fast, scriptable and efficient for developers and data engineers. Okay, so this is a very in general Snowflake CLI. So it is something which can make your stuff fast instead of just going into the web interface, clicking on multiple things. So you have all your script ready, you just place your script and you can reuse that script multiple times. So actually it is very much fast and it leverage the Snowflake in a very efficient way. As a command line interface, okay, Snowflake CLI provides several benefits for developers, okay, such as speed and efficiency. CLI allows developers, to perform tasks quickly and efficiently by executing commands from the terminal without needing a graphical user interface. Okay, this can save developers significant time and efforts, especially when performing repetitive or complex tasks. All right. So, second major benefit of CLI is automation. Okay. So, a CLI can automate tasks and workflows such as building, testing, CI/CD, and deploying applications. CLI can help developers streamline their development process and reduce the risk of errors or inconsistencies. All right. Third benefit is portability. A CLI is often platform independent and can be used across different operating system and environments. Okay, you don't need to worry. You can use on any operating system in any environment. Developers can work more easily on multiple projects or collaborate with others who use different systems. So this is the third benefit. Okay. Fourth one is customization. Okay, a CLI can be customized and extended by using modules and scripts so developers can tailor it to their needs and preferences. Automating common tasks and workflows can help developers actually work more efficiently and effectively. So, next is accessibility. CLI can be accessed remotely. So developers can work on servers and other remote systems without a GUI. And the sixth benefit is version controlling. A CLI can be integrated with any VCS like Git, okay, to manage changes and track code history, which can help developers collaborate more effectively, resolve conflicts, and document changes appropriately. So now let's install and configure Snowflake CLI. Let's begin by downloading binary installers from Snowflake official documentation. On your browser, search install Snowflake CLI. Okay, and go to that URL. And here I will go to CLI repo. And my system is Windows system, so I will click on Windows and I will install anyone. Uh, yeah, this one I will install it. I will open that, click on next, install. Yo. So installation is finished. I will click on the finish button and I will go to my command prompt. And here, as I had installed it into my, other folder. So I will go to that folder uh, and I will go one more step, CD program. Okay. So now I will do CD Snowflake CLI and I am into the folder now. So now I am going to type snow connection list. Let's see. It's unpacking the distribution. As you can see, there is no data it's showing. Basically, it means that there is no connection list. So now I'm going to create a Snowflake connection, okay, by using Snowflake connection, Snowflake connection add. Is it Snow connection add? Yeah. So it's asking for the connection name. Connection name is my username. In my case, it's my name. Account, enter account. So what is account? Okay, so let me help you with that. If you need to go to your account manager, okay, and here if you see this is the locator number, right? If you remember, in the previous video I had told you. So account is nothing, it's just the concatenation of your locator number plus your account ID. So this is your account ID. In my case, it's this one, V511 whatever. So I'm pasting it with the concatenation. Into concatenation here is hyphen. So I had entered my account. I will click OK. So now it's saying what is the user. User is same as my connection. Okay. So now it might be asking for password. So I will be entering my password here. Yes. So it's asking for which role you want to create. So I am okay as of now with account admin. I don't have any other role. It's new account I just created. So I will just hit enter. So with warehouse, if you remember, as of now, I am only having very few, I guess, two warehouses. Let's see that. Two or three. Yeah, two warehouses I am having. One is Snowflake Learning and second is Compute Warehouse. I am going to use Compute Warehouse. Okay. And I'm going to click on enter. It's asking for database. I don't feel I need anything. So I'm just clicking enter. So you can also skip some of the options. Like if you see these options, you can obviously, if you have information, you can, but if you don't, you can obviously skip them. So once everything is done, it will create a file, which is a toml file in which it is having all the configuration, all the passwords. You can see your toml file. I can't show you my toml file because I have my passwords there and it is visible from there. So you can obviously go to the directory which is showing in your system. Like in my case, it is showing this system, and you can open the toml file and see all the configurations which you had just done, and it successfully created a new connection for me. So now I'm going to test the connection. Okay. So now in order to test the connection, I guess it should be snow connection test minus connection name testing. Let's see. Perfect, perfect. So as you can see, the status is okay. Okay, this means the connection is successful, and you can see all the details like my connection name, my host name, my account name, my username, role, database, compute. You can see all the details here. So this is how you can connect with your Snowflake CLI. Let's now discuss about Snowpark. Snowpark is a developer framework that allows you to write code in Python, Scala, or Java using the data frame API. Snowflake then converts that code into highly optimized SQL and runs it directly on its own elastic compute. If we talk about Python, Scala, and Java features, the primary use of Python is in AI, ML, and data science, where the primary use for Scala is for large scale data pipelines, and the primary use for Java is for enterprise custom apps. Python supports massive list of libraries, where Scala supports Spark compatible libraries and Java supports all the standard Java jar libraries. If we talk about ease of use, Python is very easy to use because it's kind of natural language, and Scala is kind of moderate to use. Java is always complex and or verbose to use. If we talk about speed, Python follows push down logic. That's why it is having more speed. But Scala is something which is compiled language. It is the fastest among three, and Java is also very fast. Let's now begin with lesson 3.3 to determine the appropriate data transformation solutions to meet the business needs. Here we will be covering about data transformation techniques, querying semi-structured data and flatten the data, data processing and its techniques. We will also learn about the functions that are external functions, and we will also understand the secure functions as well. Let's begin with data transformation techniques. Let's discuss about data transformation techniques using structured, semi-structured and unstructured data. So structured data, that's a traditional SQL. Okay, here I don't have any much to discuss. So these are just transformations here usually involve standard SQL and DML operations. So I won't stress on this structured data part. This is a really BAU. And second is semi-structured data. For semi-structured data, Snowflake uses a special data type called variant data type to store the semi-structured data. You don't need to define a schema before loading it. Okay, you just need to create a table with a single column called variant, and you are good to load the semi-structured data into the same table itself. Okay, the transformation techniques is dot notation. It access nested fields directly, and second is flatten, a table function used to explode arrays into individual rows. We will see this in action in couple of more minutes. Let's discuss about unstructured data, then we will move to Snowflake to see this in action. When we talk about unstructured data, Snowflake doesn't store the content of unstructured data in a table cell. Okay, instead it stores the metadata about the file and provides a directory table to manage them. Okay, it doesn't store the unstructured data directly. The transformation techniques here is you can use scoped URLs. It generates the temporary secure links to files for processing by external tools or by Snowflake Snowpark. Second is you can use Snowpark to read these stuff and build a stuff on top by using the Python libraries directly inside the Snowflake. Third is you can create a user defined functions and you can write a Python UDF to extract text from blob or even return it as a structured string. Let's see semi-structured data and unstructured data in action. For that, I had logged into my Snow site. We will discuss one by one of couple of semi-structured data formats like JSON, XML and Parquet. Then we will also move to unstructured data like PDF, and we'll try to process all these kind of data within our Snowflake one by one. So I will pick and start first with my JSON format. So I will just give a heading JSON. So in order to work with JSON or even any kind of semi-structured data, I need to create the file format first. This is the mandatory requirement. So I had written the file format script, create or replace file format type JSON and strip outer array is equal to true. I will run this. So once I had created the file format for the JSON, now I will create the stage where I will load the data. Create or replace stage. Then I will mention the stage name, let's say my JSON stage. I will hit run. Cool. I had created the stage now. Now what I am going to do, I am going to add the files inside my stage. I had downloaded a dummy JSON file for this tutorial. So I will go to this stage and load that file. In order to load that file, I will go here. I will say add data, click on add data, and I will say load file into stage. Then I will select my database where I had created the stage, and then I will get the schema, and then I will also select my stage name. As I am working with JSON, so I had created the my JSON stage which I had selected. Now I will click on the browse button. This is my JSON file. So I had click on upload and I had uploaded it. Now I will click on this upload button and that's it. If you see guys, my file is successfully uploaded in the stage. So now let's see the file. In order to see the file, I will go back to my notebook and I will say list my file. I want to see my file. List at the rate my stage name. This will show me my file. See here guys, flowers.json file is now in my staging area. Now what I will do, I will create a row table. I had created a row table with only one column called JSON content, and data type is variant data type. Whenever you are going to load the stage data from JSON format or even Parquet format or even ORC or even any other format, you need to create a variant data type for semi-structured data. Now let me hit run. Cool. I had created my table as well. Now I am going to copy the data into this newly created table from my stage. For that, you already know I need to write copy into command. So I'm going to write that command copy into raw JSON data. And then from my list, I will copy paste this one. I will run this and I will copy paste this one. From at the rate is very important. My JSON, and then I will mention the file format which I had created up. File format is equal to format name is equal to my JSON format, and I will hit run. It's running cool. Data is loaded. Rows passed are 150. Rows loaded are 150. So there is no data loss happened. All the data from the stage is loaded into my row table. Now let's see this data first. Let me run a select query. Select star from raw JSON data. Oops. Raw JSON data. Hit run. See guys, this is how JSON gets loaded into Snowflake initially. Okay, now we need to clean this data and load this data into my actual table, which I will say flowers table. So first I will create the DDL for the flowers table. I had created the DDL for the flowers table. Now I will just hit run this DDL and my table is created. Once my table is created, now I am going to insert the data into this table. This is how I will clean the data from my raw table, and I will first write the column name which I am having in my row table. My row table column was JSON content. I will copy this column and I will say JSON content, then colon. Then I will copy the first name. If I just run this one, the first name is petal.length. Okay, I will copy this one, petal.length. Okay, let me copy this and I will paste it here, petal.length, and then I will mention its data type. What is the data type here? I had mentioned here as float, so I will mention here as well as float, so it converts the data type. Okay, this is for one. Similar way I will do for sepal length, sepal width, petal width, and variety. Let me quickly do that. So I had written the script which will clean the row table and which will load the data into my insert. So I will just mention the table name now from raw JSON data, and now I will hit run. Cool. Number of rows inserted is 150. It means data is loaded in the structure format now in my table. Now my data is cleaned. I will just say select star from flowers and I will hit run. See guys, magic. Cool. This this is how you can work with semi-structured data and load that data into your table after cleaning it. Make sense? Please note that how you can clean this. This is the way. You need to mention the column name, then colon, then the column name from the file followed by the data type. This is how we will clean the data before loading into the final table. So this is pretty much about the JSON format. Let's discuss about XML. For that, I won't be deleting this one. I will be using this one only. I will just create another file format here. I will say my XML. Okay, and here I will mention the type as XML. Oops, XML. And I don't need strip outer array. Strip outer array is only specific for JSON. I will hit run and I will create the XML. Similarly, I need to create the stage. So I will mention my XML stage, hit run. Perfect. Now I had created the stage and now I need to load the file, upload the file in this stage. Again, for that, I will go to my add data option. I will go to loads file into stage. I will select my database, select my schema. Then I will go here and I will select my XML stage. This time we are going to load XML data. I will click on this option and I will check on the books.xml file and I will click on upload. Done, guys. It had uploaded the file into my stage. Now let's list the file and see whether the file is showing in the XML stage or not. Perfect, perfect. I am able to see my file. Here also I will just change JSON to XML, and here also I will say raw XML data. See guys how quickly I am doing it this time. I had already created the JSON. I am reutilizing the same JSON scripts to make it work for XML. Okay, this is all the formats follow the same process, even XML, Parquet, JSON, ORC, Avro. Okay, so you need to understand the basic fundamental behind this. Once you know that what steps you need to do for a single one, you can do it for everything. Now let's change it from raw JSON to raw XML. Raw XML, and then obviously I will mention my this location inside that. Copy paste this JS and mention it here. Cool. Now here also I will just say my XML format. Perfect. Perfect. It's running. See guys, row parsed 1, row loaded 1. Everything is loaded into my XML data. Let's run it. XML. Let's see. Cool. Cool guys. See here guys. All my XML data in one table. I had loaded the semi-structured data into my row table. It's time to create the DDL like we had done for JSON. Let me create the DDL for that quickly. This is the DDL for the books. I will just hit run. And cool, I had created the DDL. Now again, we need to write the insert scripts. I will quickly write insert into books. And then notice here how I will process the XML, guys. For in order to process XML, you need to use two functions. Okay. First, obviously, you will say select. Then first you need to get the first attribute of the XML. For that, we will always use get function first, and then followed by we also use XML get functions. Okay, we will fill this, but first from where we need to pull the data? We need to pull the data from raw books XML table. Correct. Now another other thing we do here is we apply comma. Okay, first we had done the inserts, then we say select the data, we will get the data, we will get the XML data using XML get function from the table where we had loaded the data. Now we need to flatten this data. Okay, for that we will use the function called lateral flatten. This ensures that all the data get flattened out into the respective rows. Okay, here I will mention input. What is the input? XML content. And whenever there is the input for XML content, it is always denoted by dollar symbol. And if I name it, let's say F. Okay, now I will fill these one. First is get. In order to get what I need value, F dot value. I will fill F dot value. And the first column in my XML is ID, right? First column is my ID. So I will mention get ID, F dot value, and then I will say at the rate ID. That's it. Now I will mention the data type as usual. I will say double colon and I will say it's a string data type. And I will, let's say, name it as a book ID. Now let's fill this one also. This one also is similar. There's a little difference, like here f dot value will be the same, but the XML get function will get the value inside this complete set of data. For parent attribute, we always need to require use at the rate. Okay. In this case, for ID, we did that. But for child attributes, we don't need to apply at the rate. At the rate is only for the parent attribute. For all other attributes, we can just mention the name. Okay, what's our other name? Author, title, gene, listed, description, right? Let's mention them one by one. I will say first is author, and then I will say dollar. This is how we clean and transform the data for in when it's XML. This is what I had done for author. Same way I will copy paste for others, and I will say here title, then I will mention here title, and same way I will mention others. Now I had created the insert scripts. I will just hit run, and cool, it had loaded all the 12 records inside my books table. Now I will just query books. See guys, here is all the data in the structure formats. So this is how we clean the semi-structured data and load it into the table in the structure form for XML. Now let's see one more for Parquet. For that also I will change here only. I will say Parquet, and here type is Parquet. Parquet is the columnar form storage. This is very interesting one. Let's run this. Cool. Now I will create the stage as well. Parquet, hit run, ran. Now what I will do? I will again load the file in this stage. For that I will go here. I will do add data. I will go into load into tables. I will select my database as well as my schema. Then I will select the stage. Now my stage is my Parquet stage. Then I will browse and load the my Parquet file and upload, and my Parquet file is staged into my Parquet stage. Now let's go back. Perfect. Now let's list my Parquet stage, and I will list this, and boom, here is my empty cars.parquet file. And now I will create again the table. I will just say Parquet, and I will say Parquet content. It's easy, right? Once you are done with one, you will file very easy for others as well, right? So I will hit run. Now I will copy paste. So I will say raw Parquet data, and I will mention the list from here. I will copy this, copy, and I will paste here, and then I will mention my Parquet format. Copying data and copied. I had copied my data into my staging area. Now I will again trigger a select to just visualize my data. And this is how my semi-structured data is looking now. Now I will again create a DDL. This is the DDL for empty cars. I will hit run, and I had created the DDL. Now I am going to insert into empty cars. And now what's the functions, Jaswinder, we use in case of Parquet? In Parquet, it's straightforward one, like JSON one as well. It's straightforward. We will just use the column name from raw table, then column name from the file data. Then I will say the data type, let's say string, and I will fill this up. So I had written my insert script now. I will just run this, and it is again, I told you, just you need the column name from the row. Then you need to have the column name from your file with the data type. And I similarly I had done for all the columns. Now I will just hit this. It has inserted 32 rows. Now let's query this. Cool guys, see, this semi-structured data is also loaded into my table, and now this data is converted into the structured data as well. Make sense? This is pretty much about semi-structured data. Now let's talk about unstructured data. Okay. So when it's come to loading unstructured data in Snowflake, it is different from loading structured data. Okay. You don't insert the file content into the cell. Okay. Instead, you stage the files. Okay. Then you use a directory table to create a searchable catalog of these files. Okay. Let's see that. First, we will create a stage with a directory table. Okay, create or replace stage, let's say my unstructured stage, and then I will create a stage with the directory table. So I will say directory equals enable is equal to true. So this will create a stage with the directory table, and directory table is the brain for unstructured data. Note that guys, this is the brain for that. Without that directory table, we cannot process the unstructured data. It stores all the metadata, even like file size or MD5 hash, last modified date, and about every file in the stage. Cool. So I will hit run. And perfect, I had created my stage. And as usual, once we create the stage, we will go and upload the file. I will go here, I will load file, and here I will select my database and schema. Then I will select my stage, my unstructured stage. So in this unstructured stage, I am going to load a PDF. This is the invoice PDF which I am going to load as part of this unstructured data loading. So what I will do, I will go here, I will browse, and I will select the invoice. I will click on open, and my invoice 1 to 3 PDF is there, and I will click on upload. That's it guys. My file is again staged. Let's query the file metadata first. Now you can query the stage just like a table because you had used the directory tables. For that, I will say select, and then I will say relative path. These are all the functions which are there in directory tables. We had already discussed that guys. If you hadn't watched that video, please go do watch that video. Last modified date, let's take that as well. Then I will take file URL. Okay, and then I will say from my directory, and I will mention my staging area name at the rate this one, and I will hit enter. See guys, so what I am getting is I am getting the relative path, the size of the PDF file, last modified date, and the file URL which is there in the AWS location. Okay, now I will access the file using the scoped URLs. Okay, since you can't read a PDF in a SQL result grid, Snowflake provides us a function known as scoped URL. Okay, these are temporary secure links that allows users or applications to download or view the file. Okay, for that I will say select, and I will say relative path as I already had, and then I will say build scoped file URL. This is known as scoped URL guys. This is a function for scoped URL, and here I will mention my stage name. My stage name is my unstructured stage. Here I will mention that, and after that I will say the relative path. I need only those files which is in the relative path, and I will say this as, let's say, temporary link. Okay, and then From where I need obviously from the directory table, because without directory table we cannot process unstructured data. So I will run this. See guys, now what I am getting is I am getting the relative path, and I am getting a temporary link using build scope file URL. Make sense? Cool. Now I will process the content. Okay. If you want to extract the text from these PDF, okay, or analyze any kind of even images also, let's say, you can use Snowpark Python. Okay. And you can even write a function that takes the file URL and reads the bytes and return the text. Okay. So what I am going to do is, instead of using Snowpark, here only I am going to create a function which will takes my file URL, okay, and read the bytes, and it will return me the text. Okay, so I will quickly write the function and I will then walk you through that. So this is the function which I had created. Okay, this is a UDF. So I had named the UDF as extract PDF text, and I am passing the file path, and it will return me the string, and language is Python. The version I'm using is 3.9. And by the way, Snowflake uses minimum of 3.9 as a Python version. The packages I am including is Snowpark Python and PyPDF, because this is the package which will ensure that I am able to read the PDFs. Okay, so I will say from PDF PDF library import PDF reader, and this is a Snowflake files import Snowflake files. Then I will create a function, and which will take my file path, and I will use with open function. As you know that it is used to open the file and see the data inside the file. And once I am opening the file, I am storing the data in the text, and I am returning the text. This is a very quick, straightforward Python function. So now I will hit and run this Python function. Cool. My extract PDF function got created. Now you have two options here. If you just want to test it, you can use and just call this function like select extract PDF text, and you can call this function. Okay, and here you need to mention build scoped file URL, and then you can mention your staging path. Cool. And then you will need to mention your PDF name. This is just for if you just want to visualize and see any random one PDF. Okay, I will. This is a very normal one scenario, and I will just show you how it works. So it is running now. See guys, now you are able to see the PDF content, all these Gen Corporation telephone number and the date, invoice number, and all these details, right? Now let's load this into the table, right? That's the end goal for this unstructured data hands-on. For that, I will say create or replace table, and I will say, let's say processed invoices, and then I will say alias, and I will say select relative path, and I will say that file ID. Then I will say last modified. I will say as upload date. Then I will say I will use my UDF now. Extract PDF text, and then I will mention my this one build scope file URL, copy paste here. Now I don't want to see one PDF. There is a possibility I am having, let's say, 100 PDFs. So I can't just limit myself to one PDF. That was just for visualizing the PDF. I need all the PDFs. So I had mentioned the relative path, and this will ensure that all the PDFs will be getting read into the same table. And obviously everything is working from directory table. So I will write directory, and I will say at the rate my unstructured stage. Cool. And that's pretty much about it. Last modified extract PDF text and everything I had mentioned. And let's run this. Let's try to run this. Perfect. I had created the table. So now hopefully will we be able to see the data and select star from this and let's run this. And cool guys, see here. I have file ID, I have upload date, I have content. Suppose we are having 20 PDFs, then we will be having 20 entries with the file IDs and upload date and all the content in the third column. So this is the beauty of working with directory tables, and it is very helpful when we are dealing with unstructured data. Let's now discuss about external functions. External functions in Snowflake are user defined functions that invoke code stored and executed outside of the Snowflake environment. They allow you to extend data pipelines by calling third-party APIs, machine learning models, or custom logic in languages like Go, C# that are not natively supported as internal UDF handlers. If we talk about core components, first is external function object, a database object in Snowflake that stores the invocation URL and the API integration name. Next is remote service. This is the executable code residing outside of your Snowflake, either in your Lambda or in your Azure functions or in your Google Cloud functions. So these code exist outside of your Snowflake environment, and we will see this code in action in few minutes. Next is proxy service. This is an HTTPS relay that receives requests from Snowflake and forwards them to the remote services. Next is API integration. This is something which is inside the Snowflake. It is a Snowflake object that securely stores authentication and security details needed to connect to the proxy service which we are going to create in just few minutes. If we talk about limitations, the maximum response time batch is limited to 10 MB, and we cannot share the external functions via secure data sharing, and the external logic feature is only available for functions, not for any kind of stored procedures. They typically execute more slowly than internal UDF due to network latency and cloud infrastructure overload. Let's now go to Snowflake and see this in action. Let's now create an external function. For that, Snowflake had provided us this template where we can track all the steps like mentioning our account ID, Lambda function, role, ARN, gateway integration, and all those things. So I will also maintain this Word file so that I can keep track of all the required IDs, ARNs, and API names, so that it will be very handy when I create the external function to just copy paste from this Word file. I will attach this Word file inside my repo so that you can go and download from there as well. So first thing first, we need AWS account ID. For that, I will go to my AWS and I will click on my profile, and this is my account ID. I will just copy paste this account ID here, and next thing I need to create a Lambda function. For that, I will type Lambda inside my AWS, and then I will click on create function. I will select author from scratch, and let's say my function name is Snowflake Lambda, and I want to have a runtime, let's say Python 3.14. Yeah, that's pretty much. So I will just click on create function, and I will record this Snowflake Lambda inside my Word file. And here my Snowflake Lambda function is created. It's the time to write some code inside this. I have my code ready. So first thing, I will remove the default code for Lambda and I will paste my code here. And once I paste my code here, I will deploy this code. And it started deploying. It had successfully deployed the code. And now I will click on test code and I will create a new test event. And let's say I will name this as test event. And then inside my event JSON, I will copy paste my code and I will invoke this code. And see guys, I got the status as success. This means my code is working as expected. I will click on save, and now I will go to my IAM and create a role. I will click on roles. I will create a role and I will select AWS account and I will create a role on top of my current account. Then I will click on next. And as of now, I don't assign any policy. I will just click on next and I will mention the role name as, let's say, Snowflake role. And yeah, that's it. And I will click on create. And perfect, guys. I had successfully created my role as well. Now it's the time to create a proxy service on API gateway. So I will type API gateway and I will go to my API gateway. I will click on create an API and I will go to the REST API and click on build. And then I will click on new API. Then I will name the API as Snowflake AWS API. And then I will click on create API. After creating a API, I will click on create resource and I will name this as, let's say, a Snowflake proxy. And I will click on create resource. Then I will click on my Snowflake proxy and I will create a method. And here I will select post. And yeah, I will also click on this Lambda proxy integration. And then I will select my Lambda here and I will click on create a method. Now I will copy this one and I will go to my Word file and I will place this as resource invocation URL. And I also need to fill my API name and API gateway resource name. And my API name is Snowflake AWS API. I will just mention here. Oops. And my API gateway resource name is Snowflake proxy. Perfect. Now I will click on this post option and here I will click on edit option and I will say authorization as AWS IAM and then I will click on save. And I will copy paste this one and I will paste inside my method request ARN. Now I will go to my resource policy from this right panel and I will click on create policy and I have a template ready. I will just change it. I will add my 12-digit account number, which is this one. And then I will mention my resource. And I will click on save changes. And now my policy is saved. I will go to my API and I will deploy this API. I will say new stage and I will name a stage name as, let's say, test, and I will deploy this. Perfect. This is my invoke URL. Now it's the time to go back to Snowflake and create a new worksheet. And I will name this as external functions. And let's create a API integration. Here, I need to mention API AWS role ARN. I will go to my Word and I will see what's the value of that. This is the value. I will copy paste. And then I need to mention my API allowed prefixes. And this is the value for that. I will copy and mention it here. And then I will run this one. And perfect, guys. I had successfully created my API integration. I will describe this integration now. And here I will copy my API AWS IAM user ARN and store it in my Word file. Similarly, I need to copy my API AWS external ID. That also I will copy paste and store it in my Word file. Once that's done, it's the time to set up trust between IAM and the Snowflake. For that, I will go back to my IAM and I will click on roles, and then I will click on my role, and then I will go to trust relationships and I will edit the trust. And inside the condition, I will mention my string equals, and then inside my external ID, I will copy paste my external ID. I will go here and I will just copy paste this ID. And also inside my AWS, I need to mention this AWS user ARN. So I will again copy paste this one. And perfect. I will click on update. And I had successfully created a handshake between AWS and Snowflake. It's the time to create my external function. So I will say create or replace external function, my external name, then I will pass the variables and then I will return the variant, and then I need to mention my API integration, which is my API integration 01. So I will add it here, and then I need to mention my invocation URL. If I go here, this is my invocation URL. I will just copy paste and then I will hit run. I had successfully created my external function as well. And as we just hit run, we are able to see our row ID and our external function name. This is how external function works in Snowflake. That's it, guys. That's pretty much about external functions. Next up is secure functions. In Snowflake, secure UDFs and secure store procedures are specialized objects created using the secure keyword to protect sensitive business logics and data. The key characteristics of secure functions are it is helpful in defining masking. The underlying SQL or JavaScript code remains hidden from unauthorized users. Commands like show functions or get DDL will not display unlike the user owns the function. And it also helps in metadata protection such as handler name and package imports are also concealed. And it is very helpful in optimizer constraints to prevent the data leakage via query plan analysis. The Snowflake query optimizer bypasses certain performance optimization. This ensures filters are applied before any potentially leaky UDF user-defined logic executes. Last one is it supports execution isolation for functions written in Java, Python, or Scala. Making them secure ensures they run in a separate, isolated sandboxes to prevent data sharing. With that said, we had covered domain 3 as well. Hope you had really enjoyed it. I will see you in the next one. Well, we had finally reached the domain 4. Congratulations, everyone. We had literally covered domain 1, 2, and 3. This is the very time to touch base on the final domain of Snowflake Advanced Architect exam, that is domain 4.0 performance optimization. We will be covering everything here about query profiling, virtual warehouse configurations. We will understand what is auto suspend, what it auto resume, how the Snowpark optimization warehouses work, what are Gen 1, Gen 2 virtual warehouses, what is clustering, and then we also discuss about search optimization service, query isolation service, and then we will also discussing about the 3 type of caches. Then we will be moving to 4.2 lesson where we will be troubleshooting the performance issues within the existing architecture, where we will be understanding about warehouse monitoring, optimization techniques, micro partition pruning, and then finally we will be covering the monitoring and alerting part, where we will be discussing about account usage and information schema. We will also touch base on the difference between account usage and information schema. Then we will also understand the resource monitoring, alerts and notification, and finally we will discuss about logging and tracing using the event tables. Let's start with our first topic, that is query performance tuning. Snowflake provides 2 primary features for analyzing query performance and executions, that are query profile and query insight. We'll start first with the query profile. The query profile is a powerful diagnostic tool in Snowflake Web UI that offers a detailed breakdown of single query execution. Okay, it is used to understand how Snowflake process a query and to pinpoint the performance bottlenecks. It is really helpful to see all the complete diagnostic thing of your query. Let's go to the definition. Is a feature in Snowflake UI that gives you a detailed insight into the execution of query. Okay. It contains a visual representation of the query plan with all the nodes and links represented. Execution detail and statics are provided for each node as well as the overall query. This is how query profile looks in Snowflake interface. It is having a complete representation of the query execution plan, and it is having a couple of more options. It shows the profile preview. It also shows the statistics, and it also shows the most expensive nodes around. Okay, so it starts with a table scan. It scans the data, and here only it filters the data, and then it moves further based on the query complexity. When should I use query profile? The query profile, if I say, should be used whenever diagnostic information about a query is needed. Okay, a common example is to understand why a query is performing a certain way. Suppose you have a query, you want to see and reveal the stages of the query that make him either significant longer than other processes. Okay, similarly, you can use the query profile to even figure out why a query is still running and where it is getting stuck. So this is really very helpful and very important. Okay, another useful application of query profile, if I say, is to figure out why a query did not return the desired result by carefully studying the links between the nodes. Okay, like see here, links and nodes, you can potentially identify the parts of the query that are resulting in dropped rows or duplicates or maybe anything third, which may explain you why you are seeing the unexpected results in your output. This is another UI explanation of the query profile, but let's start with the execution time summary. Execution time summary shows what percentage of total query execution time was actually spent on different buckets. Okay, it is having 4 options, right? Processing, local disk, remote disk, initialization. What is processing? Processing is just the time spent on query processing operations like joins or aggregations or filters or let's say sorts, etc., etc. Okay, what is local disk then? Local disk is the time spent reading and writing data from or to local SSDs. Okay, this would include things like spilling to disk, okay, or even reading the cached data from your local SSDs. Okay, what is remote disk? Remote disk is the time spent reading and writing data from and to remote storage. Local disk is for local storage and it includes things like spilling to disk, and remote disk is for remote storage like S3 or blob storage, and this includes things like spilling to remote disk and even reading your data sets. Okay, makes sense. Fourth is initialization. This is just a overhead cost to start your query on warehouse. In our experience, it is always extremely small, okay, and relatively constant. Cool. Now let's talk about the second part, which is query statistics. Information like number of partitions scanned out of all the positive partitions you can find here, as you can see. Note that this is across all the tables in the query. Fewer partitions scanned means the query is pruning very well. In this case, if you see, the total partitions was 3242 and it only scanned 491, and this is a really good thing. It shows that query pruning is working very well. If your warehouse even doesn't have enough memory to process your query, okay, and it is actually spilling to disk, and that information will also be reflected here. Okay, as of now in this image you are not seeing it, but in next image I will show you that as well. Third is the number of records shared between each nodes. If you see, this information is very helpful to understand the volume of data being processed. Okay, if you see, initially the records is 227 million, but when the aggregation got completed, it only left to 12. Okay, so it shows each node and it shows all the volume after each node, and it is helpful in knowing how each node is reducing or expanding that number. Fourth one here is the percentage of total execution time of each node. If you see this query, if I talk about this query, in this query, table scan took 83% of my time. 0.3% of time was taken by filter. 16% of my time is taken by aggregator. Okay. It indicates the percent of total execution time spent on the operator. In this example, as I just told, 83% is this one, and then information followed by others, so on. On the top right of the query profile, we can see that there are other options called most expensive nodes, and it indicates that among my all these 5 nodes, which 2 nodes consume the most of my time. This is the another in detailed one. As I mentioned earlier, you can click on each node, okay, to reveal additional execution details, then statistics. On the left, you can see the result of the table scan operator. If I had clicked on table scan operator, I will be seeing this detail. And similar way, if I had clicked on aggregator, I will be seeing this detail. Okay, let's see where you can find this in Snow site as well. I am into my Snow site. Now I will go in monitoring, and I will click on query history, and this will show me my query history. And here I will, let's say, I will just open any random query. Okay, I will open this procedure, and I will go to query profile. See guys, this is how you can access the query profile in your Snowflake. Other way to access the query profile is you can go to worksheets, open any worksheet, and if you just do the select from any table, let's say company dot public dot books. So if I run this query, it ran, and where you can click on these 3 dots, and if you see here, you will get the option of view query profile. You click on this and a new tab will be open, and here you can see the query profile. Cool. Now let's talk about query insights. Query insights is nothing but a message that shares information about the query, okay, that is actually causing the performance issue. This not only actually provides information on how performance is impacted, but to be very fair, it also offers recommendations, okay, to fix or even improve your performance issues. Okay, let's go to definition. And query insight is a feature that builds on query profile by automatically detecting conditions that might affect performance and offering actionable recommendations. Cool. And query insights is a account usage view and can be used same way as the other usage views. This view has specific columns that share information about queries, warehouses, and 3 key columns, that is insight ID, messages, and suggestions. As we just discussed, that it also provides recommendations to fix or improve your query performance as well. Okay, so this is really helpful view, and you can use query ID to check if there are any insights available in the table and get the recommendations to improve your query performance as discussed. So this is the sample query. For that, you can go to snowflake.account usage.query insight, and you can mention your query ID, and you can get all the insights that how your query is working and do it needs any further performance improvements or not. Bytes spilled to storage. In Snowflake, when a virtual warehouse runs queries, okay, it first tries to process everything in memory, the fastest resource, right? But if operations, let's say, need more memory than the available memory, okay, then what happens? Then Snowflake spills data onto local SSD storage. Okay, and even if suppose that is also not enough, Jaswinder, then it relies on your remote storage in the cloud. It is going to third layer, okay, introducing more delays. This is known as bytes spilled to storage. Okay, whenever you are running a query, a very big query which will consume a big of memory, and if it is actually the work more than the memory you are having, then it first move your stuff to local SSDs, and if that is also not enough, it will immediately go to your remote SSDs. So this is the definition that bytes spilled in storage refers to the temporary data that virtual warehouse writes to disks, whether it's a local or remote. It writes to disk when it is out of memory. Okay, this is pretty much about bytes spilled to storage. So when the spilling happens, disk spilling is almost always about resource pressure. The data involved in operations like large order buys or group buy or sim joins simply doesn't fit in the memory. Major causes include is like large data operations, warehouse size. You are actually using a small warehouse size, but your load is way too much, so it actually overloads your virtual warehouse and it eventually leads to spilling out the data. Then concurrency, then suboptimal SQL. Okay, and you can identify the query experiencing spillage using the query profile. Okay, or even by querying account usage.query history view. And this is the image how it shows in the statistics. It will show below in the spilling that how many bytes are spilled to local storage and how many bytes it had spilled to remote storage. So this is again very helpful feature of query profile. You can see actually that how many data got spilled to your local and how many data got spilled to your remote, and that is a very big reason for your delayed results. Perfect. Now let's discuss about inefficient pruning. Inefficient pruning in Snowflake occurs when queries can too many micropartitions, often due to poor clustering, improper data types, or even a complex expressions in where clause. This causes high input output, increased query time, and higher cost. Okay, self-explanatory. Cool. So common causes and solution for poor pruning is weak clustering. Obviously, if you are not applying a proper clustering, Snowflake already applies, take ensures about everything, but there are some tables which we require to manage clustering as well. So if the clustering is weak, then obviously it will eventually go to inefficient pruning. And the solution is implement automating clustering on frequently filtered columns. Similarly, second common cause is unsupported filter expressions. Okay, and functions or expressions applied directly to filter columns prevent optimization. If you are having a where clause like applying a function to on a column in the where condition, then eventually it will prevent optimization process. But if you are having a direct query, it fastens the pruning process. Same way, subquery predicates query using where in select or not always prune efficiently, and always use join clauses or CTEs for better partition eliminations. Next is unsupported data types and frequent small updates in your table, which makes your pruning less effective. And this is how your query profile looks without pruning and with pruning. In the first image, you can see when there was no proper pruning happening, the query took 20 minutes to complete. But when there was a proper pruning happened for that query, it only took 1.7 seconds. You notice the massive difference between time? This is very important whenever you are working with Snowflake. Always monitor the query profile. If your query is taking more time than expected, always see what is happening. Okay, in this case, see here, the partitions scanned are equal to the total partitions. Inefficient pruning. This is very inefficient pruning. Exactly. But in this case, the partitions scanned are almost nil. It only scanned 4. Wow. Amazing. This is the benefit of pruning. This is the benefit of proper clustering and ensuring the process. This is the benefit of query profile. Now let's discuss about exploding joins. Exploding joins occurs when a join operation produces an unexpectedly or excessively large number of rows, far exceeding than even the input data size. This issue often leads to severe performance degradation, long-running queries, memory spillage, increased compute cost, potentially failures. Whenever you are doing a join condition, always ensure the condition is accurate. And the common causes for join explosions are missing or incomplete join conditions, duplicate values in join keys. That's a very common one. Non-equi joins. Non-equi joins are joins using range predicates like between or like are in a range. These kind of joins often require Snowflake to perform a Cartesian methodology internally before applying the filter, which can eventually lead to larger intermediate result sets, right? So this is obviously another region. And fourth is complex queries or flipped joins. Cool. Now let's talk about queuing. Queuing in Snowflake occurs when a virtual warehouse has insufficient compute resource to handle the volume of incoming queries, causing them to wait in, first out queue until capacity frees up. Okay. It is primarily caused by excessive concurrency or resource exhaustion resulting in higher latency. Okay, the solution is obviously multi-clustering warehouse and resizing your warehouse and query optimization. You can see the query history to optimize your poorly performing SQL queries. Cool. Now let's discuss about the another very important topic, that is account usage view. Here we will be discussing more about query attribution history view. This view tracks query specific cost. This allows users to accurately measure and analyze the resource consumption of their queries, enabling more effective cost management and optimization. Very important. Please take note of this thing. Why we need query attribution history? To analyze the resource consumption of queries. Cool. Query attribution history view in Snowflake is a valuable tool for gaining insights into the cost of individual queries executing within your account. It provides detailed information about the resource consumption of each query, enabling you to optimize performance, manage cost effectively. There are few important considerations. Whenever you are using query attribution history, keep in mind that latency will be up to 6 hours. The results might take up to 6 hours to reflect. The role requirement is minimum the user view database role you should be having. And the for short running queries which runs shorter than 100 milliseconds, these results might not be included in the view due to current limitation of per query cost attribution. Cool. Next is query history. This is also one important part of account usage. Query history you can see from Snowsite, you can see from information schema, and you can also have query history for account usage. Query history in information schema is real time and for shorter duration, and query history in account usage is for a longer time and 365 days. The retention of query history in information schema is 7 days, and for account usage it's 365 days, and in Snowsite it's 14 days. Similarly, it's a latency is real time, and it takes 45 minutes to 3 hours to actually reflect the changes, and it is a real time. And this is best for troubleshooting the current issues, and account usage query history is best for long term auditing and billing purposes, and this is just good for visualizing the query plans. Information schema uses these table functions for real-time monitoring of data queries from last 7 days. Note that these require the table keyword. So whenever you are going to write a query to get the query history, you need to use the table keyword. For example, this one, select star from table and then information schema dot query history with the bracket starting and bracket ending. Okay, this is really important. Okay, table keyword is used whenever you are actually going to query the query history table from information schema. Okay, and for account usage we had discussed that it is up to 1 year, and you can use the shared Snowflake shared databases, and this is the view, so it doesn't need the table command like in information schema. This is the table, query history is the table, but in account usage this is the view, so you can just quickly say select star from account usage dot query history to get your results. Okay, so this is the example for query history from account usage as well, where you can directly write the database name, schema name, and the view name, and you can get your results. Now there are top 5 views you must know. This is something very important. There are a lot of views in account usage schema, but you don't need to memorize all 100 plus views. First is query history. It tracks the every query run in the last year. It is used to find expensive queries or slow performance. Second is warehouse metering history. This is the billing view and it shows the credit consumption per hour per warehouse. Third is the login history. This is the security view and it tracks all the successful and failed logins. Fourth is the storage usage and it shows your data footprint, all your database stages and fail-safe storage for billing. Fifth and last is access history. It tracks which user accessed which specific columns and it is very crucial for data lineage purposes. Let's talk about the most important topic, that is query acceleration service. This diagram I had created to show you how query acceleration service helps. Before going into the definition and what it do and how it do, let's first understand why even I need the query acceleration service. What is the problem, Jaswinder, it is solving? I am already having a multi-cluster warehouse. I am already having a large warehouse. I can horizontal scale, I can vertical scale, I can use Gen 2 warehouses, I can use Snowpark optimized warehouse. After all of these things, you are saying there is a query acceleration service? What is this, Swinder? What is the problem that caused Snowflake to create this service? Cool. Let's discuss about that. When a statement is submitted to a warehouse, Snowflake allocates resources for execution the statement. That's true, right? If there are not enough resource available, what happens? There is an extra large warehouse, okay, and you submitted a job. And so Snowflake said, okay, I am going to execute that job. It started executing. Cool, that's fine. Okay, Jaswinder, we understood this. Okay. And what happened? This execution was very heavy and it is taking all the warehouse compute. What happens in this case? In this case, all other queries will get queued, right? One is even queuing, others are getting queued. Okay, Jaswinder, yeah, I agree. These are getting queued. But we can scale the warehouse, no? Yeah, you can scale it from extra large to 2x large. But suppose this query is very, very resource heavy. Then what will happen? That even 2x large won't be even helping any of these queued queries. By considering all these bottlenecks, Snowflake thought to create another service, which is query acceleration service. Query acceleration service plays a very critical role by bumping up additional database resource temporary to complete the query execution. Okay, it will say, okay, keep running. What I am doing, I am going to bump up additional database and I will, whatever this is queued, I will run this. Once these queued queries are complete, the additional resources are released. Query acceleration service is a serverless service and it is based on the scale factor which you will include whenever you are running a query. And once the query execution is over, resources are released automatically without any kind of manual intervention. Cool. So query acceleration service in Snowflake is a feature that improves the performance of large scan intensive queries by offloading portion of processing work to separate shared compute resource. This allows the primary warehouse to focus on other tasks and can significantly reduce the execution time of eligible queries without requiring a full warehouse resizing. Makes sense now? Cool. How it works? It works by automatic detection. So Snowflake's optimizer automatically analyzes a query plan at runtime to determine if the part of the query is even eligible for acceleration. If it is, then it will eventually spin that out. Second is offloading workload. If eligible, these portions are offloaded to dedicated query acceleration service serverless compute resources which process the data in parallel. Third is pay per use. This service is built separately as it is a serverless service. So you are only billed for the seconds you had used this service and you won't be billed further. Okay, no code changes. It integrates seamlessly with existing setups, require no change to SQL code or pipeline design. Enabling and configurations. We discussed about query execution service, but also we need to enable this service. It is not by default enabled. We can enable this whenever we are creating a warehouse, or we can even alter the warehouse to enable the service. Okay, and once we add enable, we can also control the cost with the scale factor, which is query acceleration max scale factor. And we have values here 2, 4, 8, and 16. Max is 16 and default is 8. This is very important from exam point of view. And this is the query which you can use to alter the warehouse for setting the query acceleration max scale factor sub of any value. This is the typical query profile when there is a query acceleration service is required for a process. If you see here in the statistics, you can see that scanned selected for acceleration is equal to 2. So whenever they was using warehouse, they had mentioned the size is equal to 2, and they had enabled the query acceleration service, which eventually helped them in reducing the time to only 59 seconds. And among all these 94,000 partitions, due to query acceleration service, only 13,000 partitions got scanned, and it eventually gives you result very, very quickly. Let's talk about search optimization service. But what is the problem which search optimization service is solving? Let's discuss about that. Let's say you have multi-terabyte table, okay, maybe logs, IoT events, or even transactional histories. You run a query, okay, you are running a query to find just a single transaction ID. You might be expecting it to be very instant, but what is happening? You are just waiting that your result will be coming out. Queries running, very painful, right? Despite Snowflake incredible micro partition pruning, the query scans 40% of your table. Okay, why? Because the data isn't it clustered by that random transaction ID, right? You're just searching for a transaction ID. So the needle is scattered across thousands of micro partitions, right? This is the exact problem the search optimization service was built to solve. It's a magic wand for everything, but for point lookups, it is really a blessings. You are just looking for a simple transaction ID in a bigger table. That's where you need the search optimization service. What the definition says, search optimization service is a feature designed to significantly improve the performance of specific highly selective queries, often referred to as point lookups or needle in the haystack. Note that, guys. Note that. This is the exam question. Okay. Cool. This is a syntax for optimization. You can set the search optimization on the table level. You need to do alter table name, add search optimization, and once you run this query, you are automatically search optimization enabled. Let's discuss about how it works. The service operates by creating and maintaining a persistent hidden data structure called search access path. This data structure is responsible for maintaining the data values within which partition is. Okay, this keeps path track of which data values reside within which micro partition. During a query, the optimizer uses this path to prune unnecessary micro partitions from the scan, dramatically reducing the amount of data read and speeding up the query. This is how it works. Okay, it creates a data structure which is known as search access path, and all the data resides within the micro partitions. It keeps track of that, and whenever you are running a query, the optimizer use this path to eliminate all the unnecessary micro partitions from the scan within seconds. Key features and benefits: improved query performance as usual, automatic maintenance, a background service automatically updates the search access path and its modify require no manual index management from the user. Third is broad data type support. Fourth is substring and text search. It can optimize queries using like, I like, R like, contains, and other regex functions, including full text searches with the search functions. Where we need to use this when service is most effective for queries that run for several seconds or longer. Highly selective filters that return a small number of rows, columns with a high number of distinct values, large tables that are not clustered and or are frequently queried on columns other than clustering keys. So this is the use case where you need to think about search optimization service. Now let's see this picture comparison. This is the first one where we are not having the search optimization service, and this is the second picture where we are having the search optimization service. As you can see below, the query profile below shows that it had to scan all the micro partitions to get the required results in 1.3 seconds. So it scanned everything to give me the results in 1.3 seconds. But if you see here, the query profile is running much faster using search optimization effectively and returning the results much faster. It only returned the results in 799 milliseconds. The same query without search optimization service took 1.3 seconds, and the same query with search optimization service only took 799 milliseconds. This is the major difference, and even it had scanned less number of partitions. In this case, it scanned 103 partitions, but in this case, it only scanned one. This is the biggest advantage of such optimization service. And when you see the most expensive node in first one, you will see table scan, and in second one you will see search optimization access. Again, query profile is very helpful here also. If you see, you can clearly visualize the differences between first image and second image using the query profile service. If I have to conclude the differences between search optimization service, query acceleration and clustering key, I will say the primary goal for search optimization service is to find the specific rows and get the results faster. And for query acceleration is scale compute for huge scans, and for clustering keys is organized data for pruning. Okay, so the effort requirement for you is low here because this is managed. Same way for effort required is medium because you need to set the scale factor in your warehouse. And for clustering key, the effort required is high. You need to think about which columns you need to have the clustering applied. Now let's discuss about Snowflake caching. So Snowflake is renowned for its architecture that separates storage and compute, right? But what truly supercharges its performance is its multi-layered caching mechanism. Okay, caching in Snowflake isn't it just about storing data? It's about intelligently reducing compute cost, boosting speed, and even enabling near real-time analytics. So in Snowflake caching, there are three core caches. First one is metadata cache, second is query result cache, and third is virtual warehouse cache. Result cache and metadata cache sits in cloud service layer. Very important to note. And only virtual warehouse cache sits in virtual warehouse layer. Now let's discuss about the metadata cache. Metadata cache in Snowflake is a system managed cache that stores file level and table level metadata. Okay. It only stores file level and table level metadata. It resides in the cloud service layer and is automatically populated and maintained by Snowflake. This cache includes metadata such as micropartition information, files location in cloud storage, row counts, null value indicators, column level min max values. How does it help? When a query is submitted, Snowflake first consults the metadata cache before even scanning any kind of actual data. Okay, it allows it to prune micropartitions. Okay, if the metadata shows that certain partitions are not relevant, so it skips those partitions quickly. Second is it's avoid unnecessary input output. Instead of scanning all the files, Snowflake reads only whatever is necessary. And it speeds up the query planning. Metadata helps Snowflake optimizer make intelligent decisions without even accessing any kind of data. Very important. Okay, the key benefits is performance boost, reduced cost. Okay, because you are not touching the storage, you are first going to metadata cache and checking the file level metadata to even see the partitions and prune the partitions even before touching the data. That's where the reduced cost is coming. Zero overhead. This is totally managed by Snowflake. No tuning or memory allocation you required to do anything here. Early filtering, always on and automatic. This is pretty much about metadata cache, and it is really very important for SnowPro exam point of view. Next is query result cache. Query result cache in Snowflake stores the final output of the query. the actual result set used to the user. When the exact query runs again, Snowflake serves the result directly from this cache, provided the certain conditions are met. It lives in the cloud service layer, which means no compute resource are involved when serving from this cache. Here, what Snowflake checks before using the query result cache, the text is identical, the user and role permissions are same, the underlying data has not changed. If the data is changed, this won't work. Okay, the query is running within 24 hours of last execution. Very, very, very important to note. The query is not using non-deterministic functions like current timestamp or UUID. If you are using these kind of functions, query result cache won't work. The key benefits is zero compute cost, instantaneous response, cost saving, no billing required. It's a BI tool optimization, and it is really great for dashboard for repeatedly running the same queries, and it reduces the load for reprocessing or freeing up the resources from other tasks. Third is virtual warehouse cache. Virtual warehouse cache is known as query cache within the virtual warehouse, is a compute level in memory cache that stores micro partitions recently read from remote storage during query execution. This cache resides within the virtual warehouse itself, which is compute engine running your SQL queries. When is it used? When a query accesses the table data, the warehouse fetches the data from storage. These data blocks are temporarily stored in memory on the local node of the virtual warehouse. Very important to note. If a subsequent query on the same warehouse accesses overlapping data, Snowflake can reuse the in-memory data instead of refetching it from the storage. This reduces input output latency and actually give a boost to performance. Okay. Please note that this query is ephemeral and it is lost if the virtual warehouse is either suspended or scaled up or down or even restarted. Okay. This is only limited until unless your virtual warehouse is up. Once it is suspended or it is scaled up or down or restarted, all your query result cache is gone. The key benefits are faster repeated queries. It reduces the time for running the subsequent queries on overlapping data sets, and it reduces the storage input output cost. It boosts the performance, and it is really great for batch jobs. This is the comparison table between metadata cache, query result cache, and virtual cache. So when it's come to location, metadata cache and query result cache sits in cloud service layer, but virtual cache sits in virtual warehouse. What it stores the file and table metadata, and the query result stores the final query results, and virtual warehouse cache stores the recently accessed table data in the memory. And it is used when the table scan is needed. It is used to rerun the same query, and when the same warehouse and same data is queried again, then virtual warehouse is used. Note this point. This is really important. Okay. It is valid if table hasn't changed. It is valid until the query role and underlying table hasn't changed. It is only valid unless the warehouse is running. Okay. Do you need compute for metadata cache and compute cache as it sits in cloud service layer? I don't need the compute, but virtual warehouse cache sits in virtual warehouse layer. So I do need the compute for that. Performance impact, it prunes the data scan. Okay. And query result, it skips the execution and it just speeds up the reruns. Persistence location, it varies because it is managed by Snowflake, and persistent duration in the query result cache is 24 hours by default, and for virtual warehouse it's as long as your warehouse is running. The biggest benefit type is reduced scan and faster results. The benefit is for query result cache, and the faster query execution is the benefit for virtual warehouse. It is best suited for any query involving large tables, And best then for query result, it is best suited for repeated queries, and for virtual warehouse, it is best suited for transformation heavy ETL workloads. Now let's discuss about virtual warehouses. So virtual warehouses are nothing just a compute engine. So if we go with the definition, that virtual warehouse, often referred to as a warehouse, is a cluster of compute resources. So virtual warehouses are available in two types: standard and Snowpark optimized. Okay, standard one is the normal regular virtual warehouse, and Snowpark optimized are the latest new addition. Snowflake recommends to use Snowpark optimized one for workloads that have large memory requirements, such as ML training use cases. Snowpark optimized warehouses let you configure the available resources and CPU architecture on a single node instance for your workloads. The default configuration for Snowpark optimized provides 16x memory per node. Okay, this is very important to remember, that Snowpark optimized by default provides 16 times more memory per node compared to the standard warehouse. So you can obviously optionally increase or add additional nodes and CPU as well using the create warehouse or alter warehouse property. And the following options are available in the Snowpark optimized one. If we talk about memory, so default one is 16x, which is 256 GB. If we talk about memory of up to 16 GB, the resource constraint value which we need to pass is memory 1x or either memory 1x x86. So this is the minimum warehouse support in the Snowpark optimized, and it is extra small. Same way we have medium and large. Aligning with the same, we have the resource constraints. This is a default one, and obviously you can increase or decrease, you can add additional ones as well. If we talk about the standard warehouses comes with two options. Okay, Gen 1 and Gen 2. Gen 1 is Snowflake Originals one, and it is industry standard for using the virtual warehouses. Gen 2 is the next generation warehouse. Okay, so in Gen 1 warehouse, the ratio of CPU to memory is fixed because it is designed for general SQL tasks. In Gen 2, Snowflake swaps out the virtual machines, okay, for instances that have more memory and faster SSDs. Okay, so this is the difference. Okay, so Gen 1, it's having a general memory to compute ratio, but if we talk about Gen 2, it is having a significant more memory and faster SSDs in order to process your queries. Snowflake universe, Gen 1 and Gen 2 generally refers to the evolution of virtual warehouse hardware and performance architecture, while Snowflake manages all the underlying infrastructure for you. Understanding these shifts are very, very important. Okay, so if we talk more about that, so you can alter a standard warehouse and specify a different generation clause or resource constraint based on your requirement. You can change it from Gen 1 to Gen 2 or Gen 2 to Gen 1, and you can change this whether the warehouse is running or whether the warehouse is suspended. So this is the general NVMe SSD Gen 2 uses to provide you more significant and faster query performances. In order to create a warehouse, that's the typical script we need, that create or replace warehouse with the warehouse name. And in the resource constraint, you can mention which kind of warehouse you want to create, either Gen 1, either Gen 2, or either you can also mention the resource constraint for Snowpark optimized one as well. Okay, and obviously the warehouse size is required when you are talking about Gen 1 and Gen 2 specifically. So you should mention the warehouse size as well. So this is a typical thing between Gen 1 and Gen 2 and what is Snowpark optimized compute. So Snowpark workloads, can be run on both standard and the Snowpark optimized warehouses. Okay, but Snowpark optimized warehouses are recommended for workloads that have large memory requirements. Difference between Gen 1 and Gen 2 workloads. So these are optimized for row and columnar SQL, and these are optimized for memory heavy objects. In Gen 1, we have high risk of remote spilling, okay, because of large kind of workloads. But in Gen 2, It is designed, actually to eliminate this remote disk spilling because of its significantly large RAM and faster SSDs, where it is highly unlikely that it gets remote spilling. So if I talk about concurrency, it is great for smaller queries and it is great for fewer massive and complex tasks. So obviously when it comes to cost, so it will be less costlier than this one, because it is obviously using higher compute and higher SSDs on the cloud. So it is almost charged double credits. So this is the pretty much about Gen 1, Gen 2 and Snowpark optimized warehouses. Let's discuss about scaling policies. Snowflake employs scaling policy as a feature of multi-cluster warehouses. So it is supported minimum with enterprise edition and it is running in auto scale mode. So these policies determine how quickly Snowflake adds or removes the cluster, okay, to manage your workload fluctuations and balance the performance, taking care of the cost. Snowflake offers two type of scaling policies. Okay, one is standard one and second is economy one. Standard one is performance optimized, if I say in very easy words, and economy one is cost optimized. Okay, so the difference here is that if there is a new user trying to query and query are getting queued, okay, so it immediately triggers or adds the additional clusters. But in comings to economy, okay, it don't add additional cluster instantly. It waits until it have the estimated workload for more than 6 minutes. Okay, so if we go with the definition, so this policy prioritize performance, okay, as we just discussed, by quickly starting new cluster when queries are queued or current resources are deemed insufficient. It's suitable for interactive workloads. New clusters are added quickly with a 20-second wait between adding additional clusters. So this is very important to remember. And clusters are shut down for a period of low activity, as usually Snowflake does. Now coming to economy one. So economy, obviously it is a cost optimized. It prioritizes cost by aiming to keep existing clusters and adding the new users into the queue. Okay, so potentially leading to the longer queues. Okay, so it's recommended for non-urgent background task. Okay, a new cluster is only started if there is a enough estimated workload for more than 6 minutes. So this is the difference between standard and optimized. Standard one is performance optimized and economy one is cost optimized. If you have a warehouse, you can obviously change the warehouse properties. That includes scaling policy as well. So you can change your scaling policy anytime you want without worrying about the cluster status. So now let's talk about the best practices which Snowflake recommends when it's come to sizing. Okay, we are talking about vertical scaling. So sizing refers to changing the size of the warehouse from extra small to large or extra large up to 6x large. So each step up doubles the compute power, okay, and the credit cost, obviously. If I talk about, the best practice, so best practice is always start small, use the extra small warehouse and monitor from the query history, okay, to check if the query is spilling to the disk overload. That's very, very, very important to remember. If you are seeing that your query spilling is happening, you need to increase the warehouse size. Okay, you can try from extra small to small then, and then you can again notice the query history and until it is not a query spillover. Cool. So scaling up, it is advised to do the scaling up when you are dealing with the complex queries. So if the queries are taking too long because it's processing massive data volumes, a large warehouse is recommended as it provides more memory and more threads. Okay, so scaling down is, if your warehouse load monitor chart shows a lot of white spaces, this means idle time. If queries finish in sub-seconds, you are likely over provisioned, so you need to scale down at that time. Okay, please note that you can resize a warehouse instantly with zero downtime even while queries are running. This is very important to remember. Cool. So let's talk about horizontal scaling. So scaling refers to adding more clusters or to the warehouse. So the best practice is to scale out for high concurrency. If there are a lot of concurrent users hitting the multiple queries, you need to ensure that your system is scaled out for them. So I had given the example that if you have 50 people opening a dashboard at 9 a.m., scaling up to a large won't help. Okay, you need to scale out by adding clusters so users don't have to wait in the queue. Scaling policies, I guess we had already discussed that one is standard and second is economy. Standard is performance optimized and economy is cost optimized. All right. So let's talk about the third one, which is auto suspend and auto resume. We need to set auto suspend for 60 seconds for all the processes which are ETL based and ad hoc query request. And we need to set the auto suspend for minimum 10 minutes for all the BI tools requirement. Cool. So this is written. You can obviously read the definitions. Auto resume, it's saying always keep this on. There is almost no reason, to manually manage warehouse starts. Let's start with micro partitions. If we have a journal discussion on micro partitions, although we don't explicitly specify partitions in Snowflake, all the data are automatically loaded into partitions. Okay, so this concept is known as micro partitions in Snowflake. So this is not something which we are doing. This is something which Snowflake is managing on its own. Whenever we are trying to load the data, automatically data is getting loaded into partitions. So this is the very cool stuff, and it is Snowflake, managed. This is not something which we are doing, right? This is something which Snowflake does automatically for us, right? Okay. So micro partitions, if I say, it's a contiguous unit of storage in Snowflake. All the tables, all the tables, okay, are automatically divided into micro partitions. If I just talk about the size, okay, each micro partition can be of roughly 50 to 500 MB of data. Okay, but that data is in uncompressed form. Okay, this is very important to note. This is further compressed, okay, during loading. So whenever you are going to load the data, it compresses the data. Okay, the coolest part is tables are also, transparently partitioned, okay, using the ordering of data as it, inserted or loaded. So this is pretty cool feature of Snowflake, and it is totally Snowflake managed. We don't need to worry about. So it won't be surprising to say that, a table in Snowflake can easily have millions of partitions. What Snowflake says is, in Snowflake, all the data are automatically loaded into partitions called micro partitions. Each micro partition contain 50 to 500 MB of data. Right? We just discussed that. So this is really important to note that each partition contains 50 to 500 MB of uncompressed format and organized in a columnar fashion. Cool. So Snowflake maintains the metadata of each micropartition, such as the range of the values by which it gets to know that which partition it needs to search. Okay. The second is the number of distinct values. This is something which it stores and maintains as the metadata. Okay. Third is additional properties used for both optimization and efficient query processing. Micropartition is automatically performed on all Snowflake table. We had already discussed that. And tables are transparently partitioned using the ordering of data as it is inserted. Note that. Please note that, guys. This is really important. There is higher chances that you will get a micro partition question in your exam. All the tables are automatically transparently partitioned using the data ordering. Cool. So this is known as natural clustering of table. Okay, so this is the example. If you say this is a row based column storage where we have employee ID, employee name, salary, and department ID and the data. And when it's getting transferred into the Snowflake, how it's getting transferred? It is micro partitioning and here you see it is storing in the columnar format. Employee ID, employee name, salary, department is coming as a row, and whole entity is becoming a column. Cool. So this is how micro partitions work, and it is actually very transforming and very, life changing for all the businesses. Okay, what are the benefits of micro partitions? So major benefit is, Snowflake micro partitions are automatically derived, that you don't need to define any micro partitions. These are automatically derived by Snowflake, so you don't need to worry about maintenance and all those things. Second point is micro partitions are small in size, 50 to 500 MB size before compression, and which is extremely efficient for DML and fine grained pruning for faster queries. Cool. So micro partitions can overlap in their range of values. Columns are stored independently within micro partitions. Note that, guys. This is known as columnar storage. This is the process which makes that efficient scanning possible, and we are able to prune the data. Okay. So this is very, very important. Next is columns are also compressed individually. One thing is columns are stored independently. Second is columns are also compressed individually. Okay. So this is very, very, very efficient way to store the data. The micro partition metadata maintained by Snowflake enables precise pruning of the columns. Okay. So if a table have 100 columns and you only need data of, let's say, 5 columns. So by default, using the metadata, it will prune other 95 columns and it will directly go to those 5 columns. So how fast it will be? It will be very, very, very fast. Cool. So this is the biggest benefits of micro partition. Please take notes, guys. I'm repeating it multiple times. This is a very important topic to understand. Cool. So let's come to table clustering now. Before going into what Snowflake documentation says about table clustering, let's have a general discussion. Okay. So what might be the table clustering? It's a data pruning process. When you hit a where condition, based on the clusterings, okay, it prunes the data and it retrieves the data very fast because it already had skipped non-required data and it is only going and fetching the required data. Cool. So let's see what Snowflake says. So the table clustering is a process of physically organizing table data within its micro partitions to align with specific column values. Okay. How it works: Snowflake automatically stores data in encrypted cloud optimized micro partitions. Okay, that is also we had discussed. Okay, so natural clustering: when we load the data, Snowflake naturally clusters it order by it arrives. As soon as the data arrives, automatically Snowflake do clustering as well. Okay, so this is again the coolest feature. Next is, what's the problem when Snowflake automatically do the clustering? There is no problem in a normal scenario, but let's suppose there is a table which is having terabytes of data. Okay, so over time, as the data is deleted, updated, or merged, the natural orders breaks down. That's normal thing, right? It makes sense that it will break down. This might leads to data skewness, where the specific range of values is scattered across thousands of micro partitions. If the table is small, okay, then do you think this problem will exist? No, right? This problem won't be existing. But if the table is of terabytes, now you are updating it, you are deleting it, you are merging something on this. The natural ordering actually breaks down at a very large scale. Okay, and this actually leads to data skewness, that you are seeing that in a single partitioning you are having only one record, in other we are having suppose 10 records. So it is a big overhead. Sometimes Snowflake does his work naturally, but when it's come to big tables, then data gets distributed across millions of micro partitions, and it becomes overhead. Okay, so that's the problem why we need to actually do table clustering. Sometimes it is not every time. The solution is clustering allows you to define the clustering key, which we had already discussed. One or more column we can use to collocate the related data. Cool. So when to use, this is very important. Although Snowflake default natural clustering is incredibly efficient for most small to medium data sets, Snowflake still recommends you to do clustering, which is known as manual clustering, only if the table is multi terabytes in size. Okay, multi terabytes in size. This is really important to note. Only do clustering when the table is in multi terabytes, when the query performance is noticeably degraded. Earlier you were seeing that query was running fine, but now today if you are running the same query, it is very slow. That actually will be the biggest indicator that you need to define clustering on your table. And if the clustering depth is consistently high, okay, if the depth is too much high, for most frequent filter columns, then obviously you need to apply clustering. Cool. So what is clustering depth, Jasminder? We understand that if the table is in multi terabyte size, we need to do clustering. Okay, we will do that. Okay, we will run our queries in Snowflake, and if our query is degraded over time and we are seeing that the query is long running, earlier it was a very quick, obviously we understood that point as well, Jaswinder, that yeah, we will think about the clustering. Cool. But what is this clustering depth? What is this depth? Let's talk in a very easy way. Okay, clustering depth is nothing. Okay, it's actually nothing. It's just a numeric matrix, okay, that just represents how how well organized a table data is across the micropartition. It's just a numeric value. Okay, it just represents that how well your data is. Okay, so lower the clustering depth is, okay, better the table is. Jasminder, then how we will find that it is having the lowest clustering depth or the highest clustering depth? How we will do that? So in order to do that, we have a Snowflake function, okay, clustering depth function. You can type on you can go to Snowflake documentation and get that function and run on your system, and you will be getting a clustering depth. Okay, if it is a 1, for most of the tables it will be 1. You are already in a good shape. You don't need to do anything. But if it is, let's say, 5 or 4 or 6, then you require to think about the table clustering as well. Cool. So now you understood. So clustering depth is nothing. It's just a metric representation. Okay. That how well table data is stored. Okay. So simply lower the clustering depth, better the table. What Snowflake says about clustering depth. Okay. So if you see this image, this is the clustering depth. Okay. If you see 1, 2, 3, 5, these are the numbers which is given. Cool. This is the level 1 of clustering depth and most ideal one. Okay. So if the clustering depth is 1, this is a really good scenario. Cool. So if you see here, A to D columns are here, E to J are here, K to N are here. So in a very generic way, no data is overlapping, right? Now let's go to clustering depth if it is 2. See, data started overlapping. Cool. Okay, this extent I am okay. With this extent I am okay. I will not apply the clustering. It's fine because a very minimal amount of data is overlapping for me. So I am still good. But now what about this, Jaswinder? And this one, everything is overlapping. In this case, I do require to reconsider my decision of not applying clustering on the tables. I need to go back and apply the clustering on the tables, right? This is very important for me. So this is how clustering depth works and how you can identify that your table actually requires clustering or not. Cool. 90% cases you don't require, but you know the three major cases when you actually requires to apply clustering on your table. Snowflake documentation is saying clustering depth for a populated table measures the average depth. Okay, we understand that, Jaswinder. Of overlapping micropartition. Okay, that is also understandable for specified in the column. The smaller the average depth, the better the cluster table is with regards to specific column. Resource monitors track credit uses by virtual warehouse and their supporting cloud services. The three actions which Snowflake perform is notify, suspend, and suspend immediate. Notify is just to send an alert to all the account admins that hey, you had used 70% of your today's compute or like that. Suspend is stops the warehouse for taking new queries but allows current running queries to finish. Okay, whenever there is currently running queries, it will finish. Just don't allow the future queries to spin. And suspend immediate is doesn't matter even if your query is running at the moment or about the new query, it immediately shut down the warehouse. Next is warehouse monitoring metrics. The exam often asks how to measure performance versus cost. You should know these key views in the Snowflake account usage schema. The first is warehouse metering history. It is best for cost. It shows exactly how many credits each warehouse had consumed by the hour. And second most important view is query history. It's best for granular performance. It shows the execution time, queued time, byte scanned for the individual queries. Third is warehouse load history. It is best for concurrency and it shows if the queries are even running or how many are in queued and what is the provisioning state for the queries. Okay, and the importance in resource monitor to remember is that reset frequency. Monitor can reset even daily or weekly. Monthly is the default setting. Please note that. And you can set based on your requirement. Second is role required. Only account admin role can create resource monitors by default. Okay, no other role can create resource monitors. Okay, next is cloud services. Resource monitor can track cloud service usage but only trigger suspension based on warehouse usage. Okay, fourth is grace period. So credit usage resets to 0 at 12 a.m. UTC on scheduled reset day regardless of your time zone. Next is calculating virtual warehouse credit usage. There are couple of rules. The first rule here is the per second billing rule. Snowflake bills for warehouse usage by a second, but there is a catch. There is a 60-second minimum every time a warehouse starts or resized to a larger size. This is very important to note. Please note this line that there is 60-second minimum. It will charge you for at least 60-second minimum whenever it starts or it is resized. For example, if you run a query for 10 seconds and then the warehouse shuts down, you are billed for 60 seconds. Okay, not 10 seconds. You are not going to get billed for 10 seconds. You are getting billed for 60 seconds. But if you run it, let's say for 65 seconds, if the query is running for 65 seconds, then you are billed for exactly 65 seconds. This is per second billing rule. Second is the T size multiplier. All the virtual warehouses are T size multipliers. If you are talking about extra small, the credit per usage is 1. And if you talk about small credits is 2. Every other warehouse up to 6x large will only multiply by 2. Medium, if you see 2 multiply by 2, 4. Large is 4 multiplied by 2 is 8. Similarly, 16, 32, 64 and so on. This is warehouses are always T size multipliers. Third is the addition rule. This is known as multi-cluster warehousing rule. So if you are using multi-cluster warehouses, the math is very simple to calculate how many total credits you have consumed. That is credit for size multiplied by number of clusters running. If you have a medium 4 credit per hour warehouse and it scales to let's say 3 clusters for an hour, you are going to get billed for 12 credits now. Okay, because This is the 4 credit per hour and you had scaled out to 3 clusters. So you will be getting billed now for 12 credits per hour. Okay, this is the multi-cluster warehouse rule. Fourth rule is the cloud service free tier rule. So Snowflake charge for cloud service, but only they charge if they exceed 10% of your daily warehouse usage. Let's see now alerts and notifications. You can use Snowflake alerts to send notifications and perform actions automatically. In SQL, you can send a notification to an email address or queue by calling a built-in store procedure. And there are two major store procedures. First is system $send email, and second is system $send Snowflake notification. And system $send Snowflake notification is a very vast and very in detailed one. Okay, Snowflake alerts if you need to send a notification or perform action when the data in Snowflake meets certain conditions, you can set up Snowflake alerts. Similarly, notification, you can configure Snowflake notifications, okay, using Snowpipe and task, okay, and you can use a SQL statement to send a notification to any email address or cloud provider queues like SNS or event grid. Now let's talk about logging and tracing. Snowflake provides built-in capabilities for logging and tracing applications, which consolidate data into central event tables for analysis and monitoring. Event table is a specialized table with a predefined schema designed to store, logs, traces, metrics for you guys. Every Snowflake account, comes with the default event table. Okay, and let me show you that. Event table is present in Snowflake database under telemetry schema, and the table name is obviously events. Let me query that table and show you. This is the default table which is present in Snowflake. This framework based on open telemetry standard. Okay, what is open telemetry standard? So open telemetry is just a open source framework for cloud native softwares. Okay, it just provide a single set of API libraries, and you can say agents to capture distributed traces and metrics for your application. So this is a very much open source framework and is available for code written in Python, Java, Scala, JavaScript, and Snowflake scripting. Cool. So the key components here is event table. We had already discussed that. That is a special and predefined table in your account where all log messages and trace events are automatically collected. Okay, an account can have only one active event table at a time, and we have seen that and it is present in Snowflake database. And second is telemetry levels. You control the verbosity of collected data by setting the log level and trace level parameters here, and these can set at account, database, even session level, with more verbose level taking precedence. And third and last key component here in logging and tracing in APIs, developer can use language specific APIs to handle their codes and to omit the log messages and trace events. And with that, we had officially wrapped up domain 4, which also brings us to the very end of our complete Snowflake SnowPro Advanced Architect tutorial. If you had made it all the way here, give yourself a massive round of applause. Mastering advanced Snowflake architecture is no small feat, and you have put in the real work to get here. Now that the core tutorials are done, what are your next steps to absolutely crush this exam? I have 3 things for you. First, take mock test, get used to the question formats and time management. Second, do hands-on practice. Don't just watch, build, break, and optimize as much as you can. And third is deep dive into documentation. If any concept feels a bit fuzzy, head straight to the official documentation to fill in those gaps. To make things easier for your preparation, I have uploaded the complete PPT and all the SQL hands-on script files to my GitHub repo. You can grab them right now. The link is sitting right down here in the description. If you hit a roadblock or you have any doubts while studying, you don't have to figure it out alone. You can drop a comment right below this video join our community on Telegram for quick chats, or if you want a personalized one-on-one strategy or doubt clearing session, you can book a slot with me on topmate.io. All of those links are waiting for you in the description box below. Before you go, I want to know what certification tutorials do you want me to cover next on the channel. Let me know your thoughts in the comment section. Thank you so much for sticking around through this entire series. Thank you for your support. Happy learning and have an absolutely fantastic day ahead. See you. Bye bye.